All right, so we'll be talking about system administration these slides, and we see that what is system. When we talk about system, which means our Linux machine, and how do you manage the Linux machine storage, partitions, and devices. So those are the things which comes under the administration part, and we'll be talking about what is a disk and what is a partition in this. So as you may all have seen in Windows, C drive, D drive, E drive. So those are nothing but the partitions of your hard drive. So let's say there is one hard drive which is of 500 GB, and then you have seen so far there are multiple sub drives that you can create, for example C, D and E drives. So if you look at in this image of PPT, it is describing about the partitioning and the file systems in Linux. If somebody asks you how many partitions you can create in Linux, so the answer is 4. Okay, but you must be thinking, how can it be 4? I have seen multiple more than 4 partitions, then why is it not more than 4? So overall partitions in Linux can be maximum of 4, but now there is a trick is what kind of a partition it is. So if we talk about that in detail, so in Linux we can create 4 primary partitions. So let's say this is your hard drive. Okay, and in the hard drive you create partitions. Okay, if you are having primary partitions, so you can have 4 primary partitions. Okay, this is one way of doing it. Or you can have let's say 1 primary partition and 3 extended partition, which represents by E. Okay, so why I said 4 is because maximum of 4 partition it can create, but under the hood, if we talk about in the extended partitions, so in the extended partitions we can see that you can create multiple more partitions. You can create more partitions like logical partitions you can create, which are called LVMs. We'll be creating shortly in this demo session. So in the extended partition you can create multiple partitions. That's the reason you can always have multiple partitions and create more than 4, but overall if somebody asks you, then a partition can be 4, maximum is partition 4. So if you create 4 primary partition, let's say for example if we talk about in the Linux machine, let's say if you have a drive of 500 GB, okay, in that 500 GB of drive, if you create 4 partition of 100 GB, 4 primary partition, let's say if you create 4 primary partition 100 GB, then 100 GB will no longer be used anytime later in the future, which means it will be left out like this. So the reason being, we chose to create primary partition. So if you create primary partition, then all these 400 GB will be used, but not the remaining 100 GB. So it's always suggestible that whenever you create a partitions in your hard drive in Linux machine, you should always create 3 primary partitions, okay, and then 1 extended partition. Extended partition means you can further extend those partitions. That's why they are being called extended partition. You can further create more partitions to it, and that's how you can create extended partitions. So that is about how do you basically create the partition. So when we look in the partition table, so the first 2048 sectors of your partition table, that is being always be blocked for certain use cases, like where it stores the inode numbers, it stores the metadata of your files. And now in the modern environment, there are modern partitioning systems and stuff which supports that 4 KB partitioning metadata kind of a stuff, which always requires that amount of sectors, the initial sectors of your partition to be left out. So in this example, you are seeing a hard drive of 10 GB, and there is 2048 sectors. We'll be talking about what sectors is. It's kind of, you can think like the minimum value parameter to measure any hard drives in the form of sectors. So it's like you have a hard drive. Let's say for example you have a hard drive, and then hard drive is like this. So it starts from, let's say, sector number 0, then it goes to, let's say, 1000, then 2000, and then let's say for so and so stuff. But this sector from 0 to 1000 contains certain MB of data. And how much is it? So number of sectors. So if you want to calculate the size of it, so you have to do sector multiply then one sector size, which is 500 MB. 512. So if you multiply this, then you will get 500k. So this much size of 0 to 1000 sectors are being defined. So that is, there is a formula to calculate the size. So it's always be calculated in the form of sectors. That's how Linux file system partitioning understands. So the initial 2048, you see this, it is reserved for the metadata and inode numbers. Then remaining, there are 3 primary partitions created, 1 GB, and the remaining, the last one, extended partition created, which is of 7 GB. So in that further 7 GB, there are you see, you can maximum up to 60 partitions can create inside extended partitions. You can create further more. So in total, if we calculate, so 63 partitions we can create in the hard disk. So, and we will be talking about the commands which are required to see the partition table, which are required for mounting a partition, and how to create a partition, what kind of a partition. If you want to format a partition, how do you do that? What kind of a formatting mechanisms are available to format the partition? So we will see all these things in the hands-on part. So there are a few commands. Basically, it is talking about how to partitioning the disk. You can see there is a command called fdisk command, basically, which is used to discuss about the partitioning tables and all. So let's go the demo thing, and we will see how does it look. So for this demo, in my parallel desktop, what I've done is to this client machine, I have created one more hard disk so that I can show the demo for logical partitions and stuff. So there is one hard disk which is of 64 GB already allotted. There is one more I have created just for the demo, so that we will be seeing the partition here, which is of 5 GB. Okay, so now that 5 GB is nothing but SDB1. So if you remember, we discussed in the file hierarchy systems where all the device type files are mostly being stored under /dev. So similarly, like this, if you look at this, so SDB is also a block type file, which is a device file. It's a block, which means it's a sectors, hard disk and something. So SDB is what we created for 5 GB, and SDA is 64 GB by default created while booting up this machine. So we will be testing out on the SDB and see stuff. So the command to check the partition table is df command. So you want to see the file system, so df is just to describe or display the file system for you. So let's understand what it is actually trying to tell. So this is the file system that is currently available on my machine. This is the size of that file system. Each and every size you can see. SDA 262 GB out of 64 GB. SDA1 is 1.1 GB. So if you calculate, it's roughly around 64 GB. Then SDB1, which is there, I have created is 435 MB, and there is one more logical partition being created of 1 GB. Okay, and this much is used percentage. This much is used size of the partition. Then this much is available partition. This is an MB. K stands for KB, and G stands for gigabytes. Then percentages of use case, how much is used. You can see the percentage here in the file system, and the mounted, where it is mounted. So when I say mounted, what does it mean by that? Mounted means you are making the partition accessible. So how do you make it accessible? You mount it on some of the directories. If you don't mount it, the partition will no longer be used. It's unable to actually access it. So what does it actually? So if you remember, when you in the day-to-day basis, when you try to connect your USB drive or pen drive, right, in your system, you see there is another folder of USB automatically being created. So that folder is nothing but mounting. So it has mounted successfully on your file system, and that's why you are able to access the entire partition size or entire size of your pen drive and external hard drives. So that's how mounting is very much required. Without mounting, you will not be able to access the partition. So currently, if you notice, for SDB1, SDB partition, which is of 5 GB, we are only using 1.5 GB of it. So this 5 GB I am talking about, we are only using 500 MB in the first partition layer, and then another in the logical volumes, that 1 GB. But the remaining 3.5 GB is still left out, but it's not showing up in the partition table. Reason being, it is either not formatted, or not been used or not been mounted yet. So that is the reason you are seeing that left out and not being used, and it does not show up also in the partition. Uh, and if you look at like this lsblk command shows you a little more detail about in the tree structure. So if you look at this sdb, which is of 5 GB, but currently we are using these two partitions, sdb1 and sdb2. One is of this much and sdb2 is of 4.5 GB. But from this 4.5 GB we are only using as a logical volume of 1 GB. So that is the reason you are unable to see this remaining 3.5 GB, because it is not been used. It is there, but you can create more logical volumes out of it, but you will not be able to see it until you mount it. So lsblk command, you can note, this command will show you in detail the tree structure format of major number and minor number, and size and read only partitions or something. So, and mounted on which folder it is mounted. So that's what it is telling. So that is the df command actually. If you want to see df home, so it will show you that this home directory where all the users home directory is present. So this is basically coming from original file system, which is sda2, and 1k block, it is this much block and this much is it's used. If you want it to be human readable format, better to add option -h. -h basically gives you human readable format, so you can see and read more easily. Out of 62 GB, used is 8.7 and then available is 50 GB. So currently it is using 15% of your file system. Okay, right. Now how do you measure the directory file storage? Disk file df command will show you. Directory usage you can use with the help of du command. So du-sh, let's say I want to see this home directory, this directory home parallels, how much storage it uses, which is 129 MB. So du command will help you to display the disk usage here, and df command will help you to display the file system usage there. Okay. Then there is a command called mount command, which only works with sudo. So for example, if you want to mount any partition, so let's say there is a partition called as tb3. Suppose there is a partition and you want to mount it to a directory. So I want to mount it to /mnt. I can mount it like this. Currently this partition is not created. That's the reason it's saying that does not exist. If it would have exist, then it would directly be mounted to me /mnt directory. Okay, so /mnt is nothing but a directory here. So /mnt, if you look at the dot present directory, it's a directory type file. Okay, so that's how it is basically showing up the mount. Okay. Now there are two directories you see inside /mnt where we have mounted some of our partition. For example, in df-h, if you look at /mnt primary partition is a folder, which is what is storing this, and /mnt my disk is storing this logical volume. Okay, so that is how you can see. And then similarly, sudo umount, you can unmount any of your disk if you want to unmount it. So let's say if I'm unmounting sudo this mnt my disk and I execute and then I see df-h, I no longer see this mounting file system. Okay, so mount -a command, what it does is it basically remount it, whatever the mounting configurations are being written. There is a file called etc fstep. It's very important file, you should make a note of it, that this file is very important. Whenever our Linux system boot up, it reads this file, and this file tells about the listage of the partition that you would want to mount and where do you want to mount and what file format you would want to mount. So this was the label for lbm, and this was mounting on this mnt my disk, which is unmounted earlier when I executed new mount command. But after mount -a remount, this command reads this file. So whatever the entries will be present inside etc fs tab, it will automatically mount those directories or file systems. Okay, so that is the mount command. What if you want to scan the file system? So you can run fsck and then file system, let's say sdb1. I will not execute it because if you scan the file system, it basically tries to checks the metadatas and stuff, so which is not recommended until you. So there are proper steps when we will be creating the partitions. That time we'll be discussing when to use this command, because this will check the partition and will make sure the sectors are properly appropriate and metadata is stored in the properly manner. So it's always recommendable to unmount the partition first, and then whenever you shrink or increase the partition size, that time you have to do this fsck. And if you want to forcefully do this fsck, there is an option called -y, which will force check your partition table. So that is how you can use fsck command. So far we discussed about df command, which will be useful for the partition table file system checks. File system, if you want to see the more information. Du command is for the directory usage. Then mount command is to mount the file system on a directory or device, whatever you want to mount on. And umount command to unmount the file system, the partition that you have created. If you want to unmount it from your file system, then you can execute umount command. And to repair the file system, fsck command is the important command, which basically repairs, or it basically checks the file system, it scans the file system, and if there are any bad sectors, it tries to check and recover those and correct those as well. So that's how it uses. Now let's talk about partition and let's do some hands-on sessions as well. So lsblk command we have already shown up, where it will list out all the partitions to you in the proper tree structure manner. Now let's see if you try to create a disk. So let's say if I say this fdisk command. So fdisk command you are trying to create. So it's a welcome to fdisk. So it's currently in use. Repartitioning is probably bad idea. So it's already indicating to you, saying that this partition is already being used. Okay, so please do not touch it, otherwise there might be some issues or something can happen. So let's do one thing. We will do this, that we will switch off this machine, and then we will add one more partition so that we can play around with it, not to touch this partition. So I'll just say shutdown. Okay, so this changes you can only do if your machine is in shutdown mode. So let me add one more hard drive, and let's create a new image, and let's see 3 GB we are adding up. Okay, and then say okay. So there is one more disk of 3 GB created, and now let's start our machine. See how quickly the machine reboots, the Linux machine reboots, and you can see it. That's where the configurations, it's telling what all services it is reading from reload configurations or enable configurations, and then fs tab and so stuff. So our system is booted. Let's log in. Okay, let's zoom it a bit. Right. Okay, so now let's see lsblk. So now you see this SDC is already created and showing up in my table, partition table, right? So which is not being currently used. It's free to use. Okay, so it's 3 GB. So now let's try to do fdisk/dev/sdc. Okay, we have to use this via sudo. Now if you see, there is no more warnings has shown up now. The reason being, this partition was never being used. It was not mounted to any of the file systems. That's the reason it is not showing you any type of warnings. Otherwise, it shows the warning saying that please don't touch this partition. Otherwise, the data, whatever you have put up into this storage, there are chances that it could corrupt. So that's why you should always avoid, do the proper method, do the proper following, whatever is required in order to unmount the partition and then recreate the partition or shrink the partition or extend the partition. Since there is no warnings coming up, we are good to go. So let's try to see what helps we can see. It tells. So there are a lot of commands that we can execute. Delete a partition, add a new partition, and print the partition table. Let's say pre. When I say P, which means it is printing the partition table for me, 3 GB. See, here is a unit of the partition that I was talking about, the sector of 1. So one sector is always be 512 bytes. So you should always remember this. If you calculate the total number of sectors, so you can just calculate based on the size and divide by 512. To this, you will get the number of sectors which are available in this 3 GB of hard drives. So that's how you should calculate it. Okay, now so there is no more further partitions created. We are good to proceed with creating a new partition. So now it's asking you to create which type of partition you want to create. You want to create a primary partition or extended partition. See, I'll tell you this, you should always have a primary partition. If you directly try to create an extended partition where you don't have any primary partition, there are chances that it will not allow you to do that. So you should always have 3 primary partition, and after that you can have extended partition, or you can have at least 1 primary and then 3 extended partitions. So, but it's recommended ways having 3 primary partitions and then have 1 extended partitions. Otherwise, like based on the use cases, you can create take the references and create. So we will be creating the primary partition here. So that's why I'm pressing P. So primary partition, what is the partition number you want to give? Let's say I want to give 1, default 1. Here is the thing. So default, it is taking sectors from 2048 only. Why is it not choosing the sector from 0? As we already seen in the PPT, 2048 sectors are required in order to make sure the file metadata and inode numbers are being saved. So this is used to align the 4K sector devices. So there are some devices which are aligned to 4KB sectors, and that's what this 2048 is being used. And being always blocked, you cannot touch that initial 2048 sectors. Also, it is good to have a compatibility with the bootloader of your machine. Bootloader means a loader which basically loads the OS. So without bootloader, the OS cannot be loaded, right? For example, Grub is one of it, Grub 2 is another one of it. So those are the bootloaders which basically loads the OS. So to make a compatibility with the bootloaders, it has to have this 2048 sectors to be required. After that, these are the sectors reserved for the metadata and inode numbers that we have already discussed. And so it's always good to have left out this much partition for increasing the performance and the optimization in terms of performance of your OS or of your disk, whatever you are going to create. So I'll say default is 2048. It starts taking sector from 2048 and then create it. So you can either give the sector number or you can give like the size. You are saying KB, MB, GB, terabyte, petabytes and stuff. So let's say I would want to say 500 MB. Okay, it's not taking, no worries. So let's say 500, let's say 1 GB. Okay, it's out of range. Value out of range. We will be, say, okay. So now you have to create by adding this plus. Reason being, this is like how much adding you are doing on top of 2048. So it will automatically create the number of sectors for you, and then it will allocate those sectors, how much the partition size you would want. So you should always have plus 500. So which means that on top of 2048 sectors, allot the sectors, number of sectors which will be coming up in the 500 MB. So, and minus would be to reduce that. So plus is to just to allot more sizes. So we have created one partition which is of 500 MB, and it is showing up to you. If you say P, it will print the table. Okay, so now you have /dev/SDC1. So this is one partition that you have created from SDC drive. Okay, so it says that it is automatically calculate the number of sectors it is going to end. So inside 512 MB, this much sectors is required, and that's how the partition is being partitioned like this. And if you want to save it, you can just press W, and then it will save it for you. And one more thing is, this ID and type is Linux because we have created a primary partition. That's why it is showing this ID. So now let's run this command, lsblk. So it says from the SDC, which is 3 GB, we have created a partition SDC1, which is of 500 MB. Okay, so this is the partition that we have created. So for the disk, you will always see here the disk. Okay, for the partition, you will always see this partition part, which represents the partition. And currently we have not mounted this partition. That's why you are not seeing anything in the mount points. But if you look at this one, you are seeing the mount point, right? But for this one, there is no mount point. Now we are going to format the partition and then mount the partition to a respective file systems. So how do you do that? So let's try to execute this. Let's do one more thing. Let's refresh the kernel table, partition table. So there is a command called part probe, which basically refresh the kernel partition table for you. So this will update whatever the changes that we have done so far. We have created a partition called SDC1, and that we are going to update in that kernel partition table. Now let's use this command for creating partitions. So there are few commands people use it. Parted command is one of it, which is basically used for the GPT types partition tables, which is kind of larger disks if you want to create in petabytes and zettabytes. So those are recommended to create parted command. You can use that. Also in this thing we will be using mkfs. So let's see, mkfs. I'll be formatting this using mkfs.ext4. ext4 is the format type. For Windows OS, if you look at the formats type, the format type is either FAT32, FAT64 or NTFS. So any pen drive which is formatted with NTFS or FAT32 or FAT62 will not be detectable in the Mac, because Mac OS or Linux OS does not understand that partition formatting. So if it does not understand the partition formatting, it will not allow you to access that hard drive, or you will not be able to access the content inside it. So sometimes you might have seen issues where you are connecting the pen drive which is formatted in the Windows format systems, let's say NTFS, and you're trying to connect to the Ubuntu system, which is a Linux based OS. So their formatting structure is totally different. So what is the best solution? Either you should use a Windows machine to detect their pen drive, or you should format that pen drive. So, but if you format the pen drive, the data will be gone. So that's how it is. That's how the Linux understands the file system. So it has to be compatible to that format in order to understand. Or you can look for some other tools which supports that file system to be formatted on the Linux machine. Then you can go for as a solution to this. So now let's format this /dev SDC1. Okay. So now it says that mke-e2fs. Okay, this is the mkfs command. It's allotted this UUID, which is a unique identifier. Superblocks backup, it has taken the backup of your superblocks. This much is required, whatever the backup was there, and then it is basically writing the superblocks and file system. So basically kernel is doing its own job in order to format the file system. There is a way to format it. It's kind of a very huge topic to discuss about, like how does this formatting work, what is a super block, and how do you store the backups. So that is kind of a detailed sessions. But in this we will be seeing that at least how does this partitioning happens, how do we format it actually. So it is taking the step by step, allotted the identifier IDs and super blocks and backups and so stuff. So those are the things when you format the file system, it stores it. What if you want to format it? Let's say mkfs NTFS is one of formatting type. to format it via NTFS, or XFS is another format, or ext2, ext3, which are the older formatting systems. So the differences between, if we talk about, right, so between each of the formatting style is different, because some of the styles has more inode numbers and more way, and more directories you can create and stuff. So their limitations are keep on increasing, their limits are keep on increasing with the formatting styles. So with the ext2 has limited inode numbers lesser than ext4 and XFS. So XFS is like far better than ext2, ext3 and ext4. So, and then yeah, so that's how the formatting types are being used, and that's how they format the disk. So for FAT32 you can use mkfs.vfat, so which will be formatting your disk into a FAT32 type, STC1. Let's say if I try this, it says permission denied. Let's use this. Okay, currently I formatted is with this. Okay, so you can format any, since we have not yet mounted, so you can format any way you want to format. So mkfs, let's say if I format xfs /dev/sdc1 sudo, then it will format this way. It says appear to be existing file system vfat. Use this option to override. So you can use option, since it is already formatted with vfat, so you have to use this option to format it with xfs. So once we do this, it's basically formatting it the way it should supposed to format. So every formatting style has its own mechanisms under the hood which it used to format the device. So once you format the device, you can label the device also if you want to. E2 label is the command. Let's say let's label it with let's say StarAgile, StarAgile, to label the device STC1 StarAgile. Bad magic number to STC1 contains XFS file. There might be some problems with the file because we have formatted with the different ways. Let's okay, ST4 again. Let's see if it does format. Okay, now it has labeled the device. After labeling, you can just mount it to a directory. So I'll create a directory /mnt StarAgile. Okay, sudo. Okay, now let's mount it. Mount /dev stc1 /mnt StarAgile. Okay, now let's check our partition. So currently it says that SDC1 is mounted successfully on file system called MNT StarAgile. Let's try to check the disk usage of that MNT StarAgile. So let's use this du command. So this du will tell you that this much usage it is doing currently, and if you say fdisk -l, it will tell you all the listed file systems. SDC1 500 MB, and it is formatted this way, and df-h. It says that the partition that you have just now created, it's 1% in use currently, and it is successfully mounted on the MNT StarAgile. Okay, now let's unmount it. You mount. So either you can unmount like this /dev/sdc1. Okay, or you can unmount with the directory name also. So either with the file system name or with the device name. So anyways you can unmount the partition. Now if you say df-h, this will no longer be shown in the file system because we have unmounted it. Unmounted means we have kind of ejected the pen drive. Usually what is what it says about unmounting. You are just removing from the mounted partition, so it no longer being showing to you. All right, now let's try to add the entry in the FS tab, so that we will be using FS tab in order to make the changes. etc FS tab. Okay, let's say label, we will do the same entry. Let's copy this and then paste it. We have labeled our partition with StarAgile. So you can either use UUID if you have it. Okay, if you don't have it, then you can use label. So UUID, you can see there is a command called buildkit command. We will show that in a bit. But since we remember that we did label our partition, so we will be saying look for the partition which is labeled as StarAgile and mount that partition onto /mnt/StarAgile. Okay, the partition formatted is ext4, and after that it says that what kind of format types you would want to choose. So there are multiple mounting options. So currently it says default. There could be read only, read write and stuff. You can choose to do that. Sometimes some for input output operations you set up to async, and there are a lot many others are there. And then this 0 represents the dump field, which means that you want to dump or take the backup of your data if you would want to. So if you select 0, which means it will skip the backup, it will not take the backup for this partition. And this 2 is the FSCK order, which means that it basically defines the priority of your file system. So if 0, which means no checking, if there is set to 2, which means checked after the root, and 1 means it's set as a high priority. So for example, if you look at this boot partition, so the priority for this is 1, which means it sets on the first priority. So this partition should be booted first, and then these partitions should be booted. So that's how the priority you can assign. So let's, how do you reload this file? The command called mount-a, sudo mount-a. So it says that your FS tab has been modified, but systemd still uses the older version. So you can use this command to reload it. Okay, let's reload this daemon. Now let's see it. df-h, it will showing you that whatever the entry that we have done in the FS tab. Now let's add the entry via UUID, not via the label. So okay, there is a command called buildkit to identify the unique identifier of your drive. So this is the unique identifier. Okay, block size, type, and etc. So those things you can check here. So what if you want to, so just copy this from here. Okay, let's unmount /mnt StarAgile. Okay, now we will go to FS tab. Now instead of this, we will say like this. Okay, StarAgile 64. And let's comment this line. So once we comment this line will no longer being used, and whatever the uncommented lines are there, it will be using those to mount it. So let's say sudo mount-a. After that daemon reload. See, okay, it has not read it properly, maybe some issues. Cannot find this UUID. So let's try to check UUID mnt StarAgile external default 02. /sdc1, label is this, UID is this, copy, okay. Last time it was not, I guess, updated because it was not showing the label thing and stuff, but now this time it is updated. So let's try to mount again, -a. Yeah, now it should supposed to see. Yeah, so that's how you can mount it based on your UUID or your labels, or you can directly give your partition name /dev/sdc1, and then after that you can just give where you would want to mount it, what file system, which priority you would want to put it on, 0, 1 or 2, and do you want backup or not. So you can change those things accordingly. So that is there. After that we will be seeing how to resize the partition. See, resizing is good to know, but it's just that when you shrink the partition, that's very important. There are chances sometimes when you shrink the partition, it can reduce the partition though, but there are chances for the data loss. So it's always recommendable that either you don't shrink the partition, which if I talk about the industry perspective, there is never be a requirement usually to shrink the partition. It's always a requirement to add on the partition, to extend the partition, but not to shrink the partition. But for example, let's say if in case you have to shrink the partition, make sure the partition backup is there, so that if in case some sectors goes into the bad state or file system gets corrupted, you can recover it, you can copy at least the data back, whatever the backup that you have taken. So if you come across these scenarios, then always preferable that you take the backup of your file system that you are going to do. So let's talk about shrink. So there are respective commands and stuff to do that. It's not it's fine to, if you don't remember the exact steps, you can always Google up and then get the commands, whatever the step by step it's required. So we'll be talking about that. Okay, so first of all, to shrink it, let's say you have to scan the file system, fsck. You can run, there is a command called e2fsck -s. Forcefully I'm scanning the file system check. Okay, so this is what say it is mounted, cannot continue, so you have to unmount it first. So let's say sudo unmount. Okay, now it is not mounted. Now we can run this command. So this is basically checking the inodes. Okay, the first check is pass, checking inode blocks and size, then directory structures, then directory connectivities, and so all these 5 checks are successfully done, which means our file systems is perfectly fine so far, and we are able to scan it. It's properly scanning as well. Now let's resize this partition. So there is a command called resize to fs, and then we want to resize STC1. So earlier we gave 500 MB, let's resize this to 100 MB. Okay, let's resize it. So now it says 100 MB. Okay, M is there. Yeah, so resizing file system on this. Okay, reduce it. Now the file system is this. Once we resize the files, the file system, we have to reduce the partition now. So see, the thing is, first the partition was created in 500 MB. After that, on that 500 MB, the file system was mounted, which means the file system was scattered across that 500 MB. So initial thing is check your file system, scan your file system. Once you're done with the scanning, reduce the file system, because without reducing the file system, you cannot reduce the partition. Otherwise, what will happen is there are some data which is there in the, let's say, another corner of your hard disk or your partition, but you have not reduced the partition file system, then the partition reducing might lose the data for sure. So it's always recommended that, see, think like this, right? So there is a room. In that room there are sofas and chairs and stuff, right? So if you want to half the room, what do? You first shift your sofa and chairs and everything at one corner, keep it in the half space so that half space is empty. After that, you make a partition. You reduce the room size. You just don't directly reduce the size when there is a sofa lying in the other corner and the chair lying in the other corner, right? So it's always recommended to keep file system, the contents, whatever there inside your drive, to a location, reduce that first, and after that reduce the file system disk space. So now we have reduced the file system. Now let's try to reduce the disk size. So there is a command called parted. So let's do this. stc1 resize ck stc and resize partition 1 200 MB. So it says that shrinking a partition can cause data loss, that I have already told in the beginning, that it's always good to take the backup. So it's again sending you the warning and asking, are you sure you want to continue with this? If you say let's do this, so it says you may need to update the etcfs tab. That is information it is giving it to us. So we have reduced the parted. Now let's do this. If you want to stc, you want to see the print, sudo /parted so it is printing that currently the size is 100 MB. It's a primary partition extended to file system. So we have successfully able to shrink the partition. Okay, sometimes you might end up getting the errors where the block sectors or hard block sectors, basically those are being corrupted. So in that case you have to go to the recovery mode. There are a few commands that is being used to recover it, but considering this case, we did not come across such scenarios, so we'll be skipping that part. But in case if something happens while you multiple times try to shrink the partition, then chances that bad sectors can occur and corruption of the data can also occur. So you have to resolve that actually. So once you do that, after that you have to fix the file system and you can just mount it. So partition table mount -a. Let's type bad option, single parameters. You can have more information. So to extend, and once you do this, you can just check the file system. Verify. Okay, the file system size is this. Physical size of the drive is this much. Either the super block of partition likes to be correct. Okay, so this is again, it's asking me to. I'm aborting it for now, and you can just resize it. Resize to FS. C1. Okay. Resizing. So this is just to clean it. CK-F. Okay, it has checked it. That is also good. And then let's try to run this mount command. Yeah, so now you see we are able to successfully mount the reduced file system, which was of 100 MB, and now we have reduced it, and after that we are able to mount it. So there are chances sometimes you come across with the errors like this where you try to scan the partition, it's not able to do that. So seems like we went for a moment in that stage, but after that when I rescan the partition, it basically, after resizing it properly, it basically let me scan the partition, and then after that I was able to remount it. So Shrinking is always risky, but yeah, you can do that. There are ways to do it. So these steps you can perform. About extend, it's easy because the extend is like you have to add one more, extend the partition, and after that you can extend the file system. Once you do that, after that you can mount it. So it's kind of little easy. So let's try to extend it. Let's unmount it first. So we'll use it sudo unmount. Okay, let's verify the partition is unmounted. After that, let's scan it. e2fsck after /dev/stc1. Okay, we are able to scan it. That's good. Now let's use this command parted. Sudo parted device resize part1 from 500 MB to, let's say, 300 MB. Earlier from 500 MB to 100 MB, and then now from 100 MB to 300 MB we are doing this. Okay, once that is done, you can resize the file system. Resize to fs command stc1. Okay, that is done. After that you can just print parted print command. Okay, now it is with the size 300 MB. Once that is done, you can scan the file system again. fsck-f stc1. Okay, and then you can just mount it again. Sudo mount -a. So now you see from 100 MB, now it is showing to 246 MB, and then that 300 MB has been increased, and now we are able to mount it and able to see the size. So you might see a slight difference in the size, whatever it is showing up here, because it's always be 1024 kind of a thing, right? So it's always be a less. That's how the partition and the file system are being used. So, but if you look at the overall, it's 300 MB. Earlier it was 100 MB, right? So that's how you can extend it. Now let's talk about the LVM partition. So before jumping to LVM, you should understand what LVM is basically. So it's kind of a logical volume manager. So LVMs are being used when you say, for example, that when you try to, so for LVM you have to create a physical volume, which is a PV. Okay, and then from that PV you can create a volume group, which is called VG, and after that volume group you have to create LV, which is called logical volume manager. So the partition is logical volume partitions. So that's the structure of creating a logical volume. Now you must be thinking, why should we use this LVM? So LVM is a way where mostly the partitions are being created. So there is another partition called RAID partition, which we will not be discussing in this. It also kind of used and in the industry where they want to create a backup and stuff for the partitionings. But LVM is at least important because you should know that in, let's say for example, in the same PV which is of 10 GB, for example, you can create volume group of 10 GB, and then you can create 1 GB 10 partition. So total number of 10 LVM partitions you can create out of that 10 GB. So 1 GB each. So that's how you can create more and more and more partitions. So when I was talking about maximum partition you can create in a hard drive is 4, and then we have, let's say, created 3 primary partition, and now the 4th one is extended partition. In that extended partition you can create logical partitions, which are nothing but these LVMs. So there are commands how do you achieve it. We will be talking about that and seeing in the demo. So let's see currently if we have any LVM partitions or stuff. So let's say first let's display if there is any physical volume present or not. So PV display will display you, okay, there is one physical volume which is present called device SDB2, and then it has a volume group as well, which is my_VG, that is also 5 GB. Okay, and then there is a physical extents which is 4 MB of size, and then total physical extents you can calculate based on the size divided by this, the total P you will get. How much physical extents are currently available? There are 904. So the commands that is required, so there is a software called LVM2 which is required for Ubuntu in order to create the LVM. So since I have already created LVM partitions, I don't require this package because it is already installed. Now let's check how to create a PV. So since I already created on device DB2, let me create in the new device SDC SDC, or do one thing, let's create another partition actually. Primary partition to first sector is fine. Let's create 2 GB if we are able to. Okay, W partition has been altered. Yes. Okay, SDC2. Now KFS 64. SDC2. Okay, that is fine. Now let's try to create the volume PV create /dev/SDC2. So ext4 signature detected. Wipe it. Yeah, let's wipe it. It's fine. So it has created the physical volume. So now if I say PV display, you would be seeing there are 2 PVs. This was the earlier PV, and this is a new physical volume that we have just now created of 2 GB size. So this displays the message like this because that is how Linux tries to update you that okay, this is a new one that you have created, this is the existing one which was already there. Okay, once you have created the physical volume, you have to create a volume group. So for that there is a command called vg create to create the volume group, and I want to give, let's say, StarAgile volume group to what drive STC2. Okay, volume grid group you can list vg display. This will display you earlier we were having my_vg, and now it has StarAgile_vg, which is a volume group, and the formatted and stuff, it is telling you all this information. Now once you have created this volume group, let's create LV. So to create LV, there is a command called LV create -L. So now we have 2 GB of space, so let's use this. Let's try to create 500 MB only, and -L for the name, let's say StarAgile_LV. okay, and from which VG, StarAgile VG. So this will basically create a logical volume partition of size 500 MB. The name of the logical volume is StarAgile_LV, and name of the volume group out of which this LV will be created is StarAgile_VG. So now let's see this LV display to display the logical volumes. So this was the logical volume which was previously created. Now this is the current logical volume that we have created on top of this volume group. Okay, so first create PV physical volume, then volume group, and after that logical volume. Okay, so that is a 500 MB size. Now that's done. After that you have to format it again. So let's say mk4 me2ms kfs64/dev. So the device name, you will get it here. Okay, you don't have to remember this once you do this. So it has formatted our logical volume and then it is ready to use. and after that you can just mount it. So let's say I create a directory /mnt star agile underscore lv, and then let's see mount /dev /underscore inside /mnt star agile. So let's mount the partition that we have created, the logical volume. And if you look at here, we are successfully able to mount the logical volume partition on mnt star agile underscore lv is the file system. So let's conclude this session and let's recap it what we have discussed. So we have discussed that there are maximum of 4 partitions can be created in a hard drive. It's always a best recommended practice that you create 3 primary partition and the 1 extended partition. In that 1 extended partition, you always create logical volume partition so that you can have multiple partitions. Depending on the type of the hard drive and the supportability, maximum up to usually 60 partitions can be created in 1 extended partitions. So there are multiple options to format the drive. You can format it with NTFS, ext2, ext3, ext4, XFS, and GPT for high scale variety of partitions things. So while doing this shrinking operations, it's always recommendable to take a backup of your data because there are high chances to get the corruption for the data. So you should always take a backup before you do shrinking of the partition, which are not really needed in the industry real-time purpose. But yeah, in case if you had to do the shrinking part, you can definitely do it, but always take a backup. For extended the partition, it's nothing required, just extend the partition size, or after that the file system size, and then you can extend the remount the partition. That will happen. It's good practice to label the partition so that the confusion should not get created, and it's always easy to find out the partition so that you can append in the etcfs tab file, so that while booting it up, automatically the partition gets remounted. And then for the logical partitions, we discussed about it has to have the physical volume and then volume groups and the logical volumes, and the minimum unit for the logical volume is P, which is a physical extents. So number of P is depending on the size of the partition that you are going to create, so you can calculate that as well. So yeah, there are some other partitions as well, like RAID partitions and stuff. We will not go to that detail. So that's it for the partitioning and verifying the disk usage and file system usage here. Right, so in this chapter, we'll be talking about the backup and restoring methods in Linux. So which is usually required when you have to take a backup and you have to zip the files in order to compress the size so that you can easily take the in and out operations. You want to take some data, you can just compress it and decompress it. So there are varieties of tools which are available in Linux, for example, tar, gzip and rsync commands to backup and storing. And after that, we will also see how do you monitor the systems in Linux, for example, using htop, iotop and vmstats, which basically provides the statistics of your systems which are being happening. So this is all also cover up in the portion of system admins, which admin should also have an understanding about all these things. So let's go to the demo and check out things, how do we capture the backup and restoring methods. So let's currently I'm logged into this machine and I'm logged in with the user StarAgile. Okay, so when I do ls in my home directory, I see these are the files and directory which are present in my home directory. What if I want to take a backup of a documents folder? I want to create a tar file of it. So how do you create it? So there is a command called tar-cvf to create the backup, and you have to provide the file name, what the backup file should look like. So let's say I would name it document.tar.gzip. If you are using, so currently I'm just creating a tar file, not zipping it up. So I can just say document.tar to document folder. So when I do ls-al, I will see a tar which is already created for this. Now let's see document.tar. It's 12 KB. What if the size of documents, it's 12K, it's 4K. There is some differences in the size as well. But if you really want to see the tars, so this is not a compress, it's just the mechanism to basically create a backup. So further you can create a tar backup and zip it up, and let's say document.tar.gz of document folder, and then let's check the size of it. So du-sh, so the size is 4 KB. That's a minimal size, it gets created because I don't think there was some other data contents present in the documentation, so that's why. But what if we have multiple lines and stuff, so you will definitely see the compression of size of the files. So that's how the compression is done, and then you can create a zip file for the using tar. And if you want to just read the tar, then you can read it like this, document.tar. So it says, okay, it is basically, it has documents folder, and let's say I create a directory called let's say backup, and if I go inside the backup, I want to untar this package here. So see, if I do tvf does not basically untar it, it just tells you that so it has taken a backup of a particular file or directory, but it is not really doing untar or to you. But if you want to untar the file, you can use command xvf. Okay, let's say you want to untar it, and I want to untar it in my present directory, which is a backup. So it says existing with failures due to previous errors, not found in archives. That's okay. What we can let's try to create some other file or directory. Let's say I do test. Okay, let's remove this test, and let's create a directory test. Okay, I am creating some files inside test, file1.txt. This is file 1. Okay, this is StarAgile file. Okay, something like that. I'm creating a content, and then let's tar this tar-cvzf test. Okay, I want to create a tar inside backup. Okay, of what? Test. Okay, so now let's go to backup. You see the tar has been created. Now I want to see this tar tvf test.tar. It says okay, so this backup is created for these two files and directories, test and file1.txt. Let's decrypt it, or let's decompress it. So xvf is used to do that. So once you do this, it automatically uncompress the tar for you, and then creates the it unfolds the tar values, and then it shows you the contents which is present inside the tar file. Okay, now if you look at the tar, you should be able to see the text, and if you do this, you will be able to see the content. So that's how you can use tar command in order to create the backup, and also you can compress it via cvzf. So if you want to read more about the options of tar, so see, tar-c is to create the archive. Okay, and if you look at -v, then it will show you -v is for backup, the verbose mode. So it's showing up here that this is the verbose. Okay, -z for compression, and gzip. So this is how capital Z is for compression and small z is for gzip, and similarly it uses unzip and gunzip. So and -x to unfold. So you can get it from here, It's basically trying to decompress the program. So in order to decompress it, how do you do this? Using -x command option. So that's how you can read a variety of options which are available with the tar, and you can use tar. So what if you want to exclude files or directories while creating a backup? So for that, let's do one thing. Let's first remove the compression that we have taken, okay, and let's create couple more files inside our test directory. So I'll create file 2.txt, okay, and file 3.txt, okay. Now let's try to avoid file 2.txt, only take the compression and the backup for file 3 and file 1.txt. So how do you do that? You can exclude using option -- exclude, and then let's say, so exclude and say file 1.txt and tar dot cv zf test new tar.gzip of test, okay. So when I exclude file 1.txt, it only took the backup for me only for this test directory, then file 3 and file 2. However, if you look at the test directory, you will see there are 3 files, but we have excluded via option file 1.txt. So now let's copy this tar inside backup, and then we will uncompress it there in the backup. So let's go to backup, and currently we removed that earlier decompressed test file. Now let's again decompress the new backup that we have taken, test_new here, and tar-xvf. So mainly I guess it is creating a problem because we don't have the file here. Let's try to untar it, test-new. Yeah, so you have to move the file. It should be present in that location. That's why once you do that, after that you should see that there is a test directory which is created. But if you try to locate the files which are present, so file 1.txt is skipped because we explicitly excluded that file while creating the backup of it, okay. Now how do you basically gzip to individual file compression? So how do you do that using gzip? So there is a command called gzip. So you can just let's say you want to zip file 1.txt, you can just zip it, okay. So let's see. So file 1.txt.gzip. So once you do the gzip part, automatically this file has zipped into .gzip format, and then if you want to unzip it, so you can use gunzip and then test and then file 1.gzip. So if you do this, it has all automatically unzipped it once we execute the command gunzip to unzip the file, okay. So that's how you can use gzip and gunzip to unzip the file, okay. rsync command we have already seen before, where it basically tries to copy it up from the remote machines. You can just copy it up as it is for the files and directories. So that is a difference between gzip, rsync and tar. So mainly for Linux systems compressions and techniques, so people prefer to use tar because it can have a facility to automatically creates a backup, as well as it basically creates the compression as well, so both things, and then you can just unzip the file, and also you can just unzip the backup as well. But gzip and gunzip is just to unzip and things do this. For rsync, I'll just show here the commands that we have preferably tried before if we did. So like for example, our sync is being used. So let's say you want to rsync this directory called test, okay, to the remote machine. For example, StarAgile @10.211. Okay. So if the machine has a connectivity, then you should be able to do this. Okay, maybe some directory test it is doing. From if I try from this server, let's try from here actually. Okay, because I have my public key stored in the server. This is a client machine, so I'll just use rsync and remote machine StarAgile @ let's say 10.211.55. Skipping directory tests, okay, because it is already present. So let's go inside test and then do this rsync. StarAgile test. Yeah, so this way you can sync the directories from your server. So this is my server 12 machine, and you have to use option AVZ. Without that it was not working, it was skipping it. So this will include the zipped as well, and here it is. So it has successfully, bring all the informations of this directory, whatever it contains. So it was skipping that earlier, but now including this -a option, which includes the subdirectories and files inside the directory. So that's how you can use the rsync. So the main differences between tar, zip and rsync is just to create a backup for if you have a requirement to create a backup as well as the zipped backup. So better to go with the tar command. If you only want to zip the file compression, you can use gzip command, and then you can use gunzip to unzip it. And then if you want to sync between remote machines, then you can preferably using rsync, because it will directly sync the directories and files for you. So that's how you can copy it. Now let's talk about some system monitoring tools. I think we in terms of htop we had already discussed in the previous chapters, but I'll just recap it. Htop is a command which basically gives you the real-time view for your processes which are running on your Linux machine, and it can gives you some granularity in terms of the usage of your CPU, memory, processes, priorities and commands and time, and load average and stuff. So that can help any admin to analyze which process is consuming high memory, which process is consuming more CPU usage, and which process has to be terminated and stuff. So those tricks you can do better in htop. In the process management, if you remember, we talked about ps command as well, where you can just check the processes, list down the processes. But for the live process, there is a command called top command. But for high physical graphical interfaces, if you would want to see, then htop is a better command. Here you can basically filter out based on percentage of your memories and stuff. You can sort it. So for example, F6, if you press it, so then you can sort it, let's say percentage of memory. When you press enter, so you see the high percentage of memory process which are being used. So that's how you can do. So all these options are being shown up here in the below, that F1 does what, then setup and search. So let's say if I want to search something, and let's say I want to search htop and I pressed enter. So it has found me the process called htop. Currently I'm highlighting on that htop process. You can just shift the arrows, keyboard arrows, to shift from top process to bottom and all. So, and if you want to send some sort of a signal, so you can say F9. So go to htop and then say F9. So once you do the F9, it will lock that process. After that, whatever the signals you would want to pursue, you can provide that signal to the kernel. So if you remember, we talked about the signals earlier as well, that signal number 9 is just to kill the process, does not ask for anything. It's more of like a forcefully kill for any of the processes, right? So signal 9 is this. So for each signals, there is a respective work that signal does. Like sig hub is just to just to make sure the process just to hung it up and then not to work, but does not kill it. Then similarly for abort and quit and stuff. So let's say if you provide any specific signals, let's say I provide signal 9. So ultimately what it will happen is, under the hood, it will execute a command called kill command with the option -9, because that's a signal sig kill which will be triggered for the to the kernel, saying that this stop has to be closed immediately. So if I press enter, after that you see I have come to the shell. So directly it has killed that stop process, which was showing me these graphical representations of the processes, process tables and stuff, right? So that has directly gone up. So that is the advantage of using htop. You can filter it out, you can search it, you can create a tree, for example with the F5 function. So you can create a tree, which means you can see list down the processes, sub processes which are running from one process. And so it's kind of an easy access for the admin to analyze which process is consuming more, and if the admin wants to take any further action, then admin can do this. So a system admin should have the understanding about these processes and should have an understanding about how to deal with those things and how to kill the process and stuff. So to quit it, you just have to press Q. So htop will be quitting it. And if we talk about the usage by the process, so there is a command called IO top as well. Okay, seems like IO top is not installed, so we can download the package via apt, and then you can install it. So first let's update our repository. So sudo apt update will update my repository for the Ubuntu machine, which will basically update any packages which are not at the latest or level, which are still at the earlier packages level version. So it will update the version automatically for all the versions that the repositories that I am being using. After that, once you do this, and then you can install package called sudo apt install iotop. Okay, so this will download iotop package, and then it will install the package on the machine. So it says that package is unpacking, setting it up is done, no service need to be restarted, no container, nothing. So since Linux is like an OS where you don't have to always restart the services, so it updates things real time on the fly itself. So now if you run sudo iotop, so this command basically describes the iotop for you, basically input output operations, if you would want to capture whatever is happening on your disk. So majorly input output operations happens on the disk and memories part, where you see how much input is happening and how much memories are going out and stuff. So those things you can track down here using IO, system IO. And if you would want to launch the iotop only for the active processes, so you can use command sudo iotop -o. So this will list down only the active packages. So currently Parallel is working, Firefox is working, systemd, genome shell. These are the current package, the services which are running. So let's try this. If in case we see this sleep command here, if it comes up here in the process. So usually it depends like the number of input output the operations is doing, then only it will come up here. Otherwise it will not come. So if we do something, let's say Firefox is keep on coming because there is a input output operations are happening. You are basically trying to search things and stuff. So that's the reason it is showing you more details and here. So there are some keys you can use, like for example, you can refresh it, you can check the processes and other things. So this command can help you do as well. Let me just kill this. Okay, right now. What if you want to specifically monitor processes input output operations for the user? So you can run command sudo iotop -u and the username. So let's say StarAgile. So this will only give me for the user StarAgile. Okay. So currently I'm at StarAgile. So StarAgile user is only using the bash. Bash is nothing but a a Bourne shell. It's a shell, the interface where we are interacting with the machine. So currently we have logged in with this. That's why you are seeing this here. If I would have done, let's say for example, Himanshu1, since Himanshu1 is not doing anything, we have not logged in with the Himanshu1 user. It's currently in the inactive state, which means it is not performing any live actions on this machine. That's why you are not seeing any of the things related to the Himanshu1 user. So that is how you can monitor for any user what are the input output operations are which are happening here. Yeah, and if you want to monitor the process, let's say I try this sleep. So the process sleep 1000 seconds in the background, it's running. Okay, you can check the jobs. Now let's try to do this iotop -b -n and grab sleep. So you can monitor a process like this. So this will give you an idea about, okay, this user, StarAgile user with a process ID is trying to do what. It's basically executed an operation called sleep. Similarly with PSAUX also you could see this, that StarAgile user with this process ID has executed this, right? So all right. So this is the command, another command to monitor the resources, monitor the input output, disk, how much it is actually happening, and then based on that, admin can take actions when and where required. So that is the usage of iotop. Then we'll be talking about some virtual memory stats. So there is a command called vmstat that also gives details, too much detail about your memory usage and how much memory is being consumed and how much memory is being used. So let's talk about this. If you want to continuously monitor it for 2 seconds, so every 2 seconds it will update automatically and then it will reflect the changes, whatever the changes you are seeing in your stats. So you can see here currently earlier the R value was 2 and now it's 1 and then 0 and stuff. So this will keep on telling you the live updates of your memory stats, whatever the changes which are being happening on your memory because of some of the process and users and stuff, whatever they try to do. So let's say if I hope to see some changes when I perform some actions. Okay, so let's see this. See, again it has gone to 2, which means something is happening. Whenever any process gets kicked in, which means that the process is consuming some sort of a thing in terms of memory or and CPUs and stuff. So that command can give you the idea about it. Okay, so after that, if you want to see this VM state for CPU, so it will tell you the CPU usage with option -s, that how much CPU usage. This is about the memory, the total swap memory is available, total cache memory is available, inactive and active memories and stuff, and how much CPU is in the idle state and how much it is waiting for the queue, active queues, and how many pages are active. So if you remember the days when you were talking, you must have read in your universities where the paging is there, the memories are being stored. The RAM is nothing but like a pages where you keep on storing that information and data. So when you page in and page out, which means you are basically trying to consume it or releasing it. So that's how those stats you can also check in, swap in, swap out stuff. So those information you can also review with using this VMstat. It's a good utility. If you want to read more about VMstat, you can read it. It explains about how to use the virtual memory statistics, a memory which is virtually available, which means it's not a physical memory. It's a swap memory. Let's say, for example, we are trying to make memory from the physical disk to a RAM. We are trying to convert that. That's called a virtual memory, swap memory. That's how we are using. So those informations you can check how much active, inactive, and stats it is being used. So that is one thing. And if you want to display memory and swap uses, so you can execute vmstat -a, and it will tell you memory usage and swap usage separately. So in memory usage, it will tell you how much memory is swapped and how much is the free, inactive states. So all these stats. So let's talk about this procs. What it does is actually, so R stands for the number of processes waiting for runtime. So currently there are two processes which are waiting for runtime to execute. B is for the processes which are in uninterruptible sleep mode, means waiting for input output operations like disk reads and writes. So there is no such process which are currently running. Swap memory is the memory which we have discussed about. We are trying to basically mean the memory which is virtual memory. It's coming up in the KB as a format here, and to a disk you want to calculate how much is the swap memory there and how much is the free swap memory available, then how much memory is in the active state and inactive states. And then if we talk about swap in and swap out, which means that the memory which is swapped in from the disk to RAM, so this much KB of memory is swapped in from disk to RAM, and this much KB of memory is swapped out from RAM to disk. So those stats you can check out here. After that, for input output operations, you can see this BI value explains the number of block reads from the disk per second. So and this numbers explains this much block per second you are writing into the disk. So you read in from the disk and you're writing it into the disk. So these are nothing but the blocks. Then in systems, you see in is the number of interrupts per second, and if there are any signals which are there for interruptions, so you can see these are the signals there. Now these are the stats for the CPU ideal. 96% of CPU which is in ideal state, and there are no waiting states and user states and system states. So those things explains that currently CPU is running at very ideal condition. That means there are not much of a load on the CPU machine as well as on the memory side of the house. So this explains kind of a thing where admin can understand, okay, the load average also looks good that we have seen in HTOP. Okay, this is also fine. 1 minute load is nothing. If we let's talk about the CPU of 8 core machine, so if it is more 1 minute and 15 minute and 5 minutes, so based on that admin can take actions, and then furthermore they can check about the input output operations and memory that are being used. So those information, so these are the utilities. You can read more about them always, and it's good to have knowledge about reading things, and based on the usage only you get to know all these things, and then you can get a chance to apply those things. Because see, all these options are on a daily basis. It's not needed or required. It depends on the use case. Whenever any user come across these use cases, then only they get a chance to explain. So if you don't have to remember the vmstat command output, what field represents what. So when you do the manual, read the manual, it explains everything to you. What does R mean, what does B mean, and swap in, swap out, and system. So it explains everything, so you don't have to anytime remember those things. So Yeah, so there are various of things that we have seen using VM stats. So if I recall this again, so VM stat is basically being used for the CPU and memory. IO stats, if you want to capture that. HTOP is more of like a process management tool, which helps you to identify what processes are running at the active state, and then you can just kill those processes whenever required, or you can monitor the usage consumptions of those processes in terms of CPU and memory. And IOTOP is again for the disk and IO stats if you want to capture that. So you can use that depending. So in this session, we talked about about the compression methodologies and backup methodologies, for example, tar, gzip, and rsyncs, to make sure you take a backup, you compress the backup, or you sync from the remote location to the local machines. And then after that, some of the monitoring stuff, for example, using monitoring the CPU and memory usage, and how do you deal with those. So these informations are very important for the admin to understand, but it's not always it's fine to not, if you don't remember the VM stats, let's say for example, here what is this values and all. So you can always go to the manuals and you can refer those manuals values, and that can help you to identify for any commands. You can read the manual and read more about what are the options it does, and then on top of it, complex operations you can perform. So that's how admin can perform. And there are some other commands as well, like free command is there, then sar command is there. So free -h also tells about the memory usage. So these are the things you can use based on the usage and can come across with the scenarios, and you can use it. So that's about this session here. All right, so let's talk about how do you manage the services in Linux. So you must be thinking, why do we need services, and why do we need to manage those? So whatever the applications, when we talked about in the operating system, we spoke about, there is a application layer which is wrapped on top of kernel, and that's how the OS is built, right? So those application layers are nothing but the services. So when I say services, which means you can just think like any application that you're going to run on your machine will be treated as a service. So kernel understands, okay, this service is running, which means the application software is currently in the active state. If a particular service which is stopped, which means that there is no communication happening for that particular service thread to the kernel and to the hardware. So how do we manage those services? Whatever is running, how to stop it, how to start it, how to make sure whenever you boot the system, service should automatically up and running. So for that, there are utilities to achieve it. So if we talk about here, so there are two utilities that we can use. One is systemctl. Okay. So this systemctl, it uses the mechanisms to manage the services. So this is a utility. There is an old method also, where a majority of Unix systems basically uses it, called service. Just by the service manage commands, you can manage the services. But I would recommend using systemctl because that has some add-ons capabilities in terms of managing the services, whatever was not there in the previous services. And maybe there is a possibility that in future service command would be deprecated. So in that case, it's good to start with the systemctl. And then in systemctl, there are various options you can see. You can read the manual of systemctl, how do you manage it and how do you stop it. So for example, like to list all the units of systemctl, you can just add option called list-units. So this will show you, it will list out all the services which are running. So you must be thinking, what is this unit? So this unit is nothing but, you can think like a application software, a service. For example, Apache, or SSH or SFTP or Samba, anything, any services which is running will be treated as a unit. So there is a single unit, and then on top of that, you can start the unit, you can stop the unit, and you will see how do you enable the unit. So that is how it is. Now, if you look at the slides, you must be seeing the commands over here. For example, how do you check the status of a service? So there is a command systemctl status. We will be seeing that in the demo. We'll be running it in our Ubuntu machines, and we will be verifying what is the status of a service, and then how do you manage those, right? So there are commands which are listed down here, and then you must be seeing at the bottom right side to view the logs as well. So we'll be covering that logs part in the next chapter. In this chapter, we'll be only covering the system CTL and the services managing part. So now let's go back to the demo machine, and then let's try to do some demo here. So I am currently at my Ubuntu machine, and let's try to execute some commands and to see how do you manage the services. So let's execute command systemctl list -units -type and then service. Okay, so it has listed me all the services which are currently available or loaded on the machine. So you must be seeing here that there are a lot of services which are in the load state, which are currently active, which means that currently it is performing certain actions on the OS. You know, it must be performing whatever the criteria, whatever the specialization of a service is, it is doing the same thing. So for example, like, you know, cups is an important service which basically is running, and it performs the scheduler on top of it, and that's how it reads. And the dbus, these are the messaging services which are internally used by the kernel in order to communicate via dbus. Then DNS mask you're seeing. So I'm just talking and highlighting the familiar services that we have seen so far in our series. So dmessage is there, then genome, this is nothing but the graphical desktop UI. Since we are seeing the graphical units are here, you know, you see the graphical UI of the OS, which means that service is responsible to achieve the same. And that's how we can see, oh, the service is currently loaded and it is active running state. And if you want to see what this service does, I mean, a little brief description of a service in like single statement. So it is genome remote desktop utility. Similarly, like LVM service is running, then keyboard setup is also running. There is a service called PD mapper, which is currently in the failed state, which means there might be some issues with this service. You know, it is unable to start, or we have stopped it, or, you know, it can be anything. So then postfix, which is uses for the SMTP servers to set up it, email servers, then SSH is there. So you must be seeing all the services which are loaded currently in the OS, and whatever the status of the services it could be active, it could be stopped, it could be inactive, or, you know, it must be exited. So exited means the service which is currently loaded and it is active, but there are chances that few services does not need to be active all the time, which means it does not need any running status all the time. It executes, it performs the action, whatever it is you know, responsible for, and then after that it exits automatically. Which means that, okay, let's say for example you're trying to communicate, you know, I'm just talking about some example. Let's say you're trying to communicate certain things to the hardware, and then there is a service which is responsible for that. You know, you hit a command in order to make sure that it fetches some output for you. And for example, there is a service which is basically doing the same thing as a job under the hood. So that service gets, you know, activated, and then it performs the action and then exit again. And which means that once it has given the response back to the user, it is in the exit state. It does not need to be running all the time. When user will perform some another action after that, then only it will again, you know, start, and then automatically performs the action and then goes into the exit state. There are some systemd, which is how to manage the kernel and those services. So that's how these are the list of services you are seeing here which are running. So currently it says 72 loaded units listed. So which means that in order to identify at this machine at present moment, 72 services or units are there which are in the loaded state. But that doesn't mean that all the services which are in the loaded is also active and running. You know, it could be in the active state, it could be in active state, or it could be, you know, some other exited state as well. So this third column, you know, it defines the description, or, you know, tells about what is this actually. So the first column, which is load, it is telling you the definition of it, that it reflects whether the unit definition was properly loaded. So let's say for example there is any unit or any service which has some corrupt files, and in that case when you try to start it up, it will not load successfully. You know, it will be some other error you might see here, or some other indications to identify saying that the service is not properly loaded. The second column is it's trying to tell that the high level unit activation state, that is the generalization of sub. So this is a substate, and what is this third substate is the low level unit activation state values depending on the unit type. So as it says, that depends on the unit type, which means whatever the type of the unit or the service would be, according to it, it will try to be in the running or exited or whatnot, right? So that's how it manages that. Now let's see how do we see the manual of systemctl. Basically what does systemctl does. So it's saying that controls the systemd systems and service manager. So this is nothing but a utility which is used to manage the services and behave as a service manager. So there are a lot of options. This option we have already executed, list units, to list down the units whatever is available. And so the available units are in the memories, and that's how it is able to list all the units. So you can read through this, and then it will give you some idea about what does it do, what is the services and what are the states of a service. If you want to know about any help required, so you can execute this command. Then auto mounts, whatever the auto mount options and patterns, you can just provide patterns after that. Then it will also tell you the path. So basically every service has its own path, and that's how. So when I say service, right, so if you remember in the file system hierarchies we talked about in Linux, everything is a file. So even a process, whatever the process runs, that process also stays or holds a file on the Linux machine. Okay, when I say file, which means there is an entry of the process ID in the file. That's how for services also there is a file which is responsible for that service. For example, like path like this, this service path automatically being created. So usually in /run directories you see all the paths are loaded. So let's go to /run and then systemd. Systemd is the service manager to manage the services. So you see here, all these, whatever the service, out of memories and journals and mount and everything. So it is listed down over here, and that's how you can just read and see the files which are present currently. So see, this is the system. In this directory there are files, for example, netplan, OVS, cleanup services. So this service is nothing but, it performs certain things in order to manage the DNS and configurations of your IP addresses. If you remember, we spoke in the IP assignments and networking things is starting, right? So netplan is the application which basically runs and performs the IP addressing. So this service basically manages in order to clean up whatever the cache holds up in the previous cache, and then you have changed some parameters in that networking configuration. So this service does some sort of a thing like this. So this service is nothing but a file. If you list down and try to open this file, so it says permission denied, and let's provide the super user permission. So it will list down in the whatever it consumes inside the file. So it says it's a unit, it describes what it does. So it's basically used for vSwitch configurations for the cleanup, and it has all the parameters and conditions. So you can tweak that as well. So this is the advantage I was talking about. So Linux is so customizable, then you can make changes in this unit files, and then according to your own use cases you can manipulate the system and saying that, no, I want it to be behave like this, I want it to behave like this. So that's how you can make a changes. Individual files editing is possible in Linux, and that's how you can play around with it and then make sure whatever the customization is required for your use cases, you can implement those customizations. So every service contains a file, some or the other direction and paths, right? So I was talking about /run here, and all the process IDs also. So for example, like SSH. So SSH is a service, and D is a daemon. Daemon means it defines that service. So every service is being identified as a daemon. So a daemon which is running. So if you hear somewhere daemon, so you should think like a service in the package, and that's how whenever a service is being denoted as a daemon. So a daemon is nothing but like, you can just think like a service which is running. So there is a service called SSH. So its daemon is currently running, and there is a file automatically created sshd.pid. So if you basically list down or open the file, you see the process ID 92839. So and then see, so this is the SSHD which is running on our machine. So this is a process. So this process also holds a file to identifying the process ID. So this is the process ID. So if I remove this file, some sort of a conflict will happen on that, so the information whatever you see in the ps command, it was loaded the process ID for you. This information are being read from some location. So this run is basically at the memory level, it's not at a persistent storage, it is the volatile memory storage from where it is basically running. If we stop the SSH service and then restart it, there is a chance that every time you see a different process ID. So let's try to now, let's go ahead with the systemctl and let's try to play how do you stop a service. So you can stop it with using command systemctl stop and SSH. Okay, it asks for the password. Okay, stopping, but its triggered unit are still active. So now let's see status. Okay, the triggered units are currently active, but the status is showing inactive. Okay, let's start it again. Okay. So now you see the different number being stored inside sshd.pid, and if you execute the same aux command to list down the processes which are running, and then you are grabbing only for SSH process. So you must be seeing here that the process ID has changed. So whenever a service gets restarted or reloaded, not reloaded, because reloaded is just while service is running, you can just reload at a real time. There is no need to be restart. But when the service gets restarted, at that time, the process ID also gets changed, and that process ID information is being stored in /run directory. Similarly, whatever you see, so /run is mainly as a volatile memory where the information which is stored, it's for short time period. Whenever something happens on the system, some sort of actions being performed, that things changes out. So mostly if somebody ask you interview questions, also people ask where do we see all the volatile stuff where process ID, for example. So /run is the directory, you should answer it up at the time. So similarly, other process IDs also are there. Cron is also utility we discussed. So yeah, for the services also you can just see all service path is present in the /run majority of the times, where it stores that persistent memory, that volatile memory, and then it fetches out the service information. Now let's talk about the status. So status command that we have seen already. This tells about the status of any service, whatever we would want to see. So systemctl status and the service name. For example, SSH or let's say cron. So cron is also a service which is currently in the loaded state. Cron is currently working, it's active, and then this is a process ID of a cron 1792. The memory, you can see the CPU usage, CPU time, it's active. C group is something which we are not covering here, but C group is, you can think like a container environment where it is isolated to any other system environment. So it's another vast topic in Linux, what is C group. And then you can see the logs, a little bit of logs, but when we'll be talking about the detailed way of logging, we will be discussing general CTL in the next chapter. But here in this output, it is basically trying to tell you that service is currently whatever the state of a service, since when the service is active, it tells you that as well. And then information about the memory and the CPU stuff, and then a little bit of a logging saying that session closed or session open or whatever, right? So it can tell you all this information. To restart, there is a restart command. So you can say systemctl restart and then cron. So it will stop it and then it will restart it. If you again see the status, it's active back, and when it was active 3 seconds ago when we did restart. So that's how you can capture it up. After that, how do you reload the service? Basically, let's say Apache, for example, you made some changes in the configuration file, or you added some index.html further in your virtual hosting path, but you don't want Apache to be restarted all the time. See, it's not always recommended. That's for the Linux give you such privileges where you don't have to always restart the service, or restart your OS. You can just reload the configuration on the fly, and it will take immediate effect. Not like Windows or which requires a restart of a machine as well in order to apply some changes, whatever you are going to make any changes, for example reg dates or some other changes you are performing. But Linux helps you that way. It can just lively update the configuration whatever you would want to see. So for that you can execute command systemctl reload and then such. Okay. Yeah, so now it has reloaded. Let's check the status, so that it says okay, when the service was active, this is the start when the service was started. Since we have reloaded the service, we have not started the service, that's why you will not see the time change over here. But yeah, it will just reload the configuration whatever is required. So it says at the end, you see reload ssh.service openbsd Barclay standards secure shell service. So ssh is reloaded, some sort of a configuration changes has happened at this time. So, and if you check the time, it tells that same time when we make the changes. So that's how you can reload the service. Now what if you want a service to be automatically started whenever system switches on? So you can execute command enable. So this will give you a facility where whenever the system will be restarted, it will automatically executes. Okay, so for that you need sudo privileges to enable it. So with sudo, it basically synchronize whatever the changes it. So this changes also being captured somewhere, and then from there only it is reading it up. So let's see if it contains some information. Yeah. So this script is enabled or not. So when this system will boot up, it will read this script as well and try to make sure it reads whatever the settings that you have provided while executing the command. So these settings will be stored or some changes will be there in this file. And then after that, system will automatically make sure, oh, you have already set that enable or disable, and then it will take care the effect whatever it should supposed to be. So this has a list of path which is related to the enable or disable. You can read through here. This script is called by systemctl enable disable. So whenever you execute command systemctl enable or systemctl disable, it makes changes by this script. So this script is responsible. If you remove the script, then it will not take effects whatever it should supposed to take. Given unit, it needs to call the distributions mechanisms for so whatever it does in order to make the changes, it basically updates it and then makes it. There is a command called stat command. I think we have not discussed this, but stat command, if you want to see the metadata of a file, you can execute the stat command and you can see when the last file was accessed or modified, or when it was changed, and when the file was originated, the birth of the file. So this can give you information about input output blocks or inodes and links and so stuff. So this is also a good utility to see the metadata of any files. Okay. Now let's talk about if you want to see a service is enabled or disabled. So systemctl, you can see, is enabled, let's say such. So this command can help you identify the current status of enablement on SSH service, which means if you want to know that this service, whenever the system will boot up, will it automatically start or not. So this status saying enabled, which means the service will automatically being started when the system was boot up. So if you disable the service, let's say systemctl disable SSH, we have to execute this with root, so sudo. Okay, now see, it says that it removed this and this, so this is disabling, so it makes some changes. That's how the Linux is being read from the file information and then executes it. So this executes this script that we have already seen with the options or arguments disable and second argument SSH. And now I want to see, let's say systemctl is enabled, it will say disabled because you have disabled it here. So let me re-enable it and then we're good. Yeah, it's re-enabled back. So now the system will boot up again, it will automatically being started. Okay, now you want to list the failed services, whatever the services has failed. So for that also you can use systemctl and then ---- failed command. So currently, if you remember our unit list, you know, here when we scroll down, so PD mapper service was showing failed state, okay, and then everything was currently in the loaded and active state. But you don't want to read the entire table or the data, right? You directly wants to see the failed services. So you can use option ---- fail, and this will tell you, okay, this service is currently in the loaded state, but it is failed. It is not running currently. So this belongs to some processor related things which is unable to work. So that is okay. So if any other service which is currently in the failed state, or you make some changes, the configuration is not properly appropriate for the service to be active, then whenever you try to start the service will not start. So that failed messages you will see in the logs that we'll be covering up in the next chapter, but the status of the failed service will be listed down by command systemctl ---- failed. So this is it's a good command to see the failed services. What if you want to prevent any service to start? So there is a concept called masking. Masking means you mask the service, which means whenever you try to start the service will not start. So you can kind of block a service to be started. So for that you can use command systemctl and then mask service name, let's say such, sudo. So currently the service is masked and it has created a symlink we talked about in soft link and hard link. So this masking the services. Now let's try to do something. Systemctl does or not. Yeah. So it says that failed to restart the service because this unit is currently masked. Right. It's not showing in the field because it's still active, but it is not running. So yeah, so it's not showing up here only. If you see systemctl status as such, so it says inactive dead. It's not running. So 12 minutes ago, and it says the loaded state also it's masked, so it will not be showing up here in the unit list command. That's why I try to fetch it by search it, but it is unable to search it also because it is currently masked. So if you see there is a service, so there is a requirement, let's say use case we talk about a service which you don't want anybody to stop it, you know, service should be always up and running. So in that case you can mask it, you can just make the service, okay, nobody should be able to touch it, and this creates some issues, so nobody will be able to do any actions, restart or stop or start, whatever. So service is in the master state. So usually it's like an admin who wants service to be masked so they can perform actions, so that user should not touch that service. So let's unmask the service now. Systemctl unmask such sudo. Okay, now it is removed from the masking thing, and now let's check the status first. So it says loaded, but it's inactive because we did not start the service. And now let's start it. Yeah, so currently service is running. Server is listing on port 22, which is what default port SSH uses, and then started the service. Okay. Yeah, so see, this is what I was trying to tell you, that the use case of it, you don't want anybody to touch this service. Currently this service is masked but is also active, and if you list down unit service, here you can search slash. So here you see a different dot which is in yellow color, it defining that this is currently masked. Nobody will be able to touch it, but it is in the running state. Okay, currently it's running and nobody should be able to stop it. So that kind of a facility also Linux gives you. So this is what all about this series is, we are talking about the features of a Linux, where you can see, you can identify, you can understand. Okay, it gives you a capability to tweak the services, it gives you capability to changes the parameter of a service, it gives you facility to make some modifications or the customizations as per your ease to the Linux services. That's why we say Linux is customizable OS. It's very reliable, and you can just make any changes what you would want. So this is kind of a good use case where service, if I try to stop it, let's say systemctl stop and then as such, it will not let me stop. So okay, it's inactive, it is masked also, and made some changes. Let's see what has happened. Okay, it's removed actually, it should not, but we'll see changes. Let's see, what if we want to start it? Systemctl start sh. Okay, it's masked. Okay, fine. So you can stop it, but you cannot start it. What if I make changes? Let me unmask. Let's see this. Okay, it's removed. Now let's start. Okay, now let's stop. Let's check the status. So status is inactive, but it is loaded. And now what if I say mask? Okay, it's masked now. Now let's try to start it. So you cannot touch, you cannot start the service because it's in the masked state. So a use case where admin knows that there is a service, it should not start, or anybody should not be able to start it because it makes some changes, or it updates some files which admin does not want it to be updated because it changed the behavior of OS. So in that case they can mask the service, and then after that nobody will be able to start it until admin mask it. Currently I am an admin, that's why I can make all these changes, but in the real-time scenarios, the users who have access to the Linux machine or any servers, you will not be having full-fledged access to the machines. You cannot play around with the services. Usually the system admin is the one who is responsible, or let's say if I talk about the DevOps admin in the companies, or who manages the, let's say, IT admin servers, who manages those servers, that admin only is able to make the changes in terms of the services, because that's how the infrastructure, the internal components or stuff of a product which is running. So they don't allow you to perform any actions on the service level. But yeah, since I am an admin and you want to play around with it, so you can make the changes. So masking, unmasking also you can do, and that's how you can play around. There is another command which basically helps to reload the daemon. So systemctl and then daemon reload. Okay. Yeah. So this can also load whatever the changes, the configurations we have done. It will basically reload the systemd. So the changes in the systemd who manages the services, if you want to reload that daemon, you can just reload via this command. Now let's review some of the things of services as well. So earlier we used to use service command where when systemctl was not there in the picture, it was not invented, or I would say it was not fully being used at the time. So service command was the one which we were using before. So sudo service sh start. So that's how the command it performs the actions. So let's say sudo service sh status. So that is how this command. So if you try to correlate the options of systemctl, so where the actions that you want to perform comes in the middle as a first argument to the command, and then service name or the unit name. But in service command, it comes actions, whatever the action you want to perform, it comes at the end as a argument number 2. But as a argument number 1, the service name, whatever it is, it comes up here. So sudo service sh status. So that's how you can use service command as well to make the same changes whatever systemctl was doing for you. But it uses, see, under the hood, it uses that same systemd libraries where it was making the changes in terms of services, because systemd is the daemon which manages those services. So see, if you want to know about systemd, you can read the manual of it. So init was the command before kernel. The first process of a kernel was init before. And systemd is also the same way. It's like with the time the evolution changes, and then they created systemd. It manages the service and do the same thing. So the process ID for the systemd is always 1. Earlier it was a init process. So in interviews also people ask sometimes, what is the first process? So you can say init also, you can say systemd also. Init is the previous versions of Linux we were using init when the bootloader was old and then stuff. But now with the newer capabilities of the systems, the first process is systemd. It does the same behavior as what init used to do. The first process of the Linux machine. You can check here also if it's listing here. No, it's not listing the first one, right? Let's see. Yeah, see, the first, it's showing init only. So that is nothing but systemd is what it is managing. So the first process is always, you can say init or you can say systemd. So in the manual also you can read. See, for compatibility with sysv, if the binary is called as init and is not the first process of the machine, and then it will execute whatever it does. So you can read through that, and that's how it manages the services. So that's how you can manage via system services command. Let's say you want to restart or you want to load, so you can use command service, then service name, and then reload. So this will also do the same thing what we were doing. Systemctl reload. Systemctl reload. So whatever this command does, the alternate is service sh reload. Okay, so that is the reloading the configurations. And after that you want to list down all the services here, so you can list down service hyphen status all. Okay, see, this is how it is listing you the services which are present, but the way of unit listing via systemctl has some other functionality or the capabilities we saw in the list unit command, right? So see the changes, the UI, the representation of the information, how it is doing. So that's why systemctl is the upgraded version, you can think like, of the service command, the previous service command. So but yeah, it does also tell you that this is service which are running or not running or whatever it is doing. So you can list down all the status, and then there might be some other options as well in the service command to list down only the active, only the inactive and failed services, like that. If we talk about the live example, let's say for example currently the Apache server is running on this local host machine that we already discussed in our previous chapters, where we were discussing about the web services or virtual hosting. Now we host a website. Now what happened, let's say I want to stop it. We want to analyze if we stop a service, the application software functionality stops, it does not work. That's what we are trying to analyze here. Okay, now we have stopped it. Now let's see if it works. See, it's not working. It's not working because it was using Apache 2 application under the hood, and we have put up a index.html page where the page was loading as per the functionality of this Apache 2 service. But now as we have stopped this daemon, it will not work. For that you can again start it, and once you do that and refresh the page, it will start working. So that is what I meant by the service, a service which is responsible to perform any actions on the Linux machine. You can start it, you can stop it, and then you can restart it, you can reload it, or you can list down all the failed services, or you can list down all the active services, and then you can see the path where the service file belongs to and contents inside those path. You can make changes, the modifications you can do in those configuration files of the services, and then accordingly it will tweak and changes. So all these things you can just go through the manual and then see things, how do you do that, what are the other options. So you can just play around with it, whatever the option you would want to play. But here it's like, we are trying to cover up a scenario where how do you use this utility. There are multiple options to it, so you can use all the options you would want to, but it depends on the use cases, whatever you have it, and that's how basically we do that. So in terms of best practices, if we talk about this session, so the best practices is more of I would say you should start with systemctl, because in future also there is a chance that the service command will be deprecated soon from all the variety of OS, Linux OS. So systemctl has some advanced version, some other more capabilities it has to perform, and then provide the information about the service, and it can do. Service command is also an alternative until it is going through. You can just see how does it work, but it is the same thing what systemctl do, but systemctl does in a good way, good fashion, and can get the more information. You can just think like a latest command of managing the services in the Linux machine. Yeah, so that's about the services and how do you manage the services in the Linux machine. All right, so now let's talk about how do you see the logs of any services. In the previous chapter, we looked into how do you manage the services and how do you start a service or stop a service or how do you reload it. But now let's talk about loggings, which is very important component of a Linux in terms of services or in terms of whatever the things, application softwares which are running on the Linux machine. You should have capabilities, you should be aware about how do you see the logs, because without logs it's nowhere you try to troubleshoot any issues. Without logs it will not help you. So that's why the logs are always being captured on the Linux machine, whatever the actions that we perform. And then there are utilities that you can use in order to read those logs. For example, journalctl is the command which can help you to see the logs. Then syslog is another things. So we will talk about the differences between journalctl or syslog, how do they store the logs, how do they read the logs, how do they show up the logs on the UI, and how do you make the changes in terms of that. So in the PPT you can see there are commands, for example journal -b. So you can see there are various options. These options you will also get in the man command, manually. When you open man generalctl, then it will give you all the manual options for the generalctl commands, and then there are various options that uh, you can look for, and then you can, based on that, you can just make changes, and then you can read the logs. But logs are very important in terms of, when I say whatever the service is doing, you should be able to justify or identify what is happening under the hood. Then using syslogs, it is telling the commands that will be common, useful for syslogs. Then when you start a service, when you stop a service, that time logs generates. Or how do you generate a temporary logs, for example one liner logs or two liner logs, you can generate by your own. There is a command called logger command. You can generate the logs, test logs. So now let's talk about see the demonstration of these logs, and how on the Linux machine, how do you see the logs are being stored, and where the logs are there, and how do you read those. So let's start with the manual of generalctl. Okay. So when you open this generalctl manual, it will say the utility generalctl about. So it basically prints the log entry from the systemd journal. Okay. So, and then there are various fields in this command which you can use as an option, and then you can print out the information that you would want to do. Okay. So let's start reading the logs, and then slowly you will get an understanding about what is happening. So let's execute command generalctl. Okay. So now you can see this. Since 13th of August last year, this system was in the running state, which means it was boot up at the time. So this log, what you're seeing, is since the beginning when this OS was built up on this machine. So it is telling you the Linux was boot up on the physical CPU, and information about the images, the BIOS systems and stuff. So when you use this arrow keyword, you will see it's what it is listing in the as a less command that it does, right? So you can just use a bottom arrow to scroll down in the logs. So it will give you information about anything about the logs. Or let's say you want to search SSH, so you can say / and then search SSH. So you remember while performing the actions on the SSH, we try to create the keys as well, public keys, in order to authenticate via keys. So at that time your public key was stored in this. So all the responses that we got in that SSH also being stored in the journals. So you can see the public key here. Multiple times the keys were created, or service was stopped and started. So all the logs, whatever it's there, you can just see it up here. All right, so this is the generalctl utility. But now it's not just if you execute generalctl, it will not help, because it will start from the beginning, all the logs will listing it out. So but yeah, the use case for us would be a little different, where we want a variety of a log, a chunk of a log from a particular time frame, or for a particular user, or for a particular service, not just all the logs, kernel level logs or boot logs, right? So let's start using some options and see what does it do. So for example, you want to store the output, or you want to list in the short format of the output of generalctl. So you can use option output and then short. So this will give you a little shorter than what generalctl command gives. So it is still, it feels like a little large or little long. Why? Because the machine was boot up last year, and it's like a long time, 5-6 months of logs are there. So that's why you are seeing it. But trust me, this is the shorter version of just the generalctl command, what it does. So you can just read in the manual as well. Option short. So it says that precisely follow the precisely this format to print the short logs, right? Output and most identical formatting. So you can format that log, short full also you can use, or short ISO, very similar. So it basically shorts the file. What if you want to, somebody who's good with the JQ, JSON query, and you want output not like in this lines, like how is it currently listed in the form of lines of the logs, one by one. You don't want like that. You want it to be in the JSON file, and then somebody who is good with the JQ command to filter out the data from the JSON. So you can use like this. So journalctl, you can output JSON. So why the use case of this JSON come up? So there are various other applications who are good with fetching the JSON file and then creates a report on top of it. For example, let's say Elasticsearch, or there are a lot of open source tools are also available. Where Splunk is also there. So there are a lot of tools which are there who can do manipulations on the logs. So what you have to do is like you have to export the logs from the Linux machine and then provide the logs to that software via any pipe or channel or whatever, and that channel does some sort of analytics operation on top of it. Let's say for example Splunk, you're passing the logs to the Splunk, and then Splunk UI is a very good UI in terms of reading the logs. Or Elasticsearch Kibana you can use, where the logs are being stored in like a good fashion. You can see the logs, you can build the charts on top of it, you can create a dashboard. So there are variety of tools available just to read the logs. Okay, so Linux machine, see, if you're reading these logs over here, would be a little clumsy sometimes to read the logs, because it's not as clear as whatever it is, because it's so lengthy in any particular line. So it's always good to forward the logs. We will see how do you export the logs and then into the files, and those files you can import it back to any other tool and it can perform the actions. So one tool I'll be using here, which is JQ. So let's say we would want only for Apache to web services logs to be print. So we can use Apache for any service, let's say for example, and then we will say JSON only output, print the output into the JSON. Then you can just use command JQ. So I will use the syntax. Whosoever is familiar with the JQ, they can understand this, but somebody who is watching this JQ for the first time, you can just Google it up and see what does the JQ use. It's a utility which can perform the action on top of the JSON based output. So message and then hostname colon does. Okay, so you can see it appear from the output. That was, see, if we remove this part, let's say for example, if we just say journalctl-u Apache to -output JSON. Okay, so see, this is how the log is looking like at this moment, but you don't want all the information. You just want the host name. So for example, you can see this is the host name on which this Apache 2 service is running. So the host name is the local host. If you say host name, this is the machine. It's my local Linux machine, Ubuntu machine, on which we are executing all the services, and Apache 2 is also one of it. So this is the host name. So you want only that host name to be print along with the message, whatever the message you're getting in that output. So you can use JQ and you can filter out the message. So see, it's displaying to you, okay, the Apache 2 service was started and this is the host. If it has an entry for the host, it is able to find out, otherwise it says null. So you can just read through this. It's kind of an easy to filter out, to fetch anything which is in the JSON format. So it's always good to have a variety of output to be prints from the JSON journalctl command. So that is one of the use cases to print the values using journalctl. After that, you want to, let's say, see the logs from the boot time. So you can use -b option. So this will show you the logs from the boot time. let's say you want to see the logs for any specific service, so you can use command U. So this will only show you the logs for SSH, nothing else. So you can see the service was started and service was stopped, it's listing on this port and whatever. So if the service was killed or something happened, so whenever you will restart the service, you will see a new entry. Okay, this boot happened. After this booting, the service was started automatically, because there might be option for enable the service is there. That's why the service got automatically started, then stopped and stuff. So you can read through logs that belongs to any particular service by using option -u. Okay. Then let's say you want to filter out the logs for a specific time. So how do you do that? So you can use option since. So general CTL, then hyphen since, and then let's say 25, let's say today is 18. Okay. So this will print me the logs starting from January 18th, 0000 time frame. So whatever I did. So let's say you must be seeing here, for example, we performed some cron actions with the user StarAgile, which basically says create a cron where, you can just use arrow right side and, back and front, so that to go scroll in that later section of the line. So you can see it here that StarAgile user try to execute a command echo. This is your trainer Himanshu, and then we are putting this output somewhere in this file, so to create a cron job for that. So that's how all kind of logs you want to see, that is easily visible by this -b option. So you can correlate to it. These are the things that we have performed in our previous sessions, where we created cron jobs, we deployed SSH servers, we created Apache 2 servers, and so stuff. So we did all these things. That's why you are seeing all these logs. I have not deleted these logs here. That's why all the previous logs and actions that we have performed here is clearly visible for us to see. So since boot, you can use option -b, and for a particular time frame after that you want to see, then you can see. So let's see today's log or something. So you can see these are the logs which are only for today. So you can just execute that command, give the time frame, and after that it can give you. So let's say if we have date, let's say 11. Okay. So since 11, just like 30 minutes back, it is giving us time logs, whatever we did so far. So we stopped the SSH service, then we started the SSH service and stuff. So we did all these things. You can just read through the logs and understand. After that, you can, between two times, let's say you want to, there is some incident happened on the Linux server and you want to fetch the logs only from 2 time frames. So how do you do that? Using general CTL. So you can use command general CTL and -, since, and then let's say 2025 01 10 a.m. until 25 10:30. So there is no entry, which means if there is no logs present, then there won't be any entry for it. So let's say some other time frame if we have it. Okay, it's not there. What if I say 2? Yeah, so from 1st to 2 the logs are present. So it depends, like a particular time frame it has logs, then it will show it up to you. Let's see if we say 10 to 10:30. Okay, there is no particular entry. No entries. Okay, anyways, this will show up based on a particular time frame it has logs, then it will show up the logs to you. So you can based on the between 2 time frames, 2 dates you want to fetch the logs, you can use until and since to get the logs between two two time frames. After that, let's talk about some real-time logs. How do you read the real-time logs? So for that, you can use generalctl -f. So real-time, when I say real-time, what does it mean is that whatever will be happening now on to this machine, the logs will be captured and will be shown on the screen, over here. So let's try to execute certain stuff. Let me just refresh this. Okay, so some other things. Let me do this. Let me systemctl and let me stop sh service and see what happens. Okay, do we get any logs? Yeah. So you see, with -f, we are able to capture that. First of all, it says that you went onto a different terminal, okay, and which was PTS/2. This is TTY is nothing but a teletypewriter. So we'll be talking about when we'll be discussing what is shell and how do you identify the, so when we switched our tab to one tab to another tab and execute some command, so it is capturing all the information that you have logged in with user StarAgile, which we are here. Okay, and this is the teletypewriter value. So let's see if we get that. It's not showing up here. Okay, nobody. So there must be a way to fetch that which basically the terminal you are currently on to, and then this was your present working directory, which is the case here. We were in this directory shell scripting, and then you have executed command /user bin systemctl stop ssh. So systemctl, whenever any command executes, it does have a binary belong to it. So when we talked about the permissions, you remember +x is the executable privileges which is required for any file to execute as a as a command. So that thing we will be discussing in the shell chapter, how to create your own command. That's where it has a binary which executes. So with the help of which command you can just see it. So for example, which systemctl, it will show the binary to you that any command has a file present on the Linux machine /usr bin or systemctl. So this is the location, and you try to execute and stop sh. So you see stopping sh service signal, and service is currently deactivated and stopped successfully. So every message that you are going to perform in terms of any services or any changes in the OS, it will be capturing it up. Let's say test. Okay, let's say your password. I am trying to create a user, and then we will see if it captures the information for the user. Okay, test created. See, changed user test information, adding new user test to supplemental extra group users. So see, we are able to read that information from the logs. So logs are basically helpful if you want to see what has changed. If you are modifying anything, if you are changing anything, you're doing any actions on the user, or creating any command, anything you are doing in the system. So generalctl is the command. You can just look for it, you can just see the logs, and then you can try to identify whatever is happening, the changes on your systems. So that's how you can capture with option -f, okay, the real-time logs. What if only for any specific service you can use like on top of it? Okay, only for Apache related logs, give me the real time. So let's say, I'm not sure if we refresh it, that is also being captured, not right. What if I say I stop the Apache service, systemctl stop Apache. Okay, so we have stopped the Apache. Now let's try to go back here. Did we get any message? Yes, only for the Apache related we are seeing here. Let me try to delete the user actually. Delete user. Let me just remove home. Okay, we have deleted the user test. Now this log will not be captured here because in this screen we are only capturing the real-time logs which belongs to Apache. So when we stopped the Apache service, we were able to see the message saying that the service is currently stopped and activated successfully. Let me just press enter and then go a little down in the screen, and then let me just restart or start the service. Okay, I've started the Apache 2 and see now the new log will be generated saying that the service Apache 2 is successfully restarted. So any changes that you are going to do for any service, you can just print out a log belong to that service with using option -u and then service, and then -f is for the real-time logs. You can read through that. Okay. After that, what if you want to read the kernel related logs? So you can use /k. This will only print kernel related logs to you, which is only belongs to kernel, whatever the kernel is doing on a Linux machine. So it'll be printing all that logs to you. So it will be like, you can use option you can use D. So this D keyboard key will just help you to pass on so quick so that you can just read through. You don't have to just press enter and then use the arrow key. Rather than that, you can use D as a keyboard key. It'll be like shortly showing up to you passing the logs. Yeah, so only kernel related logs are present on this machine. So you can just see if you can try to understand, so it says Himanshu's iPhone camera. So it is basically capturing whatever the actions that I'm doing on my Mac, it is capturing that as a kernel, whatever it belongs to the kernel, because whenever we add up any other devices on this machine, let's say any machine, right? So any Linux machine, you add a device, external hard disk or camera or keyboard or mouse or whatever, it will be detected as who detects it. It's what the kernel, these are the hardwares which we are external hardwares that we have added in our systems, and that hardware is being identified by the kernel, and then kernel has the files which stores that information, and then it does the actions, whatever. It captures the camera actions or keyboard actions or mouse actions or whatever, right? So it is able to capture the device and stuff for you. So you can just see the logs like this for the kernel. What if you want to see the logs for user? So you can use so this is the current user logs you will see here, -user command. So this will be only for the current users. You can see logs. You can just list down whatever this user is gonna do. You will be able to see that. So these are the actions this user did so far on this machine. So you can use this. Okay. After that, let's talk about some advanced level of commands. You want to filter the priority levels in the log. So how do you do that? So for that, you can use command generalctl. -p is uses for the priority, and then you can pass on the priority level that you want to see the logs for. So level 7, level 5, you can just capture the logs, and then you can see only the higher priority logs don't show me any other type of log. So you can see that generalctl. Okay. So this is the option that you can use here, /-p priority. Okay. So this is the option basically filters out the message priority or the priority ranges. Okay, 7 level is the debug, 6 is the information, or alert messages or error message. Let's say error priority is 3. So you want to only print 3. So this will only give you the error related logs. It will not give you anything else. So if you scroll down, you will see only errors that you are basically do. So let's do one thing. Let's try to do like this, and then we will mask a service and then try to restart it. That we checked in the last series chapter. which when we try to stop a service while it was masked, so it was creating a problem. So let's say sudo systemctl masking sh. Okay, now start. Okay, this is the error message we got. Let's see if it is able to capture that. Did not capture it here. Nothing as such. Okay. Okay, maybe it did not provide this information to us, but it will basically print out all the messages that are relevant for the kernel to print out in terms of errors. So then let's check priority. Okay, let's check about warnings or info level messages. So let's say alert, incorrect password. Yeah, so all alert messages are like, for example, we try to log into a user where we are executing any commands which is not existing. So those are the messages. So that is a criteria of individual priorities defined already. So those logs will be stored in that priority level. If you're expecting an error to show up in the critical priority, it will not show up like that, right? So every particular log, so this log error, whatever we are getting here, might be in some other priority, which is not visible in the error priority or something else. So that is also a case where you can just see every priority has, so this is the information log. It will not give you the error or anything, warnings. So these are the priorities that you can check out, all these priority logs, and then you can try to find out which belongs to whatever the actions that is happening on the Linux machine. So priority, if the priority matches, then it basically gives you that particular logs to find out. Okay, now what if you want to search any keyword? So that we have already used grep command. Let's say SSH. It will give me only SSH related logs. It will not fetch anything else. Let me SSH. Okay, let's try to see this. Okay. Stopped SSH service. Into mask. Yeah, so now we just started the service. It's able to capture that information. Okay, the service was started at 11:59. So it gives you only related to service. So you can fetch whatever the keyword that you would want to do. So with usage of grep command, so you can use any filters. You can just grep it. The logs belongs to what. So any options that you can use, and then on top of it you can grep. Or let's say for usage, that how many lines are there for today's logs only for SSH, or overall you can just fetch like this. These are number of lines. Or let's say I want to see from today only for SSH how many lines are there. So you can just use like this. 88 lines are there in overall. So this will help you in that way. For example, you are exporting the logs and then sending it to some other tool, right? So that tool says, okay, these are the log lines that I have got, but in the system there are 88 lines, and tool says I got 60 lines. So there might be chances that 28 lines are somewhere in the middle. Either they have not successfully exported, or something is missing, right? So in that case, you can try to identify the commands that you can use on top of generalctl. So it supports, that's how the usual Linux is, the functionality of it. Okay, after that, let's say you want to limit the number of lines, so you can limit like this, -n and then 100. It will only give you 100 lines. So here you can see 100 divided by 100, which means the overall lines are automatically being done. So last 100 lines, it will give you like this. Okay. Okay. See, so with just generalctl, I was trying to find out that masking thing that we tried here. We masked a service and we got this error and stuff, right? So it says that you did try at 11:55. Current time is what, 12? So just 5-10 minutes back. Yeah, we did execute that, and then after that we basically unmasked the service as well. So it's captured everything. So last 100 lines, it basically has that entry. Somewhat, but maybe some other priority contains that entry. That's why you're not seeing in the debug messages. But yeah, overall, if you execute generalctl, it definitely shows up that actions that user is basically trying to do. So you can just read the last 100 lines via option -n and then 100. If you want to export that, let's say I just want to export. First, let me go here in the home directory, and then let's say if I want to export last 100 lines only, which as such is there, I want to export this into a file. So we have seen this before also when we were talking about different redirections in the Linux systems. So we used single redirection and double redirection. So let's say I would mark it like this, SSH, and then say if it does like this, logs or something, Let's see if it does. Yeah, SSH logs. It has created a folder, SSH logs, and then if you read SSH logs, you will be able to see the content, whatever we exported in this command, right? So you can just, or I want the output of not SSH, let's say masking, or let's say Apache 2. Also append to the same logs. So you can just read through that. So you will see the Apache logs are also present, and after that SSH logs is also present. So you can use single redirection, double redirection, whatever the facility is present. So you can just export the logs to any file that you would want to by using redirections method. After that, if you want to clear the logs, you can use -vacuum -size. So this will reduce the logs for you. It will basically delete, but just as a precaution, I'm just saying that whenever you try to execute these commands, make sure you have a backup. If it is a legitimate machine, if it's your testing machine, it's fine. You can just trim the logs and then it's okay. But if it is a server, it's never recommendable directly to execute these commands, because there are chances that previous something happened and then you want to trace down what has happened in the beginning, in before. So you won't be able to do that because you are executing this command without taking any backup. So it's always recommendable to take a backup before executing, trimming the logs or reducing the log size or whatnot, right? So it's always recommended to do that, but this is a command to reduce it to 100 MB. Or let's say you want to say to system that I want to delete the logs for 10 days. So you can use like this 10. So basically this command will delete all the older logs which are older than 10 days. Only logs, if so currently what is the date, let's say 20th January. So the logs only from 10 to 20th will be visible over here, but not before than that. So you can delete all the logs 10 days old. So you can just make any changes like this. Or if there is any other option to generalctl, you can look for in the manual. vacuum size. You can use like this. Remove the oldest archival. It accepts KB, MB, and GB and terabyte suffix to base the 1024. Then time period also, like days, weeks, months, and years. You can trim down like this. So it accepts various of options or arguments that you would want to vacuum the size. You can just do based on the requirements or the use case. You can use that. So that is how basically it it will trim down the logs for you. Yeah. Now, if we talk about so that is like general CTL. When we'll be discussing about the comparison of both. That time we will be seeing see general CTL fetch. So it's a utility which fetches the logs, which means the logs are somewhere written on the machine. Okay, there must be files where the logs are present, and then general CTL is just basically reading the files and then fetching the logs for you. But I would say that to you, the general CTL, the files which are present, which has the logs, those are the binary files. If you try to read those files, you'll be looking up in little short. So those files are binary files. It's not like just cat command you can execute and read those and content and find it out. It's not the way it should be. So general CTL automatically does that functionality for you, reading from the binary and then printing the logs, whatever it's there on the screen. So the advantage of using that, because general CTL it's very fast in terms of searching, and it's very optimal. So that's why it uses that functionality. We'll be seeing that in a bit short. But let's see first how does syslog work and how do you see the logs for syslog. It's another utility to capture the logs. So you can just use syslog. So for example, like for syslog, there is a command, tail command and head command that we have already discussed. So tail -f will give you where log, all the real-time logs. So you want to see any logs. Usually syslog logs are present in where logs folder. So that where logs, let's say syslog. So it is printing you all the lines which are there currently in the syslog. So if you want to, let's say if you want to cat it, so you can just do this, where log syslog. So syslog logs are usually present in where log syslog. So those are everything contains related to syslog. So all these entries you want to see. And there are other directories if you look at where logs, right? So you will see, for example, authentication logs, init fail logs, dpkg logs, which are the package manager, Ubuntu Advantage syslog, SSSD, journal. So all these has files or directories, Apache 2. So Apache 2 also contains the syslogs, which has access logs and error logs. So for example, let's say I want to tail down where log Apache 2 and let's say access logs. So this will give me whenever you access the Apache server, right? So for example, use case I'm telling. So let's go to my Firefox and let's refresh that same page, and you will see a new entry will be automatically being come up here. So these are you can just think like a firewall logs. That's how the access logs are also being written in the same way. So which has the source IP address, then there might be some destination IP address and stuff here, then timestamp, then method, HTTP method, which is get, then the path of that HTTP method / there is no path, the website is directly available there. HTTP 1-on-1, it's like which HTTP are you using, 1-on-1 or 1.2. So and then status code 200 means you successfully able to retrieve the page information for you. Then there might be some bytes information, and then this is the user agent. Which tool did you use in order to fetch the data? So let's say if this is Firefox, you are currently seeing Mozilla, right? What if I use curl utility? So let's say curl -v, this is what, okay. So this is also giving me the same output 200, okay. And here you must see one more entry come up automatically, right? So this is using some IPv6, not IPv4. internally local, and this is using user agent called curl, which means some other utility curl is trying to get the page for you, and this page is slash, and then this is the user agent. So see, this is how the advantage of reading the log. So in the real-time scenarios, if I talk about, for example, how do you troubleshoot a user wants to access facebook.com or some other .com website, right? And for the user, the page is not loading. Might be a chances that the proxy or firewall is blocking the user, okay, or some other issue, whitelisting issues or anything else. But another user in the same network is able to load the page. So how do you identify, or how do you troubleshoot? Let's say a customer says, I'm unable to load the page, or it's not working for me via these utilities. So these are the logs which will be present in the access folders or error folders. So all the errors logs will be in the error folder for Apache 2, and access logs are present in the access folders. So similarly for other utilities, in Nginx also, or SSH also, any other utilities also has a syslogs to capture the access logs and the error logs. So this can help you instead of 200 OK if you're getting some other error. So let's say let's try to stop the service. Okay, systemctl stop Apache 2. Okay, I've stopped the Apache 2. Let's try to capture if we are able to do that. Page is not loading. Now let's see what happens. It's not capturing anything because this access log. What if you see error log? Sorry. Okay, so you are seeing that it says it's shutting down something, something we have shut down the service or something. It's able to capture that information. So what if, let me restart it, start it, and then okay, service is started, it's resumed back to the normal operations, and let's just stop it again. Systemctl stop Apache 2. Before that we will access something, stop it, and then again try to, if we go it here, so it will show you the Apache error log saying that the service is shut down. After that, nothing is going to capture. See, why after shutdown it's unable to capture? Because the socket itself is not open, which means on the user try to access anything, the socket is like, you can think like, you are making a connection to a website, but that socket, it's closed for you. That port number 80 is closed for you. It is not serving anything to you. So no logs will also be captured. So logs are being captured by what? Only by the services only. Like for example, SSH or Apache. So Apache 2 daemon itself is capturing these logs, error logs or access logs. If we shut down the daemon completely, after that it will not be able to capture the logs also. So you can think like every service or a daemon also has a capability to capture the logs parallel to its what it serves. For example, website. So it serves website. Along with it, parallelly, it stores the log while people are executing or using that website. So until you start it, it will not be capturing anything for you. So any logs that you would want to read or see, the service should be up and running. If the service itself is dead, then there is no point to capture the logs. You will not be able to see anything. So that's how you can read the logs, Apache 2 or anything else, whatever is present here. Let's see if SSH is not there. It's okay. Okay, so how do you read the kernel level logs here? So tail-f where logs. Then there is a file called kernel.log. So this also stores the kernel related logs to you. See, generalctl is so easy because it just gives the option -k. After that, it will print you the kernel related logs. But in syslogs, it stores this information in plain text files. So these are the log files we are reading. Currently you can just think like tail. We can do cat also. So it's reading the plain text information from the logs. But journalctl is not doing the same thing. It does not read the text information. It converts the binary to a readable format for the user and then prints it for us. So when we will see the background of from where the files are present for journalctl, and then we will see, oh, these are the binary files. But syslogs it's basically stores the log in the plain text format. So whenever you store a logs in plain text, it is not compressed as it should be. So it is consuming the storage for the servers also. So that's the reason journalctl is very much advantageous, because how long and how often you can store the text logs, because those are not feasible to, your storage is, let's say, 100 TB, out of which 20 TB is just capturing for the logs. So that is, and what if you can convert those plain text into binary format, and then you reduce further from 20 TB to, let's say, 10 TB or 5 TB. So it's kind of, you can just use that remaining 15 TB of storage for the other services and stuff. So that's the reason always advantage to use journalctl. But yeah, it's good to know about syslogs as well. How does syslogs being captured? So the difference I'm telling you, syslog basically stores the logs into text format, but journalctl stores the logs into binary, and then it uses the utility journalctl to pull the journal logs for you. Okay. Now after this kernel logs, let's try to see the authentication logs. So where logs. So everything related to syslog is just under the where logs. If somebody asks you how do you see the logs in Linux systems, you can say journalctl, or you can say syslogs, and syslogs majority of times stores the logs in the where log until you change that configurations, syslog service configuration. So these are the logs, authentication logs, if anything happened to the user or some sessions is open. So let's say, let me try to authenticate some other user. Just trying to see. Yeah, so when I opened a session from here, I have logged into user Himanshu1, and you can see it here in the authentication log. It has given me the entry saying that some other new session has opened for user Himanshu1. This is the user ID, and by whom? Parallels, with the power of Parallels user, because that's the main user of our system apart from root. So it has used this, and by that from StarAgile we are able to log into Himanshu1. Now I'll exit. Okay. Now it will say session closed. So whenever you open any session, any authentication you perform on the Linux systems, so that authentication logs goes under where log auth.log file. Okay. So that is the authentication related logs. After that, the Apache logs that we have seen, we'll be checking the daemons and how do we restart it. So for that, systemctl status syslog. So syslog is a daemon which is running. If you stop this daemon, it will not capture the logs for you. Okay. So this is currently in the active state. Let me try to stop it and do one more thing. Let's try to see. Sudo systemctl stop syslog. Okay. Let's check status. Okay, it says currently active. So let me try to see. Service is still running, so it will be capturing stuff. Yeah, it is capturing because it is currently running. If we shut down the service completely, then only it will not be able to capture anything. So whatever the logs we are seeing live here, it's because of that syslog service which is currently in the running state. So without that service which is running, you will not be able to, basically you will not be able to see the service, in the capturing any logs for you in the var log directory. So you can do the same stuff. You can stop it. You can enable or disable it. same options whatever we did in the previous chapter. After that, if you want to make any changes in the configuration, so the configuration file for syslog is this one, etc rsyslog. So okay, so this tells the information about syslog, what syslog does it, and what are the configuration that syslog has it. So this also has another location of it. We have done some modifications that we'll be seeing up a little shortly. How do you capture, when you capture, how do you export the logs or transfer it to the remote machine? So we'll be seeing that in a bit short. So this is the configuration file. Also rsyslog.d. Yeah, there also you can create some configurations. Let's say for postfix, which is nothing but a mailing tool. So it stores information like this. Then UFW configurations and say a lot of further stuff for our syslog. This is the configuration if you want to make any changes in the syslog, so you can do like this. So see, this is the file which says that all authentication and authoritative privileges logs will be stored in var log auth log. If you make a change here, if you make a different path, it will start capturing the authentication logs into different folders. So that is a functionality of a Linux, is giving you to tweak or customize the logging system. That is how the beauty of Linux, that where you can just manipulate the syslog configuration, saying that, oh no, I want a log to be present here, or I want a log to be changed here. So you can make all these changes. So it is telling you in which folder what kind of logs are usually present. So it's kind of good. You can just read through that. It's a daemon configuration file. Okay, now let's try to forward the logs to a remote machine. So let me see which machine I am currently at. Okay, I'm at 12. Okay, now let me open another machine. Okay, so let's say this is my client machine, okay, which has IP address 10.211.54.14. So if you want to forward a log, syslog, you can make a changes. So for that, you have to open a file called etc and rsyslog. syslog.conf. Okay, so let's go to the bottom. So here I am forwarding all type of logs to, so this one time is saying that all UDP related logs, and 2 times is representing the TCP log. So every logs I am forwarding this port 514, whatever comes up to this machine, which is my server machine 55.12, this machine. Okay, so this is the entry that I have to do in order to forward the logs. Once you are done with this, after that you have to restart the syslog service. Syslog, okay. Okay, syslog is restarted, and then we will generate a logger. Let's say this is test log files, test logs for you server. Okay, something like that. Yeah. So this will generate a log entry for me. But before generating any entries, let's make a changes in our server also. So at server side, inside this file, rsyslog.conf, you have to add these entries. These entries means anything which comes on this port 514, UDP or TCP, I am listening to it, which means I am active on this port in order to listen whatever it comes on these particular ports 514. Okay, so server is ready to listen and client is ready to send the logs. Now let's validate the logs. So here also let's restart the service just to make sure everything is good. Or restart syslog. Okay, service is running. And then let's tail the logs, or we can monitor it via TCP dump also. TCP dump -i. Then interface is ENP 0S5 port 514. Okay, let's try to send the logs. I've sent it. See, as soon as I've sent the logs, my server is able to retrieve, okay, from this machine. This is the local, this is a timestamp, this is the IP. So this is my client IP. So my client is using port, some local port it is using to send the logs to me, which is a syslog, and it also has information, something. So whatever the logs you are sending will be retrieval for here. So this is a packet capture, is what Wireshark does, right? We are capturing the packet like that way. And let's say if I do a tail -f also, what is the message? Okay, let's capture both things. TCP dump, my ENP0. This is my interface, ENP0S5. So you have to use whatever the interface that you are running on your machine. So, and then after that port number. Okay, cool. Now let's again click this entry. On the server we received something which is good, and here also you can see this is a test log from your server. This is a test log from your server. So you can see the syslog which is in var log syslog, that the client machine is sending something to you that is being captured in the Wireshark. Okay, from this IP address to this IP address the log has been come up, but whatever the content of the log is, you will be able to see that in the syslog log file. So this is what I'm sending. Let's send something else. Let's send, let's say, hi, this is your trainer. Start. So something, anything you can just publish. After that you will be able to get that message over here. So it's basically saying that something is coming from this IP address, and then this is the packet or this is the message you're getting it. So that's how you can capture the logs, and logger command is basically very helpful to generate any test logs if you want to generate. Because why are we using logger? It's another utility that you should be know about, how to generate a test logs. Also, in case if there is no live logs, see, live logs we have already seen by using Apache. Whenever we refresh the page, it was loading the page, and then we were seeing, okay, the on the terminal, in the authentication or access logs that Apache somebody is trying to access it. But what if some other type of forwarding of logs? How do you do that? So this is another practical demo of how do you see the forwarded logs. So by using logger command, and then once you whatever the port that you're listening from the server side, you just capture the packet on that, and then where log syslog file stores those log information for you. So that's how you can use. In case if it does not appear over here, so you can troubleshoot it via a netcat command. I'll tell you that option as well. Like how do you troubleshoot in case if you're not getting any message on the port, if you're not receiving anything, which means there is some issue with the port itself or some other issue. So 10.255.55.12 sudo test is. If it is working, it is not giving you any error or anything, which means it is currently running. Also, netstat command you can use to capture the port information. Okay, the port is currently in the listening mode. It is listening for TCP and UDP, both type of packets. So that's how you are able to troubleshoot in case if you are not getting any logs in the machine. So these commands you can use. Okay, and after that, let's say we talk about the general CTL log location. So the logs for generalctl, they are two type of locations, which is one is permanent persistent, one is volatile. So the volatile logs are present inside /run log journals. Okay, there is no files, which means that it is storing var log journal var log journal. So this is how it stores the file for you. So for example, if I copy this, okay, so this is the individual file which is present inside your journal logs. So if you open it, see, this is what I was talking about, right? So generalctl is a utility which fetch the binary logs and then convert it into a readable format for you and then print it up. So if you try to analyze the logs by file names or something, right, you will not be able to analyze it. But let's say if you go to the general directory, see, there are a lot of users logs and system logs and all sort of logs are present, but everything is in binary format. And generalctl is the utility to read these files from the binary format. That's how, and the size of these binary files are also very less actually, because it is very small in terms of storing the logs. That's a capability of using generalctl, that it reads from the binary location, find binary files and convert it into readable format for the user. So that's why, that's the advantage of using. Yeah. And then if you want to check the persistent logging which is enabled or not, you can do that. There is an entry which is present inside systemd journald.conf. You can just capture, grab storage, journald.conf storage. Let's use. So currently it's persistent because it's not giving an option where it is storing in the volatile memory. So that's why all the logs, which if it is persistent, so there is a way to tweak this. So if you change this file, you can make changes in order for general logs to store in the volatile memory, which is /run directory. But instead of that, by default, it uses persistent storage, which is /var/log path, under which inside generalctl folder, it starts creating all the generalctl logs as well for you. So you can check these configurations. If you want to make any changes, let's say if you want to enable the persistent logging, so you can do that actually. So for example, if it is not present in your system, so I'm just giving you the command that you can do. So first of all, you can create a folder var log journal. Since it is already there, I'm just giving you the steps to create the persistent logs for generalctl. So first you have to execute this command. It will create a directory journal /var/log inside that. After that, you can use command systemd -temp files, -temp files -create, then -prefix. You don't have to remember this command, you can just get it in Google if you try to find it out. I'm just telling you that there is a way to basically create persistent storage for the generalctl. This is another command that you have to execute to create the prefix of temporary files. The way systemd should capture that the journal logs inside var log journal log. After that, you have to just restart generalctl service. Systemctl restart systemd journald. So this is a service that you have to execute in order to make it persistent. Yeah, so if we talk about the comparison that we were seeing in the PPT, so it tells the comparison between generalctl and syslog. So you can see the log format which generalctl uses is binary, that we have already seen inside var log binary, var log generalctl folder. where the logs, whatever was present, they were all in binary format. And syslog always capture the logs into the plain text, where log, authentication logs, or user logs, or kernel logs, or access or error logs. Then performance also we saw journalctl is a little bit faster than syslog, because syslog has to fetch the data from the large logs, but journalctl can do it from the binary itself. It has a mechanism or algorithm in place which fetches the logs from the binary format. Then if you do some filtering, extensive filtering, journalctl can do it a little bit better, but the filtering is little expensive, time and priority is required. But for syslog, you can do filtering using grep utilities. So in journalctl we use this option, let's say -k to kernel logs, or -b for booting logs and stuff. But in syslog you have to always use pipe grep in order to fetch any keyword, let's say SSH or Apache 2. So that is there. And then yeah, so journalctl accessibility is, it's a centralized method. Systemd uses it. So wherever systemd is running, which means it is basically capturing the logs for you. But syslogs are basically being spread out into multiple files. For example, where log users, where log Apache 2, where log any service, SSH or whatever service, it basically spread out the logs for you. So there are a lot of use cases that you can rotate the logs, you can change the logs, you can read through it. So see, most important thing is logs should be very important to capture, and it's very helpful in order to troubleshoot any issues related to services, whatever is happening on a Linux machine. So that's why I always prefer, you can use journalctl or syslog, it's your choice, but it captures the variety of logs inside these files. But you should have a capability to read the logs, to understand the logs, and try to troubleshoot the issues. So that's how we basically try to capture it, and then troubleshoot any sort of issue. So that's about logging in our Linux machine using journalctl and syslog utilities. All right, so let's talk about shell scripting. So it's very important thing in the Linux systems. We have been executing commands so far, have been performing various operations. For example, creating directories, deleting directories, deploying web servers, deleting the services, restarting the services, checking the logs, anything, whatever we have learned so far, whatever we have been going through in this Linux learning series, we have been executing everything on the Linux shell. So whatever the actions, whatever the command that we execute on a shell. So if we think like that, so that shell is basically, I would say kind of application software itself, which has the capability to perform whatever the user sends any instructions or any commands to the kernel, saying that I want to do ls. When you execute command ls, at that time kernel takes that execution command, and then it performs actions, whatever ls does, and then returns back the data to you, saying that okay, this is what the list of directories and files present in your present working directory, if you do just a normal ls. So all these operations that we have been performing, we have been doing on the shell. And shell, that application software, loads on the teletypewriter, that is what called tty. Okay, so if you look at in this machine, this execution of this command ls, what I am doing. So right now it is listing me the directories and the files which are present inside this pwd. So this is nothing but called a shell. If you want to see what is this shell I am using currently, so you can execute command echo dollar and then shell. So we'll be talking about all these concepts of what is this dollar mean. I'll just give you a brief saying that currently it's saying that the value of shell which you are executing right now the commands on is /bin/bash. So this bash is nothing but a Bourne type of shell. So there are shells which have been deployed or which have been invented and worked upon. So with the time it got changed. So there are variety of shells are available. So like for example, if we talk about what are the type of shells are present, so there are Bourne shell, then there is a she shell, then corn shell, and then GNU born again shell. So these are the 4 type of shells which have been used mainly in the Unix systems. Now if we have seen the usage of shell is like any file execution that you do, any command execution that you perform on your Linux machine. The command line interface, whatever we see, is called shell. So it can be any shell. It can be bin sh, it can be bin ksh or csh or bin bash. These are the type of shells that we perform actions on. If there is any user who is watching this video have been expertise in zsh shell, so that is also advanced version of shell where you can get more options and a variety of stuff to perform on. So zsh is also again a very good shell, and you can do a lot of good jobs. For example, like GitHub, you can do direct integrations via ZSH. You can change the shell prompt and whatever the things you do on the shell. So there are a variety of shells. It depends on use cases, whatever the user would want to use. So if we say that differences between how do you identify if it is a Bourne shell or a she shell. So Bourne shell, when I say Bourne, which is this BOURN. So Bourne shell is being identified who has this symbol called $. Okay, if you see any shell prompt which has a symbol $, that means it's a Bourne shell. So bash is also a Bourne shell. Okay, born again shell, you can just say it's a Bourne shell also, Bourne shell only. But what about C shell? So if you see percentage, anywhere, that shell is a C shell. It does not have that level of granularity in terms of features loaded, which Bourne shell has it, but C shell does not have it. So, but the representation is like, the references of a percentile sign. That's where you see for the C shell, but for the Bourne shell, it's $. So that's a difference actually in these two shells to identify. Then some C type shells are present, like CSH is there. Then 10x is another shell called TCSH. So this is, I'm just talking in terms of you should aware about the type of shell. So TSH is 10x type of shell. It's again a C shell. So it basically defines, okay, this is a C type of a shell. Looks like percentile sign over there. So that is there. Now, if we talk about the little history of shell, so in 1970 mid, Stephen R. Bourne, he was working in AT&T Bell Lab, and then he designed that shell, kind of born again shell. So see, as we spoke in the very first chapter of our Linux learning series, right? That's where we spoke about everything which was invented, bought from Unix, and then took the adaptability about features and stuff. So that was everything was getting invented or getting programmed in AT&T Bell Labs. So that's where the origination of all these things. Similarly for shell also, it was invented in AT&T Bell Labs, the initial version of it. After that, if you look at like any shell scripting that we are going to perform, so scripting is nothing but, I would say, it's a sequence of Linux commands that you execute one by one. Those commands either you can execute like on the command line, or you can create a file. In the file you can have multiple commands, and you want a file to be executed, which means all these 3 commands will be, let's say for example, will be executing. So small version of the use case I'm telling here. Let's say you're executing command ls. Okay, what I want is and then you are executing pwd, but these are 2 commands that we are executing on our shell prompt. Now the use case is you want these 2 commands to be executed in a single command. So there is one way actually, you can just separate it with the colon, semicolon, and then you can just execute like this. So this will be treated as a 2 commands. Okay, but these 2 commands will be coming up as a single command. So it will print the output of ls first. So this is the output of ls, and then it will print the output of pwd, which is a present working directory. Okay, so like this you can print. Okay, or let's say I want date also. So this will print all these 3 things. First, list down the contents present in my directory, then my pwd. After that, the date command output. So this is how you can separate multiple commands to perform. But what if You don't want like this. You want a command to be created your own command. Okay. uh, so and you want these three things to happen, but in your own command, or in your own file. So that's how the need of scripting being defined. So scripting is nothing but like a language, if we talk about. So a language may have a complexity, but if in terms of simplicity, I would say it is nothing but a sequence of the Linux commands. So for example, so let's see, I have created some script here. So as you must have seen, so any script that you are going to create, for example, it should have prefix suffix .sh. So let's say, there is a script called script one script .sh. Okay, so this has a suffix .sh. This means it is telling the system that this is nothing but a script file. Okay, this is going to happen, execute on a shell. It's a script. Now if you open it, so it is telling you about that what this script is saying. So any Linux script, any shell script, if I would say, has something called a header. This header is called shebang header, shebang. So shebang header is what we call. So this header, if I would say a hash and then exclamation mark bin sh or bin bash, whatever, right? So this is called a shebang header. So this means this represents this is currently in commented. Commented means it's not applicable. When we execute this script, this line will be excluded, which means it is not doing any action, but it is just to represent, saying that whatever we are going to write just after it is a shell script. So we are telling the system. So that's the importance of shebang header. That's how you define the shebang header, and after that, you must have seen there are 3 lines which are currently commented. That means it is not going to execute. But if we focus here, so there are commands that basically what this script is doing is echo command. Echo command basically prints whatever you write after it. So let's say if I just copy this here and go to another terminal and then paste it and execute, it will just print me what is your name. Okay, so this is the echo command. So we are using this command. After that, we are using another command, that is a read command. So this read command takes the output from the input that you provide on the shell. Okay, and then it stores into a variables. So here it is storing into a variable called person. Okay, and after that also we are printing we are again printing via echo command, and then we are saying hello and then $person. So if you basically want to print the value of any variable, you use $signs. Okay, so this is a simple trick. If you want to print the value of any variable, you can use $sign. So here whatever the action, whatever the input that we are going to provide on the shell, it will be stored under person variable. We'll be talking variables in upcoming chapters. What are the variables and how do you provide the output of the variable, how do you store that. But I'm just showing up here. You can just don't get confused. You can just get an idea about how does a shell scripting being written. So if you look at like this way, it is nothing but a command, sequence of commands. So there are 3 commands. First command is echo command, then read command, and then after that again echo command. Okay, this read command also, let's say if I say read person. Okay, so it is asking you for the prompt. It is opened a prompt. Now it is asking you to input something. Let's say if I put my name, okay, and then I press enter. So as soon as I press enter, this value Himanshu is being stored under variable called person. Okay, if you want to print out the value of this variable, you can just do echo $ and then person. Okay, and then it will print me the value. So this has become a usage of command read command. Okay, so if you look at this script, it will first print me what is your name, then it will look for any input that you provide your name, and then it will say hello, whatever the name you are going to provide. So now let's save this. Okay, one more thing is to make any file as a script, if you look at the permission of this file, so you notice we have an execution permission X. So if you remember, in the permission chapter we spoke about, X means executable. You are making any file as executable. So when any file becomes executable, that colors also gets changed. It's green in color. So this is advantage of Bourne shell that we are using bash. If we would have used C shell, you would have seen this in the normal white in color. So it will not discriminate in terms of define okay which color to what, in terms of directories to blue, files to white, executables to green. So it does not do that. But Born Again shell has this feature which shows up in a very good way, where you can just identify by the color itself what kind of a file this is. So by looking at this, and we have verified, okay, this has executable permission, anybody can execute this script. You are able to execute. What if I remove this executable? So chmod -x, if I remove this executable from all these three, so you have to remove, or let's say others, or you have to remove one by one. After that, you will see color change there. Okay. So now you see earlier the color was in green because it had executable permission there, but now there is no executable permission. That is the reason you are not seeing green in color. So that is how the shell is basically giving you, just by looking at the color, giving you a feature to identify which kind of a file it is. So now in order to, if I try to execute this shell, it will not execute because it does not have executable permission. Let's try it. Now we have stored commands, and then we are going to execute a script. So there are multiple ways to execute. One way is using, let's say, bash, that saying that I'm using bash command to execute a script. Okay. So now it says, what is your name? If I say Himanshu, and then it prints me hello Himanshu. There is one way. But if I try this way, it will say permission denied. If I try sudo also, it will say command not found. Why is it saying command not found? Because this way you are trying to execute this one script.sh file as a executable, as a command, So this is not working currently because it does not have execute permissions. But as soon as you provide executable permission, it will work. See? So that is how you can execute a script. So there are multiple ways we spoke. You can use like sh also. So this means that you are using sh shell, not a bash shell. Rather than you are using sh and you are executing the same way you execute via bash. So yeah, that is how you can execute a shell, and that is how you can write contents inside the shell. So you can see it here. What if, let's say, I try to create another script, let's say basic script, okay, and then say shebang header, okay, now say pwd and ls. Okay, you can automatically see as soon as I typed the command, the color changed here. But if I say Himanshu, the color does not change because Himanshu is not an existing command on this system, but pwd and ls is the command. So what I was trying to say, just to make you understand why and how shell scripting is so easy, basically it is a language, but this language is used for the commands that you're going to execute on the Linux systems, but to make it a single executable file rather than executing one by one each command. So now let's save this file and say bash basic script.sh. So see, it has printed me the output of the pwd and then the output of ls command. If you look at the structure of this script, first it has a pwd and then it has ls. So that's why it printed me the pwd command output first, and then after that ls command output. So it is nothing but a sequence of commands that you are going to execute in the Linux systems. So that is the advantage of being using shell scriptings, where you don't have to execute one by one each command. So that's how, very basic, I'm just trying to tell you that this is how you can write the shell scriptings. That's how you can write the scriptings. After that you can make modifications. We'll be talking about slowly what are the loops and variables and whatnot stuff are present in the shell scriptings. Okay, so that is, we saw it. What happens, let's say for example, if there is let's say if I uncomment it and then save this, Himanshu is not a valid command. Now let's see. Okay, so it will again print, it will execute the starting two commands for you, because those commands are legitimate. It's not like it will break at the first step itself saying that, oh, this command is not found. No. So you can, if you look at the way the shell scripting executes it, it reads line by line. Okay, so the first executable line was pwd, so it executed the output of pwd, after that ls, and then once it reaches to the output Himanshu, it says Himanshu is not a valid command on this system at this moment. That's why you are unable to, you get this error, Himanshu not found. The same error you will get when you execute this command. So it is a sequential execution of the commands that you're going to add on in your shell scripting. So that is how it works. Okay, now, so it's like, that's why it is so easy to get it. So if we're talking about the prompt, this $, which is useful for kind of an indication as well, to provide the value of any variable, as well as it can provide you the idea about this is a bash shell, this is a born again shell, or born shell. If you say echo $date, so this is how it can print like this also. So you can use this tilted sign, which is nothing but below the escape key in the MacBook. So tilted, so this takes as a command itself, and then it prints the command for you. After that, this $ is also came in the echo, so it's just printing that value to you. So that's how you can do. Then for example, date command you can execute. Okay, yeah. So $ is not a command here, that's why you're not getting anything, but date is a command here. And then it is, so this means something else actually. We'll be talking what are the spatial features of the shell scriptings. But date command is like any command that you can execute here, that's what it is happening on the shell actually. If you want to change the session on this shell, okay, so you can use command bash. So bash will, it looks like same terminal, but it is not same. The reason being, how can you identify? Let's say check history. So in this, is this prompt, you don't find any, we executed some other commands, and exit and then do history. You will not find this echo, this is and all. See, so history itself is different, which means you have created a new session in the shell. Either you could have logged into the same user to a different window, or in the same window you could have done that. But instead of doing that, if you want to change the session, you can just execute bash and it will change session for you. It will create a new shell. Okay, you can exit and then come back, or sh also can take you, but it will not give you that good PS1. We'll be talking about what PS1 is again. But yeah, this is how you can do sh. All right. Now, when we, if you remember earlier also we discussed about this prompt when we were copying the files while creating the users, that skeleton is being copied over from etc scale to the user's home locations. Similarly, that those files also has PS value. This is the prompt. How does a prompt should look like? Okay, so I'll just recall it. This was the file in the home directory, bash rc. If you search PS1, you will get the prompt. Okay, so this is the PS1 which is currently active. So this is the primary prompt. Okay, there is some other prompt called secondary prompt, PS2. We'll be talking about that as well in a bit. So PS1 is this value. This is a default value. Okay, if you don't want to make any changes in the permanent file, which is .bashrc, but rather you just want to do here only for a short time, so you can use command PS1. So you can give like this PS1 and let's say any prompt. Okay, so once I give this, it will change it for me, but that is not persistent. When I say that, what does it mean? If I execute bash, it will create another child session for me, and then at that time it will read that file bash rc again. And in the bash rc we have proper format of PS1, that's why you will see the proper one. But now this is how you can change. You can change anything. You can add variety of colors, you can add images or emojis or whatever, right? You can Google it up the way how to add colors there, and I'm just giving you an idea about how do you change that actually. For example, let's say you change it, let's say this way. So there are more options, /use for user, and then host /host, okay, and then let's say /working directories, and then $, $. Okay, see the difference now. You can see this is the user, this is what /u presents, and then /h is nothing but a host name of this machine. Then there is a space after that, so you notice there is a space here. Then working directory, this is your pwd. After that, this prompt ends with this sign, big bracket, and then $, okay, which represents the prompt again. So you can change anything. Let's say, for example, instead of, so there are many options. For example, you can just say instead of working directory, or give me time. So this will give you the current time. So the current time, let's say the current time is what, 1:55. So it is taking 24 hours clock, and then it's saying, okay, this is your current time, automatically updated. So this way you don't have to again go to the clock and then see the time. Okay, by looking at the prompt itself, you can just see what is the current seconds. Also, you can see that seconds are also changing here, so this is a kind of a good advantage of changing the values of PS1. And if you want to make this permanent, you can make in the bash rc and then added that entry of PS1. It will, once you replace it with this entry, it will go, it will take it up, and then you just have to source that file. We will see that how to make it permanent, but let's review some other options as well. Then -t, then there is -d. You can say date, okay, Monday, January 20th. So this will print like this. What if I just don't want, I just want user and then day. So they remove this start, and I want to say something like this. Anything you can just add, whatever you feel, anything you just. So this is the advantage of being using Linux. You can change anything, in Linux. It can help you perform any actions. So you can have now the date and then time, so you can change it like this. Or let's say, for example, shell also it will print, or let's remove this, give it then /s. It will give you the shell. It is currently using bash shell. What if you want to see w? So this w, capital W, just give you the present directory name, which is shell_scripting. But if you remember small w gives you the relative path, basically, that relatively where are you currently. So relative path is different than absolute path, if you remember. So relative path can start with the like dot, double dot, or this tilde sign as well, like just to represent this is the home directory of my user, and then you're just changing. So for example, like currently pwd is this. If I say it's cd and then tilde, which means I'm going to the home directory of the user StarAgile. Okay, so and if I go back want to go back into the shell scripting, so I can just say cd hyphen, it will take me to the previous location where I was before. So that is the change in the prompt, w and small w. Okay, I'll remove this. I have this thing only. Now there is another example, user, yes, we have seen here. Then host also. Let's say this thing slash this thing. So this will basically to give you the current command. So this increases actually, like for example, ls. Okay, see now it is changing the numbers. So it is saying that in the history, what is this number of that command, 601. This is now whatever you're going to execute will be 602. So this is how it is actually executing and telling you to do that. So that is another good stuff you want to see. But these are like the use cases depending on if there is a requirement to do the same. Otherwise, it's like just to play around, you should be aware about there are a lot of options, and then you can just read the manual, and then it will give you whatever you would want to make a change. So yeah, so it's like you can just play around with it. So we will see some other options as well. Let's say $. It is just printing the UID for you if you're logged in as root. Let's say now it is taking this way. Yeah, so see, for a root we spoke that it shows hash, but for a normal user it shows $sign. So that is a change in the shell prompt. You can just identify by reviewing, oh, hash is also coming up here, and then here dollar is coming. So that is how it defines or it identifies. So this is a normal user, this is not root. So now what we will do is we will make it again changed to what we were doing. Okay, now say host name, remove this time, and then say directory. Yeah, now this looks good, understandable. So you can have n number of options that you would want to apply here. You can just keep on adding this, and then it will take effect. But this is all local. When you open a new session or you log in, let's say if I log in here for user StarAgile, you will see a different prompt. Reason being, I must have set up something in the bash RC file which list out this thing rather than having a host name, just something like IP address or something. So you can make change whatever you would want to based on the file has it. But now let's review the permanent changes that you can do and where you can do. So there's a file called bash RC. Now this bash RC file, if you make any entry for PS1, if you look at PS1, you will see this is the entry currently for StarAgile user. It's local and it's different for every user. So if you just want IP address, hostname -i is the command. So currently you're seeing here username @ and this is the IP address. So this will give you the IP address, but it also gives you the MAC address also and IPv4 and whatnot, right? So this is the tweak I did here using awk command just to filter the first value, print the first value. So that is how it is actually printing and adding up in my PS1. So instead of that, you can just make a change like, say PS1. I just want user @ and host name. That's it. Okay. And if I comment this line here, so now this line will be treated, and I've saved this file. But currently this file is not again sourced. Sourced means this file is not being read until you reboot the machine, or you relog into the same user StarAgile, or you create a new session. But I don't want to do any of this. But then how again I can read this file and make it as a reloadable? You can just think like you make some configuration changes for Apache, and then you can reload the config Apache daemon, right? Similarly for bash rc and stuff, like any source files, you can just execute command source. That means you're sourcing it, you're asking system to read this file again. As soon as you do this, you will see the ps1 value changed. And if you print echo $ps1, so you will see the difference what you are actually using. You are just saying user and then host name. So that is what the current value is being taken for this. Now let's go back to bash rc and make this change. So this is the permanent change that we have done. If you log in, let's say another terminal, and use the zoom it up. Okay, and you log into StarAgile, it will again read this same bash rc for StarAgile, and it will have the same prompt until you, because you make this permanent. But now I don't want it to make permanent. I want it to say dd and okay, and let them be permanent. Source and then bash rc, and that will make it back. So that's how you can just play around with bash rc file. You can just source the file, and then you can change the prompt, whatever. You can have any sort of color. So currently it's in green color, you can have in different colors and stuff. You can just change that. You can just Google it up, how to make it more imported, like emojis and stuff. You can just add those things as well. So people do that. It's like just to see the things fancy, but yeah, you should be aware this is nothing but a PS1 option for Linux. You can just change in the shell settings. Okay, now there is one more thing called secondary prompt. So this secondary prompts basically, what it is if I say PS2, so this is secondary prompt $PS2. So currently my secondary prompt is secondary prompt and then this arrow sign. What does it mean? I'll tell you. How do you see this? For example, let's say echo command, you are using double quote. You have opened a double quote and say this is your learning series StarAgile, okay, for example, and then you forget to end the quotation, okay, and then you press enter. So once you do that, you will be gone to the secondary prompt. Okay, this was a primary prompt and this is a secondary prompt. So now here, until you type something else and then enter, then something else, then enter, so it is not taking the entire output. So it will take the entire output. It is expecting you to end with the double quote also. So as soon as you say double quote and then press enter, so it has taken all these content that you have provided till here, then here, and this. So this has provided you all these things. So this is nothing but called a PS2. This is a secondary prompt. You can change that as well. Like for example, say @ some fancy stuff. Now let's say echo. See, now it will change the secondary prompt for you. But this is again at the local level. It is not has done in the permanent. So if you want to make it permanent, you can again go to bash rc and you can append an entry called PS2. Currently it is secondary prompt. Once you make it change, let's say I want to comment this and then let's see, I want to make it like something like that, okay, and I will source it. Once you source it, and then let's say echo, and then it will take the secondary prompt as a persistent because it has already sourced it. So that's how you can play around with it. And once you close it, So any prompt, it's based on user choice. It's nothing to do with the admin, or nothing to worry about that something will break. No, nothing will break. It's just that how a user interactions of a shell that you're basically doing, you can just manipulate things. So that is what the customizable functionality of Linux, it leverages. It provides the facility for to the user, saying that you can change anything, whatever you would want to. So similarly for shell also, you can change the prompt. So for now I will just remove this and make this applicable and source it again. Okay, see, secondary prompt, that's it. So that's how you can just play around with the shell, and you can various options you can use, and then you can, based on that, you can change the settings that you would want to change. So yeah, that's about the introduction of shell scripting in the Linux. All right, so let's continue our shell scripting demos, and we will further see towards the conditional statements and the loops as well. So in this session, we'll be talking about various loops, for example, while loop and for loop. Also, we will see some conditional statements and operators which we use for operations, various operations in the shell scripting, using if statement, else statement, or elif statements. So let's go ahead to our demo machine, and then we will start further. So let's talk about the if statement actually. So in if statement, if anybody is familiar with any programming languages, so it's like a similar functionality, just that the syntax value could be a little different in shell scripting, but the functionality of if statement is as equivalent to any other languages, let's say Python or Java or whatnot, right? So if we look at the example over here for if statement, so you will see initial we are saying that this is a shebang header, which means we are executing shell scripting. Bin bash is the shell what we are disclaiming here. After that, there is a variable that we have defined. The variable is num, which is a number. It has a value 10. Okay, now this is a if statement. So in Linux, the if statement is being written like this: if and then condition in the big brackets. Then this is the condition that we have say. After that, once this condition matches, then echo print some values, okay, some string or whatever you want to print, and after that fi. So this fi statement is being used to terminate the if starting if block. So if you don't say fi, then this if block will say syntax problem or something. So because you have not you have opened the conditions, but you have not closed that if statement. So, and if we talk about these conditions, we will see various conditions in the if statements. So this condition says if the number, the value of number, which is 10, is greater than this GT is for greater than operator. If it is greater than 5, then we will say number is greater than 5. Okay, so let's save this file, and I hope this has execute privileges, and I'm able to execute like this. So if you execute this command, it says yes, kind of number is greater than 5, because the number 10 is always greater than 5. Let's make some changes based on our things. So we can say, let's say for example, okay, say dollar number. Let's try something like this. Okay, so what we have modified in the script is, we have first said the number, the value of number. Say that the value of number, which is 10, number is greater than 5. Okay, so this 10 is greater than 5. You can make modifications, any modification that you would want, or just remove this. So say dollar number is greater than 5. Okay, this makes more sense. So you can just execute, say then 10 is greater than 5. Okay, so that is how you can execute any script, and you can use the if statement in the Linux command. Okay, now let's talk about the if else statement. So if else statement if I open. So I've created a script, but I'll explain what is the content written inside this. So I have defined a number is 3. Okay, if number is greater than 5, then echo number is greater than 5. Okay, else echo number is less than or equals to 5. Okay, so currently this number is 3. So this 3 is never be greater than 5, so it is going to be less only, so it will say number is less than or equals to 5. Let's modify this and we will say $number is less than or equal to 5. Okay, let's execute. If else statement, 3 is less than or equals to 5. Okay, so 3 can never be greater than 5. All right, so this is like a else statement. How is it being defined? If you look at here, so if the first line is if the condition, and this is the condition, if it matches, then do something, else do something else. Okay, so this is like a if else loop, and after that you have to anyways close that if statement, because if you don't close it, then this statement will never be completed. So that's why. Now let's do this. Let's make some modifications. Say number, read number. Okay, we will utilize our previous things that we have done. So this time I'm not using the predefined thing. So this time I'm asking, my script will ask me number on the fly and say that please enter the number. So we'll say, let's say I say 10. So 10 is greater than 5. Okay, let's say 15, it's greater than 5. Okay, or 100 is greater than 5, minus 1 is less than or equals to 5, 2 is less than or equals to 5. So this is how you can make it more interactive, where you can ask user to provide the input, and then once it is stored in the variable, and then whatever the logic your else statement contains, it just performs that logic. Okay, so this is the if else statement. Now we will talk about if elif statements. So if you look at here, it's like almost same. It's just that what if there are more than one conditions? In that case, what will you do? Okay, so for example, if the number is less than 10, this LT denotes for less than. Okay, if this number is less than 10, then number is less than 10. Okay, if else elif another condition, number equals to 15, then number is 15. Okay, else if these two conditions does not match, then what is the output? Echo print this number is greater than 10 or but not 15. Okay, so for example, this here you see the number 15 is there. Number 15 is not less than 10. Okay, which means this condition will not work, because this condition says if the number is less than 10 but the number 15 is greater than 10, so this condition will not be matching. After that, another if says if the number is equals to 15, yes, the number is equals to 15, then number is 15. Okay, if the suppose the number would be 16, in that case number is not less than 10 and it is not equals to 15 also. The number is greater than 10 but not 15, so it can be 11, 12, 13, 14, 16, anything, but on 15 equals to, operator says if it is equal, then it is 15. All right, so number is 15, whatever we have passed, that's why you are getting 15th here. But let's see, let's modify this again. Okay, let's say enter your number. Okay. If else statement. So this condition, there is some issue here because it's reading as a single line. It will not work like this, but this would work. Else, okay. Enter the number. Let's say if I enter 20, so this number 20 is greater than 10 but not 15. Okay. Let's add one more condition. So in elif you can add a number of conditions. Let's say echo. So you have to make some justifiable condition. So if I make like less than 10 equals to 15, number is greater than 20, then let's say, let's make it 20. Okay, if it is greater than 20, so I will just say $20, else this thing. Okay, let's say 90. So command not found, there must be some issue, line number 10. So it gives the error also. If in case there are some issues in the at any line, so line number 10 there is an issue. The problem is that elif number greater than, okay. Let's see, this should echo number is this, number is that. Okay, 100 is greater than 20. So what if I say 20? So number is, okay, there is some issue with the logic. Okay, number is 20. Now it will make more sense if you enter 20, which means 20 is equals to 20, so number is 20. If I say number is 10, so number is greater than 10 but not 15. So this also we have to correct. So if it is 10, we can have one more condition, less than is equal to 10 but not 15. Okay, let's say 10. So number is equal to 10 but not 15. Okay. What if I say -1? So number is less than 10. Okay. Let's say 11. Number is equals to 10. That is also wrong. We can have one more condition. Number is greater than or equal to 10. Greater than or equal to. So you can make the conditions as per your choices. You can change it, the logic, and you can just take out the use case. Let's say 11. So number is greater than or equals to 10. In case of 10 also, you can say number is greater than or equals to 10. Okay. What if 20? Number is 20. 21 is greater than 20. 1000 is greater than 20. So that's how you can make more elif statements. Similar to this, you can add more if else statements also. You can have multiple conditions based on the use cases that you come across. So you can make the changes as per your use cases. After that, if we talk about some operators, so there are certain operators. For example, one of the operator is like equals to operator. Equals to operator. If I open any file, let's say test file operators. So there is operator called equal to operator. Equal to operator, which means if you are comparing two values, for example, 10 is equals to 20, so you can use for example, like 10 equals to 20, 10 equals to 10. So you can have this equal to operator, and always make sure that you create in the big block. Okay. Yeah. So this is a equal to operator. The another operator is not equals to. So when you're not, when you are sure that this value, let's say 10 is not equal to 20, because 10 is 10, 20 is 20. So you can have not equals to operator. After that, you can have greater than. Okay. Greater than is let's say 10 is greater than 20. Anything. You can have any logic where you can just try to compare if 10 is greater than 20 or 10 is greater than 5 or whatever, right? So you can have any conditions, and then similar to greater than, you can have less than. Say 10 is less than 5. 10 is less than 20, something like that. Then there are other operators like this: less than, equals to, then less than or equals to LE. So this will compare less than or equals to. So this has both conditions. So let's say, for example, you're comparing 10 is less than or equals to 10. So this equals to is just to make sure that both values are equal. If you are choosing this, so this has a condition where it says the value is less than whatever the value or equals to it. So it can basically compare a less than also. It can basically compare the equals value also. So you can have n number of logics like this, but these are the operators which are generally being used or present for the shell scripting, mostly being used in these statements that we have seen so far, if elif or if else statement. So these are the operator logic that you can do. Okay. After that, there are some string operators also available. So for example, if I say this string is used for equals to sign. So if a string is like equal, for example, let's say I say test equals test. Okay. So equals to operator is being used to compare the two strings, if the two string values are same or not. So for that you can use equals to operator. Okay. Then not equals to is there, which says any string which is not equals to. So you can compare like this. So strings are not equals to. After that we have string is null or empty. So -z is used for null or empty string. Empty string. Okay. After that we have -n, which says string is not null. Okay. These are the other operators that you can use in your elif statements or if statements or any Linux shell scripting statements. You can use these operators as well. So let's try to compare some strings. So let's see string comparison thing. So we have a string called hello, and we are trying to use this operator equals to. So if the string whatever you have passed on is hello, then we'll say strings are equal, otherwise strings are not equal. So instead of this, I will just say echo enter the string. Okay. And here we'll say read. So whatever the input we will be providing, it will be stored in the string variable. Now let's execute this. Okay, let me say Himanshu. Okay, so it says strings are not equal. If I say strings are not equal. If I say hello, then also it says strings are not equal. Why? Because it is case sensitive. So the h is very small in the small, that's why you are seeing strings are not equal. If you provide capital H and then you see, it will say strings are equal. So shell scripting is also case sensitive, like Linux, it considers the case and it privileges, keeps that case sensitivity separate, and that's how it treats it. So that is how you can monitor and measure that comparison. After that, let's modify some changes here. Elif dollar string equals to trainer, then echo strings are equal. Okay, else if you say hello, string is hello. String is hello, or we can say like this, string hello is hello, or here you can say string is string or something, trainer, something like that, and equal. Any sort of logic you can implement, and then you can use it up here. Okay, let's execute this now. I will say trainer. So trainer is trainer and equal, so which means that both strings are equal and the string value is trainer. If I say StarAgile, let's say for example, so it says strings are not equal because we were trying to compare with two logics. One is trainer and one is hello, but it did not meet any of the conditions. StarAgile is not hello, nor it is trainer. That's why you are seeing both are unequal. Okay, so you can compare strings like this. Also in the strings, let's say let's make some changes. Else, let's see, elif string -z is null, then string is null, there might be some syntax issues with this. I will have to see the syntax actually for unity operator, so and then we'll correct it up. But yeah, like if you want to compare if the string you're passing is empty or not, so you can compare, and then you can after that you can basically set up your logic. Not sure. Yeah, it's still not expected behavior. No worries. After that, there are few other logical operators are there. For example, like and%. So if you're passing 2 times %, that value means a logical and that you can compare it and use it. So if you have in your studies also, you must have seen the various operators available in various languages. So in shell scripting also, these are the operators which are basically being used, and then you can based on your logic you can implement those operators, and then it will work for you. Let's say for example, if we have anything logical operators, so let's say this is the script that we have, and I will delete this, and then let's read the number, enter the number, read number. Okay, if number is greater than 10 and %, so this is basically checks the two conditions. One condition says if the number is greater than 10, second condition says if the number is less than 30. So it should meet both the conditions. If it is not meeting, that means this will go to the else statement. If it is meeting, then only it will read the output that you are passing. So if it meets, so let's say we pass a number, if the number is greater than 10 and the number is less than 30, so the number will be definitely between 10 and 30. So to make it more clear, we will say $number and then save it. Okay, or here also we will say $number. Okay, right, let's execute this, enter the number, let's say 100. 100 is outside the range. What if I say 11? So 11 is between 10 and 30. So these two conditions can be together checked by using logical operator %. Okay, also let's say 20 is also within the range, 29 is also within the range. If I say 30 is outside the range, because the second statement what we had is for if you remember, if you open it up, second statement is for the less than. Okay, what if I say less than or equals to? Then let's see what happens. So 30 is not less than 30, but 30 is equals to 30. So it will say 30 is between 10 and 30, because we have changed the condition from less than to less than equals to. So if it is equals to, then it will or if it is equals to or less than, then it will be considered between 10 and 30. Okay. Yeah, similarly for greater than equals to, you can use GE, which is operator, and it will say that if your number is greater than or equals to 10, then also it will be considered for this statement. It will hit it, and then it will print whatever the number is between 10 and 30. So that is how you can use logical operators here. Now let's talk about loops. In shell scripting there are loops. It's commonly used. So for example, for loop, so I will talk about how does a for loop is being defined, and then there are some loops like while loops also. We will see how do you set up the while loop, what is the condition expressions for that, and how do you print the output, or whatever the action you would want to perform after that condition is matched, then you can perform accordingly. All right, so let's talk about for loop. So usually for Linux, the for loop is like anything, let's say like that, and then okay, so then yeah, so in for loop like Linux, you can use a statement called for. Then I, you can assume like an object, I object, and the value of I you are passing it from a range. So this is how you define a range. For example, if I want to define 1 to 100, so I can say like this 1 dot dot 100 and then curly braces. So this will take a range of 100. This will take a range of 1000, 1 to 1000, or let's say 100 to 1000, or you can have any range. So this defines a range. So once the I is meeting that range, means you are passing the value of that range to the I. So how will it be read is, since we are providing the range from 1 to 10, which means that let's pick first value. Okay, first value is 1 of a range of 1 to 10. So that first value will be allotted in I. So I will become for 1. And then once I is 1, then it says do. This is a statement syntax. How do you have to define it? So once this is matched, okay, once you have defined it, after that, what do you want to do? So that is what this do is all about. So it says what you have to do is echo $I, okay, which means you just print the value of whatever the I is currently, and then done. Okay, after that it will again, since it is a range, right? So range is, until the range is over, it will keep on changing the value of that object. So here the value of object I would be from 1 to 10, 1 2 3 4 5 6, like that, up to 10 the value would be. After that you are doing some changes, you are just printing the value of I, which is 1 to 10, and then you are just closing that loop. So that's why you are seeing value of 1 to 10 is being there. What if you want to change the value from, let's say, 10 to 20 I want to print, or 10 to 25 I want to print? So you have to say like this: choose range from 10 to 25. What do you want to do? The number is now $I, okay, and then done. So it will say the number is 10. So it is changing that value from 10 to 25 because you have provided a range from 10 to 25. Okay, and what it is doing is, this is a string which will be same for all the occurrences. Okay, this is same, and then it will just change the value of I. So $I is nothing but a value, and the value is coming from this range, which is 10 to 25. That's why you are seeing the number is 10 to 25. Okay, now we'll see 4 over iteration over a list. Let's say over list. So let's talk about this. We have a for loop. So this is the example that I showed here. You can normally you can just execute the for loop like this. So here you see the breakage of that condition is using semicolon. Okay, and then this is statement. But what if you want to write in a shell script and then execute? So you have to do this. You have to break this condition and then do whatever you would want to do, and then done. So here you don't have to provide semicolon after echo, because this is how the shell script syntax look like. But there we were executing the for loop not by shell scripting, by directly providing that for command. It's kind of a loop only, but there were multiple commands, so we were using semicolon. As we have seen, to provide the multiple commands, if you want to execute, you can use semicolon there. So in this condition, in the for item, instead of I, you can think like this is item, it's a variable. Okay, now we are picking up the item as a string from these 3 strings. So we have 3 strings. One is apple, banana, and cherry. Okay, what you have to do is, after that, echo fruit and then print the value of the item. So one would be apple, another one would be banana, and cherry. So there are 3 fruits available. So you can just say fruit is this. Okay, yeah. Now let's execute over list. So the fruit is apple, the fruit is banana, and the fruit is cherry, because there were 3 fruits only. What if we say, let's add couple more fruits, or okay, So if we save it and then execute, it will print all the fruits that you have provided in that list of iterations. So it will pick one by one. Let's say it picked apple, then it read the statement echo print fruit is, and then the value of fruit, which is apple. Similarly for banana, cherry, mango, and kiwi. Okay. So that's how you can use over list iterations by using a for loop. Okay. Now you can use over range, so that we have already seen in the command line by using range, but here also you can do the same stuff. For range I is 1 to 5, then do number, whatever the number is, and that's it. So let's say for iteration over range, what is it? So this will say it will pick the range from 1 to 5, and then it will print the values of those ranges. After that, for loop can be used as a iteration with the step. So when I say step, what does it mean? Over step, over list, over range, over file. Okay, let's create otherwise. For iteration over step, iteration with step. Yeah. Okay, so here what you have done is you have picked up a range. The range is from 1 to 10. Okay, but you have passed on step. Step means you just skip one level. So at the step of 2, you just jump on the word. So for example, from range 1 to 10, you are jumping one word, which is like 2 steps. So directly from 1, you are just going to 3. Okay, 1 plus 2, you can think like this. After that, the next after 3 would be 5, then 7, and then 9, something like that. So if we execute with step, so this will say 1, 3, 5, 7, 9. So you can use like this. You can add, let's say 1 to 100 at the step of 30. So this will print 1, after that 31, 61, 91. So as number of step you would want it to be skip or go to the next level, so it will just jump like this. So that is advantage of being using steps. Let's say okay, something like this. I'll just jump 1000 steps. So 100, starting from 100, then 1100. So every 1000 it is just going till 10,100, because after that 11,000, and we don't have 11,100. So if you add 11,100, it will take that as up as well. Yeah, so it will pick it up, the last one. So that is how you can iterate the loop over steps, where you can basically add on this much steps I would want to go ahead and then iterate in my loop, and then you can just change it up accordingly. You can use based on your use cases. Now let's talk about iterate over files. So this is very important because in Linux you have to come across processing the files and perform certain actions. For example, you want to pick all the files which has .sh suffix, and after that you want to process it. For example, you want to export that, or you want to send it to a different server or forward it. So whatever the action you would want to do, you can do that. Whatever we have learned so far in the Linux commands, and anything, start a service or stop a service. So you can automate that step by using shell scripting. So shell scripting can be like a complex depending on the use case what you would want to do, but I'm just trying to give you an idea about how do you use these small steps, and then you can create your own complex use cases shell scripts. We will see that as well in coming up in shortly. We will see like what are the common use cases on the industries, in the industries which people use it, and then we will see how are they basically being implemented on the shell scripts. So this script basically is iterating over files, which means that it is picking up the exact file and then giving you, currently it is just printing processing file and then file name, whatever the file name is there. So let's say, for example, if I execute, okay, so whatever the files are currently present, so if you look at here condition, it is picking the file variable in, this is the wildcard entry. So wildcard, this star means anything, okay, anything which ends with .sh, where it is checking your current directory, the present working directory, the PWD. In the PWD there are files which has .sh extensions. Just pick all these files and put it into iterations, and after that just print processing file and the file name. So if you look at ls, so there are a lot of .sh files are present, okay. So these .sh files is what it is picking one by one, and then it is printing up. So for example, like one script.sh, archiving, deleting old file.sh. So these are the files which has .sh. You will not find any file which does not have .sh here. So for example, if I say so I wanted to see any file which does not have .sh. So I try to ignore that, but there is no such file which is present as per the output of this script. So every file has .sh inside it. That's why I did not receive any of the output. What if I say, let's tweak this, and instead of .sh, we'll say CSH, okay. So now if you execute, yeah, currently it's not printing anything because it just says, okay, processing file star.csh, because there is no such file present. So, and after that on top of it, I said grab -b.csh, so don't print anything which is not csh, or if I say sh, then it will print only sh. So what if, let's say, if I say let's pick star.txt, okay, and then let's print it. So there are two files which are ending with, one is users to delete.txt and one is users.txt. So these are the two files which has .txt. That's why these two files are picked, okay, and none other files are matching, because this condition we have it. Wait. The condition that we have it here is defining that what all file it has to be picked. So star.txt means only the files which has txt extensions, only pick those files, otherwise don't pick any file. So similarly, you can make any changes, like a zip file or any file you want to set as a condition, you can set. So that is how you can iterate over files via for loop. Now let's talk about while loop. So while loop is another loop that is being used commonly. If we see the use case of while loop, we will see the syntax. For example, let's talk about countdown. So there is a counter that we have. So the counter is 5. Currently the counter is set to 5. Now we are adding this while condition. We say while dollar counter, the value of counter, which is 5. If it is greater than 0, yes it is, then print countdown 5, and after that countdown change the counter value, which is what, counter -1. So it is basically reducing the counter by 1. So for example, the first value would be 5. So if 5 is greater than 0, it will print countdown 1, countdown 5. After that it will reduce it to 4, then it will print 4, then 3, 2, 1, and then that's it. 0 is not greater than, that's why it will not print 0. So let's start countdown sh. So this is how you are getting it. What if I make some changes here and instead of greater than, I say greater than equals to. So after that you will see 0 is also inclusive, because we have made some changes in the conditions which is including 0 as well. So that's how you can. Now let me delete this, go here, counter value, read counter. Okay, this time I want to reduce by 2. Okay, let's provide the counter value 50. So you see it is reducing the value by 2 because we have made the changes here in our conditions, saying that reduce it by 2. That's why the first value that we have provided by the read counter, it is 50. Okay, we have provided value 50, then it will reduce by 2, then 2, and then it will come back to 0. So that's how you can make changes and play around with the while loop by using operators. So that's how while loop is usually being used, and then you can make changes in conditions. So here we are basically trying to understand the syntax of any loop, for example for loop or while loop, but the way is like you can manipulate, you can create the use cases, whatever you guys have it, but I'm just trying to give you an idea, the overview about how do you add the expressions, how do you make those syntax correct, how do you make sure small operators are being rightly used in the shell scripts, and then after that you can make any changes based on the use cases, and then you can apply those changes and execute the scripts accordingly. So after this, let's read the file by using while loop. Read line by line, let's say. So here we are basically while read lines, whatever the line it is, and then okay, it's another line. So we are basically reading this file itself line by line. Okay, so that's what it meant. So we have provided, this is like a good use case where basically you are providing the input here itself, the file. So this is the file while read line by line. From this file you have to read lines. So this is a, you can say like in the while there is a method to read the line. So this will read line for you. Let's say it will read first line, which is a shebang header, and it will say line, then line, shebang header, after that second line, third line, and fourth line. So it will read line by line and provide the output to you. Also we can make some modifications here. Counter, let's say 1. Okay, line, and then counter +1. Let's see what happens here. Okay, so now you can see this. It is reading this file as a input, argument input, and then it is reading line by line. Line number 1 is this, line number 2 is this, line number 3 is this. So it is giving you with that number as well increment order, and then it is providing you number of lines. Let's say, so this has provided us the output. There are total 8 lines. The similar, if I try to open it up and say command set nu, I will also see the 8 lines are present. What if you want to say, some other script, let's say, let me see what all scripts are there. One script is there. Okay. Let's read through that. Wait, sorry. Yeah. So now as soon as I change that script from which it has to change the value, it will start picking up that file, and then it will see there are total 8 lines, and then this is the content based on individual line, whatever it has it. So that's how you can read through line by line in while using while loop, and then you can make modifications, whatever. It's like a use case of reading the lines line by line. So that's kind of another examples here. Now there is one more loop called until loop. So basically until loop executes a block of code until the conditions becomes true. So once the condition becomes true, it will stop. So let's say we have a until loop. So let's say the counter is 1. Now we are having until loop here. If the counter value, which is if it is greater than 5, 1 is not greater than 5, then it will increase. Okay. So the value would be, if it is greater than 5, so it will print until the value is greater than 5. Okay. So for example here, if it is, for example, and instead of until, I would have put if here. So it will read this condition and it will say, oh, this condition does not matching because 1 can never be greater than 5. Okay. But in this case, we have replaced if to until. So what until it is doing? So until is saying that this condition 1, until 1 is greater than 5, do this. Okay. And then keep on increasing the counter. So 1 is obviously smaller than 5. So it will print count 1. After that 1 will become 2. Then it will say 2 is also not greater than 5. So you can just understand like this. If this condition is not true, then print this, something like that, opposite of if. So the output you will get here. So once this counter will become 5, since 5 is not greater than 5, so it will print 5 also, but 6 is greater than 5. So until this condition is matching, it will break automatically. So let's try to execute this. So it will say 1, 2, 3, 4, 5, because as soon as the counter became 6, 6 was obviously greater than 5, so the condition is matching. Or if you think like that way, opposite of if. So if is the condition, which is the condition. So it's, if it is greater than 5, then close it up. So until the condition is not matching, that is what the until loop is all about. And it will actually start printing that value, and once the condition matches, it will break the loop for you. So that is kind of an interesting loop. Sometimes at the corner cases it may be useful, but you should be aware about how to you can just manipulate and then use until loops as well. You can use, let's say for example, here also we'll delete this. Let's make some modifications here. Read counter until counter is greater than, let's say I would say less than, okay, less than or equals to, okay, say minus, okay. So this will start printing. So 100 is not less than 10. Once it is matching the condition less than 10 or equals to 10, it will break the loop for me. Until that, it will start printing whatever the value you are basically doing it. So as soon as I type 10, so 10 is obviously equals to 10. That's why it just breaks it for me. If I say 9, it breaks it for me. If I say 0, it breaks it for me. If I say -1, it breaks it for me. But if I say 11, then it will print 11. So, and then it will reduce the value by -1, and then once it reaches to 10, 10 is equals to 10. That's where the until loop closes its execution, whatever it want to execute. After that, we will see the break conditions as well. So break condition is basically being used to break the loop wherever the condition is there. So let's say, for example, we are taking a range and we are comparing if the range is, the value from that range is equals to 10, equals to 3, then break it up. So, and then otherwise print the value. Okay. So let's say, so number 1, 2. Why did print 1, 2? Because first it is taking a range which is 1 to 5. So 1, 2, 3, 4, 5. Let's say it picked first value which is 1. So this 1 is not equals to 3. 1 is less than 3. So this condition will not be matching. And then this loop, you can forget about this. And then you just go here at this line and say, okay, echo print 1, whatever the value of $I, which is 1. After that, it will go again, and then since it is a range, right, so it will pick second. So 2 is not equals to 3, so it will print 2. 3 is equals to 3. As soon as the condition is matching, then we are breaking our loop there itself. We don't want further processing to happen, so that's where you just break the loop out. So that's how you can use the break statements. Okay, now you can make changes, and then let's say if I say 5, okay, and then only break. So 1, 2, 3, 4 will take. As soon as the number becomes 5, 5 is equals to 5, and then we are breaking the loop itself. Okay. Now we will see the usage of continue. So continue loop. In this, what we are doing is, if the condition is matching, then also continue. Okay, don't break it. It's just the opposite of opposite of break. So basically, it takes the range from 1 to 5, and then it says if $I, which is 1, for example, it's not equals to 3, then print 1, then 2, and then 3. Once it becomes 3, so you can just say continue, and then it will further process accordingly. And then we will see nested loop. So nested loop also. So nested loops means that loops inside a loop. When you want multiple loops to take place inside one loop, so you can have a nested loop. For example, here you see we are defining 2 loop values. One is this for loop. What it is doing is, it is taking a range from 1 to 3, and then from that range it is saying for j, one more loop which has a value 1 to 2, and then it is printing the output for you. So basically, it is saying I equals to 1, then it will take 2 and then 3. Here it will say I equals to 1 and then 2. So multiple combinations it will make from 1 to 1, 1 to 2, then 2 to 1, 2 to 2, and then until this condition. So I value can be 3, 1, 2, 3, and j value can be 2, 1 and 2. So we are trying to make the combinations from 1 to from I to j. So I can be 3 values and j can be 2 values. So multiply by 3 to 2, 6 combinations will be there, and that's how you are seeing that 6 responses in the result. So that's how you can create the multiple nested loops via shell scripting. So that is kind of an advantage of using loops, and you can manipulate. I'll make some more changes here, and then we will see the combinations. Let's see 1 to 10. So now we will see 100 combinations, 10 into 10. Okay, if you want to print number of lines, it will say 100, because 10 into 10 combinations will be there. From I1 to 10, I1 to J1 to 10, then I2 to J2 to 10. So like that, it will create 10 into 10, 100 combination. So it's like, you guys must have seen in Java also, Python also, some other languages also. The loop are being commonly used, the nested loops are commonly used. I am just trying to showcase here the basics of loops, where we are seeing the syntax and how do you use such loops and how do you perform the nested operations. Then we, in this session, we looked up on if statements, elif statements, else and if statements. Then we reviewed the break statement, continue statements, then while loop, for loops. So here we just check the normal conditions, but in the real use cases of in the Linux, we will see that what are the real use cases as per the industries. You can fetch the number of files, you can iterate over list or files or stuff. So those are the things you can do via using Linux shell scripting loops, and you can play around with the use cases that you have. So yeah, that's about loops, I would say, in Linux. All right, so we have reviewed the various loops available in this shell scripting, and we have also seen what is this shell and what is tiny typewriter, where the application programs gets executed. So far, we have listed down the basic concepts of shell scripting and various loops. For example, if loop, while loop, if else loop, if elif loop, for loop, until loop. Then there are statements, for example, continue to skip a particular statement, or break to break the loop at whatever the condition, until loop, until the condition is matching, run the loop, after that breaks the loop. So there are so and so forth, operators also we have discussed. And in this session, we'll be talking about mainly the arguments and the variables that we have been using in the shell scriptings. So let's talk about those variables and arguments that we pass on in the shell scripting. So you must have seen some random values generators and stuff like that. So for example, there are some predefined variables which are present and belongs to the shell. For example, pwd. So if you want to print the output of present working directory, pwd command can also do the same stuff, but there is a variable which is available to the local and as well as the global variable. And once you execute, try to print the value of that variable. So there are some predefined variables. For example, pwd is one of that. So this dollar means you want the value of this pwd variable, and what I want to do is I want to echo it, which means I want to print the value of pwd. So this is kind of printing that value. Similarly, there is some random variable which is also there, which basically prints the random variable every time. You want a random value generators, so it prints that value it for you, but it has a limit, like from 0 to 32,767. It basically prints that value from. So it's kind of a random generator, you can see. Then there is something called path. So path is basically, I think we have seen this in the file hierarchy systems when we were talking about various paths in Linux systems. So path is nothing but these are the locations. If you keep any command in this location, the command will behave like, like any executable file can behave like a command. We will see that shortly. How do you create your own command? Basically, you just have to put that executable file with whatever the name you want to create as a name of a command, and then you can put it into any of these locations. It will be treated as a command for you. So that is a path variable where you basically export the paths for the executable files. Then we have terminal. To print the terminal, what terms are you using? So this is nothing but related to some terminal. So it is using 256 color xterm based application as a term. Then if you want to print the UID of the user that you have currently logged in, so StarAgile UID is 1005. You can confirm this by etc passwd. This we discussed while creating the passwords if you remember in our previous chapters. So StarAgile, this is the UID and this is the GID. So UID of StarAgile user is 1005 is what you are getting from the UID variable, which is also a global variable, but that thing depends on with the current user that you have logged in, it will tell you the UID for that user. If I switch to, let's say, Himanshu1, in that case it will print the UID for Himanshu1 user rather than printing the UID for StarAgile user. So you see the difference here. So that's how the UID variable is being used. And then there are some language variable also, which you can use to see which language it is currently using my keyboard. So it's using US English UTF-8 encoding. Basically it is using that encoding methods. You can change that settings as well, and then you can manipulate it based on the customizations requirement for your Linux systems. You can do it. Then there is one more, we have important one is a home. So this is nothing but a home directory, what you see for any user. So for example, StarAgile, the home directory for StarAgile is /home/StarAgile. If I log into, let's say, Himanshu1, so the home directory for Himanshu user would be /home/Himanshu. So we will see that in a bit. Okay. So this is how you see the home directory. It prints for any user, whatever is logged into your systems. Now let's talk about some variables. How do you define the variables? So for example, in Linux shell scriptings, variables can be defined like let's say var, var1. It can have A to Z, okay, or capital A to Z, or 0 to 9, any numbers you can have, or underscores also it can support to create a variables. But things to note, for example, let's try to create some variables and we will analyze how does it work. So for example, I can create any variable with starting with underscores. Let's say var1, I'm passing the value Himanshu, okay, and I want to print the value of that variable. So I can use var1. So it will print me the value of underscore var1 variable. Okay, you can create a variable with capital letter also. Let's say var, which is, let's say, test, and then echo $var. It will print the value for test. So it can start with capital letter, it can start with small letter like this, and both are different. If I say echo $var, as we spoke that Linux is a case sensitive, so it takes a variable also as a case sensitive, where it is in case of lowercase, it is printing and accepting the value for whatever the value you have provided for the lowercase, and for uppercase it is taking the value whatever you have provided separately for the uppercase. And you can also create a variable with a numeric digit, for example 1 variable, and say uu. Uu is a command, so command okay, means it is not accepting that for you. Okay, so you cannot create this is like invalid examples of creating any variables. You can create like let's say var underscore 1, so that also works here, and you can just print the value of var underscore 1. It will print yy for you. So these are like common ways of creating the variable. Just two things to note, that it can accept small a to small z, then capital A to capital Z, then numeric 0 to 9. Now there are some ways, or I would say there are some variable definitions which are not valid in terms of Linux. For example, you cannot create any variable with numbers, what we were trying to do before. So when you try to create any variable with numbers, it says command not found. So basically it tries to think that are you executing any command, but there is no such command called var -text. So it treats this as a command rather than a variable. So this is unacceptable. Linux does not accept it. Or you are using hyphen, let's say var -1. That time also it is treating this as a command, so it's saying command not found. So this is also unexpected behavior in terms of setting up the variable. You cannot use hyphen. You can anytime use underscores. Underscores works, but not hyphen. Okay. Now after that, you cannot use any special characters. Let's say I want to use exclamation. That time also it says this exclamation is not identified. So exclamation mark is also invalid pattern of providing the variable information. So this is also not a valid one. Also, you cannot like with hyphen, starting with hyphen also does not accept. In between hyphen also it does not accept. So hyphens are not acceptable. Anything other than underscore as a special character is not acceptable. Then it cannot start with a number, that is also not acceptable. So these are the variety of acceptable options, or I would say variables which are not allowed in order to create it. Now what you can do is like you can access the variables. So these are the variables that we have defined, and you can access it anytime by using $sign. For example, let's say var1, there is no variable, then it's okay. One var, you can print the value of that variable, whatever the variable that you are going to create. So these are the variables called scalar variables, which means that it stores the value once. And if you, let's say I have a variable var1 and I say value Himanshu, and if I print the value, it will print the value Himanshu to me. Why I say scalar? Because next time if I change the value of var1, this time it will basically change the value. So it replaces the value. It's like, you can think like a volatile memory, right? It just replaces the value quickly. It's nothing permanent until you create any shell level variable or any global variable. So these are the local variables, scalar variables, which means you can change it anytime, in the same session also. These variables cannot be applicable on any other session. So for example, currently you see we are getting a value of var1. What if I create a new shell session? So in that case, if I try to do echo, it will not recognize this variable, because this variable is not was not created on this shell. It might be created on some other shell. That's why those are the variables are local variables, not being used or not being can be usable for any other shell. So if I go back to my previous shell by exiting the connection, so as soon as I exit the session, I am able to do a var1. So it is giving me the response back. That's what the beauty of creation of the scalar variables, where you can just manipulate the values whatever you would want to do n number of times here on the shell session. So those are the variables. And you can similarly like create script for variables to access it. For example, let's create a script variable .sh, example like this. Okay, we'll say shebang header. See, shebang header is not required. It's just that a denotion of showing that we are going to write a shell script here. So that's why. Otherwise, it's all fine. So I have a variable which I say Himanshu. Okay, now I'll say echo. Here is the variable. Okay, so now variable.sh, so it is printing me the value of a variable whatever you have assigned. We can make some modifications here. Instead of doing this way, we can see this echo. Okay, then it is reading variable and then it is printing again. Please enter the variable value. Let's say I enter StarAgile. Okay, after that it says, okay, the here is the variable value which is StarAgile. So you can use the same concepts of what we have been seeing in the previous chapters while reading the arguments from the command line, and then you can use this concept of variables, and then you can provide the variable, and then you can get the output of it. Now the same script, if I execute from another session, this will work. You will get the output of here is the variable value StarAgile. Reason being, in the new session also, you will, when you execute this script, since this script has the content where it is always trying to get the variable value on the fly, and that's how it is able to respond back. See, what I'm trying to say is, let's say if you execute the same script, it prints the value whatever I say, because it is asking every time the value from you. So doesn't matter which session you are on, since the wherever session you have currently logged in, on which shell, you can just pass on this value, and then you can get the output of the variable. Okay. That is this scalar value variable use cases. After that, we will see read-only variables. So read-only variables are basically the variables which can be set as a read-only variables. So so there is a syntax to set a variable to a read-only. For example, like let's say read-only. Okay, so let's create a script. Okay. Now read variable. I think you can do like this also, and then echo. $where. We have not read it, that's why. Read only variable, then we can have echo. Okay, so the value is, so this variable is currently the read only. What I say when I say read only, so for example like this, if you assign any variable, okay, and you make this variable read only. Okay, now if I try to make any changes further to this variable, so after that you get a complaint from the shell, a message saying that this variable is currently in the read only variable. Once the variable is marked as a read only variable, you cannot change it, like you cannot update the value of any read only variable if you are into this current session. So until you change the session, or you relog in with same user or another user, and then go to the shell and then create a variable, this will be like set as a read only. So this will not be used for any other values, it cannot take. So that's the use case of read only variable. So it is basically being used, you can think like a constant, the value is always read only, so which means it cannot be overwritten, it cannot be changed, you can just read the value whenever it's required. So think like an example where there is a shell script which performs some actions on set of servers, right? So servers IP addresses, let's say for example, they are fixed, or IP can be dynamic, but host names are mostly fixed, right? So host name does not really change every time. So in that case, you can set up the host name variables as the read only variables, and whenever you want to read those variables, you can just print it or do echo or whatever, right? So you can use dollar in order to get the value of those read only variables, but there is no requirement to edit those variables. So that is why you create a read only variable. So that's a use case of read only. For example, if I modify this here, once the value is printed, and if I say where equals to test, okay, So it's printing me. After that, it says it's a read-only variable. So line number 7, when it tries to manipulate the variable, it tries to add some values or change the value instead of that variable value. Read-only variable does not support that. So you have to go to a different shell and then change the value. So what I'm trying to say is, as we saw that it's not letting me assign the value, but what I will do, I'll go to a different shell by pressing command bash. I am onto the different session, and then I can change the value, because that variable is no longer a read-only variable, because this var1 is different than this var1, because this var1 was created in the previous session of our shell, but this var1 is the new session of our shell. So that's why they are different. Okay, they are local actually. So they are currently, if I try the same way, it will not work, because currently on my local shell session, this variable 1 is a read-only variable. So that's why you cannot make any modifications to it. And if you want to unset the variable, you can use unset command, and then or you can not unset also. Read-only variables cannot be unset. Only the normal variables. Let's say if I create var1 jj, and if I print var2, okay, it will print it. You can use command unset. Okay, this will unset the value. So that's how you can unset the value. But read-only variable, you cannot do anything actually. You cannot unset also, you cannot add values also, you cannot do any operation. So the only solution, possible solution would be either you have to go to a different session or relog into the shell and then do start from the scratch. Basically, it can just be read once or read multiple times, but it cannot be overwritten, it cannot be changed. That's why the name itself is read-only for those variables. Right. So we will see the differences between the various variable types. So first examples what we have seen so far are the local variables, which means the variables which are locally available for the current session of the shell. Okay. Now let's talk about environmental variables. So if you want to create a variable which is environmentally supported, those variables you can export and then use it to a different shell session also. For example, for that you have to use command export. So I am using variable h1 with trainer, let's say Himanshu, and okay, this is a read only. I will make var2. Okay, export var3 StarAgile. Okay, now these are the variables that I have exported. So if I want to see the value of these two, Himanshu, and var3 is it's StarAgile. What if I go to a different shell? Okay, then if I try to print the value, it will print the value for me, because this time I have not created the local variables. This time I created the variables which can be exported to a different shell also. So these are the environmental variables. So that is the difference between local variables or environmental variables. So you can export the variable once and then n number of times. So if I change the shell also here, and let's say it prints, okay, it does not print here. These are not shell based in the same session, but in the same environment it can be usable. But the global variable that we are going to come up next, right? So the global variable can be used from anywhere. Basically, you execute from this shell or whatever, you will be able to execute it. So these are all global variables. var3 is not printing up here. What if I create one more session? Echo $var3. Okay, this is not being environmental variables. You cannot use like this also. Close terminal. All right. Okay, so now let's talk about shell variables. or the variables which are basically being used in any shell that you are using. So these are the shell variables, or global variables. You can think like, it can be used from any shell sessions, or it can be used from any other users also can use it. Anybody in this system tries to find the value of dollar shell, they will get the shell value, whatever the shell is assigned to them. If they are user, then depending on which cell that you have created from etc scale, or something settings that you have changed, but this will print the values of what it should supposed to be of shell. Then for example, like ps, that we have seen in our previous chapters, to print the value of ps1, ps2. So these are also shell variables. It's available on the shell. From any shell you want to print the value, it will go for it, and then you'll be able to print the value for you. So that's how the differentiation we see between local variable, then environmental variable, and the the shell variables or the global variables. So, and then there are some spatial variables which contain some spatial meaning when we talk about Linux systems. So for example, like there is a variable called $0. So this variable is being used to identify the shell script name, whatever the script that you are executing. So this is a spatial variable. So let's see, spatial variable. Okay, so this is a script. If you look at here, we are printing 3 lines. One line is we are printing script name, and then this variable is a spatial variable which basically prints the output of your script. Okay, whatever the script that you are currently running. So it will print the output for you. Similarly, $1 will print the first argument. Okay, and $hash will print the total number of arguments that you are passing to a script. So let's say if I execute my script, spatial variable, and I pass argument 1, argument 2, argument 3. Okay, let's say for example I'm passing 3 arguments to my script. So it will say the script name. What is the script name? This is the script name, spatial variable.sh. Okay, so this is script name will be printed as a script name. So this value, how did it come? It came by this dollar and then 0. So this basically nothing but prints the script name of which you are trying to execute. So this is a spatial variable, you can make a note of it. Second one we use to get the first argument of our script, which is $1. Okay, so you see the first argument of our script was argument 1. So this is how you're getting. Third one, the last one we used $hash, which means total number of arguments that you are passing in your scripts. It will print that value for you. So here in spatial variable.sh, it is passing 3 arguments for you. So argument 1, argument 2, and argument 3. That's why you are getting number of total argument is 3. Let's make some changes, and anything you just pass on, let's say 7, 8, some values I'm providing. So it is saying that first argument is 7, because it always prints the first argument for you. Which value? $1. So this always prints the first argument. Okay, then total number of argument are 8. If you count these values, 1, 2, 3, 4, these are 8 values. What if you want to print the second argument? So for that you can just say second argument and $2. So this will print the second argument. So second argument is number 8. Okay, so that's how you can use these spatial variables basically. Now let's see some other use cases of spatial variables. For example, we'll open it up. So for example, we see something like this. Basically it's using the spatial variables, and then it's printing it out. So the variable what you are seeing here, so this is the variable for, it defines the individual string. So if you are using this variable, So it takes the individual string and then it does for loop, and then takes the argument for individual string that you would want to put it, and then it prints the value whatever you would want argument to be passed on from that loop. And this special variable is basically being used to as a single string. So argument as a single string it takes, and then it prints the value from it. So I'll just show this use case so that you get the more clarity. So let's say if I pass 1, 2 and 3. So one special variable can provide the value like 1 and then 2 and then 3, and another one which takes in the single string will print the value 1, 2, 3 together. So see the difference here. If you use this, it will print value one by one. So whatever the argument that you are providing, it will take first value and then it will take a new line character and then print the another value and last one. But using $*, it will take all the argument value in one liner. So that is a difference between using these special variables. Now let's review some other special variables. So this basically prints the exit status code. So let's say, for example, you executed a command, okay, and you need the output if the command was perfectly fine executed or not. So if the command was failed, then you have to make some additional conditions where you have to make any changes in your code and do stuff. So how do you capture the exit status code of any command? So if it is executed successfully, the status code, let's say you want 0, or if it is not successfully executed, then you want status code as a 1. So this variable $? Will basically print the value of last command that has been executed. If it is successful, then it's 0, otherwise it's 1. So what is this doing? It is basically trying to do ls on slash. Let's see if it is able to do ls slash. So currently I'm with StarAgile. Let me execute this. I am able to do ls slash. So if I execute my script variable 3, it will work because it will first print the value of ls and then it will say exit status code is 0, which means the last command that you have executed is successfully able to execute the on the Linux machine. Let's make some changes now, or instead of this, I want to read the home directory of parallel user, which StarAgile does not have access to. This is user StarAgile does not have access to the parallels users home directory. So now let's try to execute this. It says ls, when you execute ls, it says cannot execute open directories and publisher, right? And you're getting status code which is not 0. So sometimes that's a issue, right? To identify any exit status code which is not 0, that means the command was not successfully executed. So that's the advantage of being capturing the status codes, and later then you can use, okay, stop my script as soon as the value of exit status is not 0. So in that case, it will be helpful for any use case. You can just break the loop, or you can skip that parsing and then do further. So these are the advantages of using special special variables in your Linux shell scripting. So let's say like you can have like multiple changes, and then you can have like you are just capturing that value, and then once the value is like, if let's say if I say if $1 is not equals to or equals to 0, then print successful execution, something like that. You can have any sort of changes here. So let's say else execution failed. Okay, so it's not able to. Okay, there is syntax error. Something is wrong here. It's not taking that value. There might be some syntax problem here, but the concept, what I'm trying to understand is that you can capture those access status code, and then let's say if you can do like this. Let me just try, let's say variable or exit code dollar question mark. Okay, but this will be echo code. This will just print the value of, this will not say 0, or let's say ls, then okay, so ls/home parallels. Okay, this still printing 0 for you. It's not taking the real-time value. It's not updating because it's a scalar variable here. But yeah, I mean, what I'm trying to say is that you can based on your use cases, you can make a change saying that okay, if this value is not 0, there might be some syntax problem, but yeah, once we have that corrected, so it can take that execution and prints the value. Okay, it's a successful execution, otherwise it will be a failed execution. So we can make changes like that. So it's always good to capture the output like this, and then on top of it you can make any sort of executions after that. So that is what about the special variables that we have seen so far, where it can, some variables can capture, let's say $1 can capture the first argument, similar to $n can capture the last argument and stuff. Total number of arguments $hash it can provide you, or then we saw $0 and stuff, so to capture this script name itself. So there are variables like this logic, the local variables, scalar variables, then read-only variables which cannot be unset, also which cannot be having overwritten values if we try to provide some other values to it. Also there are some environmental variables you can provide in the environment using export commands, and then those variables can help you to use it environmentally. Then there are some shell variables or the global variables, for example pwd, echo $path. So these are the variables which you can basically try to use it in your Linux things. Also, let me try to show you how do you create your own command. For example, like this is kind of interesting. People might have questions about, I want to create my own command which does the processing, whatever. Let's say I want to create my own command ls, but I don't want to name it like ls, or let's say ls-al. So instead of that, I want to create my own command called Himanshu, and then if I say, what it does is it just do ls-al. Okay, I just save it. Let me set the permission, because every executable should have executable permission. Then you can just shift or you move this to any sort of shell variables in the, let's say, path, right? So you can just move or copy to, let's say you can copy to user sbin or user bin folder. Once you do that via sudo privileges, you can execute command Himanshu. So the Himanshu command will be created. So something like that, you can create your own command. It will be nothing but equivalent to what ls-al is doing. So this is how you can communicate to Linux machine, saying that the customization I want as per my own needs, so I can change the settings whatever I would want to change. So that's what the capability of Linux it provides in terms of using the shell scriptings and commands that you can manipulate in the paths. So yeah, that's about the variables and arguments that we have been seeing so far in the shell scriptings in Linux. All right, so let's talk about the functions in shell scripting. So far we have been discussing about various loops available in the shell scripting. How do you write the shell scripting? What are the commands? It's basically nothing but a sequences of command that you execute as a file, executable file. Then we also saw how do you make your own command. Basically, it's nothing but a scripting written sequential of commands, and then you can just give the executable privileges. Once you assign that, you can after that rename the file with your own name or whatever the name you want to choose, and then you can execute as your own command. That's what the Linux give you functionality to customize the commands according to your ease. So today we'll be discussing about functions available in shell scripting. So when I say functions, what does it mean is function basically give you a variety of modular code that you can build up and use. So basically, for example, think like there is a set of code line which is written. With the help of function, you don't have to write the similar code again and again. Rather, you can just have a block of function, and after that you can just recall the function whenever it's required. So that's what the ease of a function. You don't have to repetitively call the or write the same code, but using functions you can just directly call and get the output of whatever the code was written in. After that, we will see the real practical examples of shell scripting available these days. So like for example, like how do you archive or compress the file automatically whenever it turns to, let's say, 10 days old or month old or whatnot, right? Then we will also see how do you automatically clean up the temporary files. So there's a shell scripting you can use. So as you remember that we have been discussing about the use cases, the real-time use cases. So we will be talking and seeing the hands-on for those use cases in today's chapter. Then we will be seeing how do you monitor and reporting about the disk space issues, so that admin can take actions further whenever it's required. So you don't want things to be all the time manual. So shell scripts provides you automation to do that. So why not to use that automation now? So and then it will be talking about automating servers with various tasks, whatever you can set up the task, and you can perform. Then user management and securities, we will be seeing that as well. And then automating backups also we will be seeing via this. So let's start doing the hands-on. You can see my screen. Currently I'm on Ubuntu machine. So let's start with the function definition. So if we say basic function, how does a basic function look like? So this is the shebang header that we have spoken about. It tells that we are currently writing our code in the bin bash shell. So the function name is greet. So this is how you define a function in shell scripting. There's a function called greet. Now this greet, what it does is it just prints the hello, and then whatever the argument you are passing while executing this script. So this is $1 is the first argument. You remember in the last chapter we spoke about $1, $2, $hash, question marks, and so spatial spatial words in the shell scripting. How do you use those? Then we talked about operators and so stuff. Then after that we are just calling this function. So how do you call it? You can just type the name of the function, and then you can just provide the argument. So whatever the argument you're passing, this argument will be the first argument that you're passing to the function, and then it will print this. So let's execute this, and then we will see it has printed as hello world, because hello was already there, and world is the string that we are passing here in the greet function calling. If you change this, let's change it out and say Himanshu, and then execute it. So it will say hello Himanshu, because this Himanshu string is a first argument, and after that it has just appended that argument. So basically this is how you can define a function. Very small way, I'm just trying to explain this, but yeah, you understood the part is that we'll be seeing further more complex operations using functions later, but in a simplest way to explain is this, that a function is a set of code, but here this set of code is just of one liner, which is just printing the string, and then it is taking the arguments. It's very simple, in that terms. So That is a basic function example. Now we will be seeing function with the return value. So when we say return value, what does it mean? That it meant it returns something, so return in the sense it is providing you some output. It's, you can use that return value and then do whatever the operation you would want to do, or you can just print that return value as well, depending on the use cases. So we have a requirement. Let's say we want to add numbers, okay, mathematical operations we are doing. So we have created a function called add underscore number. After that, in that function, we are writing this 2-line set of code. It says that result is the variable, so it is storing the value of your first argument and the second argument, okay. Then it is returning that argument as in this variable called result. If we don't do return, then you have to print it or use this value of this variable value result within the definition of function, but usually that is not how the function are being written. So it also, like, it depends, like, whenever you want to fetch some values and then use that value somewhere else in some other functions, so you always prefer to create a function which returns something to you, so that you can use that value later in your code. So here example you see, so this is basically returning you the value of result variable. After that, we are calling this function add numbers, and we are providing 2 arguments, one is 5, one is 3, okay. Now you see this echo, this command we are executing outside the function definition. So function definition starts from this curly braces and ending with this curly braces. So outside this function scope, we are saying echo the sum is whatever the sum. So this basically is a spatial variable. We spoke yesterday that it prints the it basically returns the last command that you executed, the output of that. So last command output would be this. So when you are executing this command, so this is nothing but a function calling function. Which function? Add underscore numbers with these 2 arguments. So this will take as per the definition of this function, and it will add 5 plus 3, which is 8, okay, and that 8 value will be stored in the variable result, and after that you are returning that value of result, which is 8. So you have returned it, so that will return, and then you can use that value, whatever the last command that you are executing, return value of that command will be dollar question mark. So if you execute this function with the return value, it will print you the sum is 8, okay. Let's say, for example, you want to sum 500 or 200, then you can just tweak these values, okay, and then it will print you the value of that. Wait, something is wrong here. It's not 7, it should be 700. Wait, 500, 200. Cool. As such, okay. What if, let's say 10, 20, 30. So let's say 10, 200, 210, that is fine. So basically it should supposed to print the value. Something is happening beyond 500 if you are going, need to check further, but you got the idea that once you once you basically provide the out, so this basically prints the whatever the output you are getting it. So let's do this instead of it. Let's say if we make a change, if we use the last value as in dollar result, okay. Yeah, that is one way to do this. 260, yeah, this is perfect. What if I say let's say 500? Yeah, now this is perfect. So you can use like this, you have utilized the variable value return. Also there is one more way, I guess, you can use it. Like for example, you are using echo command, and then this echo you are directly using numbers, and let's say 10. I'm just messing up here just to see if this works or not. It's just a trick. So according to the ease, like you can just use it and play around with it and see if it works. Yeah, so it's not taking that thing. But in Python, like similar thing, you can print it, the values you can just execute. So yeah, anyway, so basically you understand the functionality of a function, which means a set of code which is can be used n number of times. For example, like what I was saying here, let's delete this. Okay, for example, like you can copy paste this line and then multiple times, so which says that you can just multiple times you can use the same, or you can call this function. So this is like a very small set of code, but what if there are multiple functions there, and then you can use this add underscore numbers, take the value of it, and then put that value in some other set of code in the another function. So something like that also you can create, and then this will basically work for you. Oh, we did not save it actually. Yeah. So that is a usage of using return values, where you can get the value from that variable once you call that function, and after that you can utilize that value anywhere else in your script or the code. Okay. Now let's see function. How do you use the echo that we are using so far? But with echo function, using echo for output. So this is the function where add function, what it is doing is it is doing a sum of first argument and second argument. After that, it's storing the value of this sum into the variable called sum, and then it is printing the value for you. And then later you are just setting up a variable which basically does call this function with the argument which is 10 and 20, and it stores the value into result. Then later you can just echo the value of result. So it is doing the same way. You could have removed this here and then return the sum value, and then you can use sum instead of result, as we saw in the previous example. But like this also you can use, so it's like a functionality. You can tweak, change whatever you would want to. Based on that you can do this. Let's change the values and see. Yeah, so that is how you can use echo command with the functions. Okay, let's see functions with the multiple commands. So here you see there is a function called system info. This function is basically executing these three different commands: hostname to print the hostname, uptime, like since when this machine is running, and then amount of memory available used on our machine. So this will print all these three values, and then later we are just calling this function. So once we call this function, whatever the set of code is written inside this function, it will basically execute, and then it will do whatever you are asking it to do. So let's just try to call this way, function with multiple commands. So this has executed three commands. One is hostname, which is this, and then uptime, and then free memory, which is free -h. So if you execute three commands, it's like a time consumption, right? So three commands manually somebody is executing, but there is a script. That script also you can use in cron jobs. If you remember, we talked about schedulings, where we want every 2 a.m. There is a script which should automatically execute, which performs these three commands and then prints the output on the screen. So that admin just monitor the screen, saying that okay, what is the current size, stage of the memory? What is the host name not changed? Like something can happen, right? So you can set up use scripts and use cron jobs in order to make sure it can become a scheduler task for the user, and it's kind of easy for user to see the things. So that's how you can use scripts in terms of various use cases, whatever come across. Then we will see using local variables. Function with local variable. local variables. Okay, so so here is a keyword called local. We are saying it local because explicitly we are defining this is a local variable which is locally available on this shell session. Okay, the variable name is product. It is basically multiplying two arguments, argument 1 and 2. So when you call this function multiply, given with the argument value 5 and 6, then it will basically take these values and then creates a local variable product, and then you are just printing that variable, and it's local, which means it can change. So here in this term it will not be like you know, it just trying to make it understand how do you define the local variables inside a script, or more of like in the functions, you know. So you can just get the value multiplication. If you want to change it, you can change it as well. Let's say it will print the multiplication value. So this is the function using local variables. Then we will see recursive function. So this is the recursive function. Basically we are calculating the factorial, and after that we are just printing with the you know, whatever the argument that you are providing, and then it calculates the factorial for you. So this is the you know, code for the factorial recursive function. So let's try to execute this. So it will print the value. If you want to change it, so you can, let's say I want to calculate factorial for 5. 5, okay. So then it takes the value 5. It says is what is the value 5 less than 1? Definitely it's not less than equals to 1, right? So nothing will print, like it will skip this part. After that else in, so this code will be ignored because the value 5 is anyways greater than 1. So it will just take that code. Whatever is written, it is basically you know, the previous value we are calculating, which means the 5 minus 1, which is 4. So we are calculating factorial 4 and then multiplying it with the value, you know. So that's how we are calculating. Wait, I think we did not save it. So 5 into factorial 4 we will be calculating, which is nothing but 120. So that's how you can use. Okay, there is one more thing I was just trying to show it up here. So there is a command I created, factorial. So this is a script to calculate the factorial you know, for any number. So this script has a logic where it is using for loop, and whatever the number that you are passing, which is argument, let's say you pass 6, so it will take this. So until, so loop will be driven until the value of I, which is 1, till reaches 6, which means 1 2 3 4 5 6, and then it will calculate the factorial. Okay, so it will just take this value fact is 1 into I, which is 1. Okay, it will store the value here, and then it will print whatever the number that you provide. So this will basically keep on updating. So let's say you know, value 1, first value is 1, so it takes 1 into 1, which is 1. Okay, after that the fact value is 1, then value of n changes, which is 2. So it says okay, I1 is still less than 1, so then again you know, calculate the factorial fact value 1, whatever it's store, and then multiply with I, and then you increase the I. So I from 1 to 2, so this value fact will become from 1 to 2, 2 into 1, then 3 into 2 into 1, then 4 into 2 into 1, something like that. It will calculate, and then it stores the factorial value into fact. Later in out of this function code, we are basically on the shell using read function to read the input whatever you would want to provide. So this basically reads like in the same line, you don't have to go to another line. So usually if you notice earlier so far, we have been using echo command, enter the number. After that, in the next command, read and then you know, number, whatever. But if you want it to be in the same line, so you can use -p. Okay, enter the number, whatever the number you provide, and if the number is less than 0, definitely factorial is not defined for negative numbers, you will get that. If it is not 0, then it will just call this function and calculate whatever the number you are providing. Okay, so let's just execute this command. Let's say 10. Okay, Okay, so basically this script itself is asking the numbers so that you don't have to explicitly provide as an argument. So they say what is the number you want to calculate the factorial for, say 10. Okay, so it has calculated factorial 10 would be this much. Okay, now what I want is, see, there is no direct command in Linux available, okay, factorial or something. And there is no such package also, I believe, which can just calculate the package for you, or like a factorial for you. You may have to use BC command just to calculate as a calculator. Let's say BC also is a good command to calculate whatever you want to calculate. Let's say 5 in 5 percentile 4, so it will calculate that for you, reminders and all. But using BC, you can have multiple pipe and some sort of a code that is required in order to calculate the factorial, but there is no such explicit command for factorial. Okay, but now since we have this script which perfectly calculates the factorial, let's make this script as a command. Why not? That's what the Linux give you capability, right? So what I'm going to do is, if you remember in the last session we talked about paths. These are the paths for the shell variables, the global variables. So I will just move or copy this script, let's just simple copy in one of these locations. So I'll just copy it under /usr bin. That's it. Okay, using sudo because these are always be accessed by the root user. All right, now if you execute, and then you have to change the script name also, because now the command is ready. Okay, but it's the naming convention is factorial.sh, but I don't want this to .sh also, right? Let's just rename it, say usr bin factorial, change it to usr bin. We are using move command to rename the script. Okay, all right, we have to use sudo. All right, so now if you see, factorial command is present in our system, and it will calculate the factorial for you. So whatever the number, let's say 4, it calculates the factorial for you. So that's how easy you can make a script, whatever the logic that you have, and you can make a command, your own command. So see, the advantage of using such facility is, you can create your own setup where you don't have to manually execute a big long command all the time. It's not something, when Linux has this capability, why not to use it? So you can make your own short command. So this is still like a big command. Some people may not like, oh, why do I have to still type factorial? Why not just say FAC? That also should calculate me factorial. So you can just rename it to FAC and then it will calculate the same way. So that is advantage of using Linux and shell scriptings, the way it modifies and then you can use it up. All right. So now let's go ahead and then we will see how does a function work with the error handling part. So let's see function with error handling. Okay. So there is a function. This function is just checking the value of first argument, basically the file. If it is checking a file for you, so if there is a file, then the file exists. If this is not null, that means the file does not exist. Okay, it will just directly print it for you. Now what all files you want to check? So I am calling this function called check file and then passing the file name in as an argument. So since these files, if you remember, we spoke in the permission, these files are present in our systems. So since it does, then definitely it says file this etc passability exist. So this is how good this utility, you can just make a command and say, when you execute this command, any file that you want to see, you just pass that value of that file, and then you can just, instead of providing the argument here, you can read the argument on the shell itself, that also, by using read-p. So this file is present, we all know that it will say this thing, but this file is not present. I have not created this non-existing file. Okay, let's see what it basically prints it for us with error handling. So this is file, this is exist, and this file does not exist. So this, see how easy is just to you can concept. So earlier what is the alternate, what you used to do? We used to do ls. If we get the output of this file, which means okay, ls, which means the file exists. But why not? Why to use ls? Let's say there are thousands of files that you want to check. You can create a script and then you can manually remove all the usage of the commands, right? So that is how you can use functions with error handling and file checks. Okay. Now let's check function with multiple commands. So this we have seen a function which has multiple commands can execute and then provides the output of the command. Now let's look at some hands-on practical use cases which are majorly being used in the industry. People who are working as a DevOps, SRE or system admins, they have this day-to-day tasks where they have to calculate backup, make sure the size of the disk is fine and stuff. So that's where the use cases comes, right? So let's talk about first use cases, archiving and deleting our old file. So there is a script. Okay, see, it's very single liner. So if it's just using find command that we have already seen in our command chapters that when we were talking about command. So it's basically reviewing the logs, syslogs. You all remember /var/logs. Only the type f, which is a file type. The name should have an extension called .log. M type means 30 days. If it is more than 30 days, then what do you want to execute? You want to create a backup and using tar command. Tar we have already seen previous chapters. Tar cvz, it will create a zipped, forcefully for this backup. So it will create a backup inside varlog archive folder. Okay, and then whatever the base name of the file would be, with the extension tar.gzip. That's how the tar basically creates it. So that is what it is doing. So it's like very small script. So if you execute this script, it will try to store the backup and then backup and then put it into the archive folder. I'm getting permission and error because I'm executing with StarAgile user. If I would have executed with root, then it would have done its own job. So it will basically some files which are not present or already archived. So some errors I'm getting, but still it should create that archive folder for you, and then make it a tar file for it. So it's basically trying to check that, and you can break that script actually to see, okay, these are the log files which are currently present. First find those log files and then tweak the tar command to calculate it. So that's how you can utilize. Now this script looks like very it's something which is doing its job, let's say, but it is just a single liner, right? It is not describing the use case of it. By the name we understand, but what if you want to a proper coder always provides the description of what command it is doing. So for example, like you can just tag it, say, okay, this is basically finding .log files present under whatever, right? So you can just describe the usage of your commands. You can break it down and then you can use a script. So that's like a proper way, real way to use it, so that later if somebody refers to your script, should be able to have this understanding, okay, oh, this is how you break down the script what you are writing, and then the command it basically tries to checks it up. So that is how you can use archive using tar command for the, and then you can delete it also, older files. All right, now let's let's clean the temporary files. So for that as well, so we can use this command. It basically anything try to find in /temp folders, type file which is older than 7 days, and then you just remove that. Okay, so first let's say if you execute just this much command on your shell, okay, and then see the output. So these are permission denied, but let's execute like this. Okay, so currently okay, sorry, sudo find /temp. So there is no such file in temp folder. So is it okay? But yeah, plus one, which means like 1 day older files are present but not 7 days. Okay, so once it gets this file, I don't want to delete it, but because maybe some other issues, if they are being used or swap or something, right? So I don't want to do that. But after that you can just execute this exec rm. So this will basically remove it, but it will ask you basically for approval, or it will not delete the recursive as well, because you're not adding option R here. But if you don't want to ask anybody, and then says recursively delete whatever the folder and files which are older than 7 days, only the files here. But yeah, in case you don't want to do file based filtering, you can remove this and then say anything which is present under this and then older than 7 days, you can just delete it. So you just think like the easiness of the shell scripts, you know about operators, you know about logics of reading variables and then putting the values inside it. But after all, what is shell scripting? It is basically nothing but commands, set of commands that you are executing on your shell. Whatever you have been doing manually, you are just automating it by writing in a file and then make the file to executable and then execute it. So that is how, easiness of shell scripting is. Then let's talk about disk usage, disk space monitoring, what we are doing here. This is kind of calculating the usage. So using df command, if you remember, we used to monitor the file system space in slash, and then it is printing the fifth value, the used value, and then you are doing further replacing this using sed command. Then it is basically printing the current usage of the terminal. Once you get that, and then you can just add a logic here, just to first it will print the alert message to the terminal saying the disk space is above this blah blah threshold. So currently threshold is marked for 10. If in case threshold goes above 10, so 10 is not a justifiable number here, to be very honest. Usually you can calculate for 90%, so you can just make change instead of 10 to 90. Currently my system is not 90% use. That's why I just wanted to highlight that how does this work. So currently it's used 20%. That's why I say disk space is about 10%. Current usage is 20%. Okay. So you can just see like this, df slash. So it basically calculates that for you. So in case this is beyond 90%, you can change the threshold, and then it will basically send an email. This condition requires you should have a postfix SMTP server configured. If you do, then it will just send an email to you, to the user. All right. So that is about calculating the disk space, and then you can just send emails, you can alert systems, and you can add a number of tools, monitoring tools, on top of it, like just send me email or just notify me so that admin can reduce the size or can do some action on top of it, some positive actions, right? So now let's see uptime, if we can calculate. Okay, I got some email. Uptime down. Okay, so this basically saying that current downtime. So what if the downtime is in 30 minutes? Let's say if your system is down for 5 minutes or 10 minutes or 30 minutes or whatnot, right? So you can calculate that downtime for you, and then the current system up, like let's say the system was up and running for last 30 minutes or more than 30 minutes or 1 hour. So you can change these settings. So this will convert the uptime to minutes. Okay, that is fine. And then it checks if the uptime is less than the downtime, which means there are chances, let's say for example, there is a server which automatically switches off, for some reason, some configuration problems or some other conflicts. So because of that, whenever admin restart the server, it automatically goes to downstate. Then again, you have to restart and then goes to downstate. So this will calculate, okay, downtime threshold was 30 minutes, but your system was up for 15 minutes. That means some problem, right? So downtime should be very less. 30 minutes is still too much. Real time environment is like the downtime can be, let's say 5 minutes or within seconds also if it is down. But in case of cluster nodes, 5 minutes is also fine, because in that case your health checks will kick in, and then traffic will be redirected to some other cluster. But if it is let's say 2 minutes or 1 minute, it replace that node or do something like that. So you can tweak the changes that way. So this is calculating, okay, server has been down, and immediately send email to whatever your system, server admin email address or anything like that. Or if it is uptime is above threshold, then print this message saying that This is so currently it has sent because maybe it was calculating the downtime and stuff. All right. Now let's check how do you create multiple users. So for admin, let's say there is any in the organization, there are use cases comes, right, where there are 5 users join the company. So admin does not just create one by one all 5 user accounts. No, there is a script which kicks in and it creates the 5 user in one go. Similarly, we also have create user script, so which basically reads the usernames from this file, and then if this file is not present, it will print the error saying that the file is not there. Once if it reads the file line by line and then tries to create the user by using user add command, and once it do that, and then after that it reset the password as well for the user. So you can just use this. So I'm just trying to show up here cat users.txt. So these are the 3 users I'm just trying to create. For your checking, I'm just trying to say that this user does not currently exist on my machine, but I'm just trying to create these 3 users. So you can use create user script, since user creation is always be created by suit privileges. Okay, so these user names are created. Perfect, awesome. Now you can at least see if the users are created or not. Last 3 lines, so you can see last 3 lines has the entry for users automatically being created. Later you can change passwords and log into the user, or give user credentials first time whenever you log in, then you have to immediately change your password, something like that. But see how easy it has become by using shell scripting, that you can just create users for admins, like multiple users you can create it, and then it just kicks the job. So see, that's easy. Now you can similarly use this delete as well, like to delete the users also, something like that. Let me just see if I have anything. Delete also. Okay. Users underscore delete. All right. So this will basically use user delete and their home directory also, and then whatever the user you have provided in the file users to delete.txt. So if you read users to delete, what was it? Wait. So users to delete. So this has 3 username that we have created. We want to delete those users. So user delete.sh. So it has completed already deletion process, but we will execute this. Okay, now the user names are deleted successfully, because earlier we were not using it with the root privileges. If you try to grab it now, okay, let's say username 1, okay, okay, pass wd tail-3. So you see these 3 users that we have created has automatically deleted after executing this script. So this is how it makes easy for people to use this shell scripting. There is one more use case we will see about automating backup. Let's just try to see. So you can grab like this. Okay, there is no such file directory. Backup or something. Backup script. Okay. So this basically log the backup start time. First, it defines a source directory where of what directory you want to take a backup, and where you want to store the backup, destination directory, and define the log files to store the backup. Okay, that is there. So once you define all these 3 things, retention period is 30 days, which means if it goes to that date, it will start automatically takes the backup. Okay, and then it will rename the file with this format. So this format, basically I'll just show it up in the local shell. For example, if I create a directory called ji and then use this, okay, I'm just trying to create a text file, but you see, you know, okay, directory ji.txt does not taken this. Wait a minute. Okay, it has taken, but it is like creating different. There might be some issue here. Something it's not doing. Exist. Okay, it's not taking that way. Yeah, but with this, basically it will just take the date and then start printing with the same name. And then it will store the backup with a naming convention where it says the timestamp of the day when the backup was created, so that it's easy for admin to identify, oh, this backup file is for that time period, this backup file for that time period. So it's easy to find out those. And then once the backup is successful, after that you can just remove the older files older than retention days, which is 30 here. So you can change it, you can tweak it, and then you can just execute. So see, without doing shell scripting, you can also execute these manual commands. These are the variables, you can define local variables and then you can perform it. But with the help of shell scripting, it can be a n number of lines, so it does not. And one more thing, you always remember that there are multiple ways to write the scripts. Some people write it in a good way where they can use shortest logics in order to make it more enhanced, plus also add the descriptions defining that what this basically line doing. So these are all behavior and good tactics way, and always recommendable to create your scripts like this. So that is how you can create a backup and then delete the older files. So this is about the shell scripting. Later you can just send emails on the files. If some issue comes up, just send an email to me, or some other issue comes up, notify the admin and reduce the file size or disk space usage and whatnot. So there are n number of use cases, and you can just start with the basic shell scripting, and then slowly you can add on the new logics, whatever you would want to, and make it more easy for you. So it's fine just to start where you just don't understand, okay, this could also be a logic, but with the time you will get this understanding once you start using that. So I just tried to explain in the simplest form of how does the shell scripting you can use, and then make sure you leverages the real-time situations and you can tweak the scripts according to your use cases. So yeah, that's about the real-time and practical examples and demos for the shell scriptings. All right, so we have come to last stages of our Linux learning series. Here we'll be talking about some advanced topics. So far we have seen about Linux, about kernels. So this advanced topic also has something about kernel. So as we all know so far, saying that kernel is nothing but an engine of the OS. For example, without engine, a car cannot be driven. Similarly, without kernel, a OS cannot be worked on. So if you need more functionality, if you need more compatibility, so your engine also has to be refined. Your engine also has to be updated all the time. So when I say this updated and refined, what does I mean? I mean that kernels has modules. So for example, if you think like this, you have a mobile phone, and every time you see there is a new updates keep on coming, and if you update your systems, if you update your mobile phones, it will load some new modules which will have some other functionality or compatibility in order to support various tasks. For example, like over 20 years, 30 years since the first kernel was launched of Linux, since then there have been a lot of changes happened in the operating system. For example, if you think like this, you have a mobile phone, and every time you see there is a new updates keep on coming, and if you change, if you update your systems, if you update your mobile phones, it will load some new modules which will have some other functionality or compatibility in order to support various tasks. For example, like over 20 years, 30 years since the first kernel was launched of Linux, IT industries, where things changed from the normal computers to the cloud computing. So there were a lot of file systems things, drivers things, supportabilities. So these are the new things which came up over the period of time. And for that also, kernel's responsibility to support that, because Linux cannot say, oh, okay, I was written in that at the time frame, and then now I don't support it with the current functionality of what cloud computing is offering. So that is not how it works. So it's always keeps it updated, and provide more and more support and compatibilities. So for that, kernel requires basically just to keep them up to date with the modules. So the responsibilities, we all know that kernel can manage the security part of our Linux systems. It manages the conversations between hardware and the user, and then it can handle the file systems and networking. So it can handle the processes and the memories, whatever the actions person is doing, or admin is doing, or any other user is doing on the Linux machine. You're watching a movie, you're doing something, some actions are being happening. So that actions are being tracked down with the kernel, are being led down with the kernel. So it's being worked with the help of kernel. So without kernel, nothing can be done. So here we will see what are the modules, how do you see the kernel version, what are the modules that are loaded, what are the modules you want to set a blacklist and stuff like that. So those are the things that we'll be checking up. Then we will be seeing the configuration files for the kernels, which are very important. Without that, kernel also would not work. Similar to the services that we have been talking so far. So kernel also has configuration files. So let's review some commands, and then we will see our kernel, how does it work. So in order to see the kernel version, there is a command called uname. So you can use uname -r. So that will say, okay, currently the version of kernel is 6.8.0. It's a generic kernel. Now I think 6.13 has been launched. I was just checking news someday. So which is also is a more advanced version of kernel, where it might be having some other capabilities and some other compatibilities with the systems and drivers and stuff. So that is how you can check the kernel version. Now there are, if we talk about the kernel modules, so kernel modules basically contains for device drivers. For example, if you remember, we formatted our devices, the file systems, with ext3, ext4, xfs, ntfs, or some other file system. Any file system, anything, it requires a driver to support that. Okay, so there was a file system related drivers that kernel is up to date in order to make it work. Then device drivers, for example, like various devices, you access hard disk, you access graphics card, network interface card, or any external devices that we will be using in the Linux machine. We will be seeing, so those required specific kernel modules, or I would say specific kernel drivers in order to support that. Because see, if those drivers will not be there, then that means kernel will not be able to support the latest graphics card. Then what is the point of using the kernel which does not support a latest graphics card, where you cannot play games supporting those graphics card, right? So it also has to be updated with the drivers which supports the latest any external devices or anything, processors, graphics card, and an IC card and whatnot, right? So anything you have it, so kernel should also be up to date after that. And then networking protocols also, over the period of time, we have seen from UDP, TCP/IP, then HTTP 101, 102. So there are changes has been happening in the networking world as well, where from SSL 1.1, 1.2 to SSL 1.3. So there is like lot of changes has been happened in order to secure the world, in order to secure the internet, the data, vulnerabilities and stuff. So kernels should support that networking fundamentals also over the period of time. Whatever the protocol that has been newly implemented or applied on top of the existing ones should also have a capability that kernel should support it and have the compatibility in terms of supporting that kernel, that use cases. And if we talk about the modules, I was just talking that, without modules, kernel is of no use. So, which means that kernel has the capabilities. But if we don't provide that modules, it's like you can think like, a set of a rack where list of modules are there. So if the modules is present, kernel can read that module files and then act accordingly, whatever the module code is being written. So you can just check the list of modes, modules that are there. So there is a command called ls mode. This command shows the list of modules which are currently loaded in your system. And definitely the modules, some modules are of higher size, some are of lower size. And this command can tells us, okay, this module is there and this is used by what, some process might be using it, some task might be using, some internal things might be using this module. So so how many processes or how many commands or how many tasks, you can just think like how many objects basically who are being using these modules. It can get the details over here. So there are, for example, if you see like this NF table, so there are 48 objects in that sense, okay, which are being having correlation in order to use this module. So they are being used by these. So these are all the modules which are there. You will see, hardware modules, like you will see video drivers modules, which has memory ops, VM logs. So these are the things, all various type of modules which are there. So you don't have to worry about, what are the modules, each and every module, what it is doing, because it's not the job for or the use cases for anybody to understand or learn all the modules listed there. Depending on the use case, whenever it comes up, you can read about those modules as well. There is a manual always available, we have seen so far in our series. So you can read through the manual and then you can get more knowledge about, okay, what does this module do, and then you can just go more deeper and deeper into that. But here in this series, we are just touching up the basics of Linux and also understand the concepts and how do we use it, fundamentally. So this chapter can at least tell you the idea about the fundamentally the modules are there. Without that modules, kernel may not work. So there are chances that some application you are trying to use which uses some other external drives, but currently not working. Maybe there is a chance at least you understood, okay, kernel is the one which is responsible to make things work. But what if there is a module which is there and currently not loaded? That's why the application is not working. Similar way, right? So that can be a use cases where you at least have this click in your mind, okay, there might be chances that a module is missing. So you can add the module. Once you add it, maybe the application start working. So that's how you can think in that direction, then try to troubleshoot things. So yeah, I can see here these file system related, then RAID partitions, another category of partitions that we spoke, LVM, and RAID was also one of it, which we did not touch. But yeah, these are the modules which supports the RAID. Then there are some other modules as well which uses by RAID and recoveries. So then algorithms, various algorithms which are being used in order to encrypt the password and whatnot, right? So there are advantages, and there are usage of individual ciphers and modules basically, which are being led by various processes, and kernel has the capability to talk to the process or the task by the help of these modules. So if these modules are not present, then kernel will not be able to talk to or support on that functionality. So that is how you can see the modules. Now let's say if you want to see how do you load a module, or how do you say to the kernel, okay, I want to load this module. So there is a command called mode probe, okay, and then you can just pass on the module name, whatever the module you think it's, just to identify if it is loaded or not, or if it is not loaded, then it will load it. So you can just say, let's say there is a module called AES C cipher. Okay, so this module is loaded. That's why you are just seeing it here like this. If this would not have been loaded, so it will load at the time, but since it is already there, so that's why it is being loaded. Or let's say if I give some other random name, right? So this will say, okay, you are getting a fatal error saying that module this not found in the directory. So this is the directory where the kernel related modules are present. So if you go to this directory and see, so you can see build, then init rd, the kernel process. These are the modules which are built-in modules. Okay, so you if you go open each of them, you will get the list of modules and you will get the understanding of how does the module look like. But this is basically taking the reference when you're trying to add a module. So it is checking inside this directory if the module reference is present or not. So if the module is not present, you can manually import a module if you have it. It's like a set of code, right? C++ was the initial thing which used by Linus Torvalds in order to build that kernel 0.02, right? So similarly, you can also use similar languages where you can build your own module and then you can pass it up here and then you can customize your kernel to behave like this way. So that is the advantage of using open source, where you can just make modifications in the source code and then you can make it as your use case purpose. So now, how do you remove the module? So there is a command called mode probe. In the mode probe only, there is an option called -r, and then you can pass on the module name. So if you pass any module name, it will basically remove it for you. So if you check the manual for ls mode, it will show you what does ls mode do. It says the status if it is loaded or not, and then there are some other utilities you should also see. So it is giving you the reference here. Okay. And it says the copyright. If you look at this manual page, which was written in 2002 by Rusty Russell, IBM Corporation, maintained by John Masters and others. So it has a copyright on this command, basically who provides the information of module. So this is also a binary, you know, like which provides the information. So if you look at like this binary, so this binary is present under this location. If you open this location, you will basically see the binary code. See, so this was written by the team and then they have copyright on top of it. Okay, now let's open that manual, what it was referencing. There is a command called mode probe. So let's open this. Here you can see how do you add and remove modules from the Linux kernel. So mode probe command can help you. Various options, you can read through the description. It says that this is how you can use options. This is how you exactly try to import module or remove the module, to blacklist, you know, to insert all the modules or blacklisted modules and configs. If you want to see the configurations, you can just see it like this. First time if you are doing module updations and stuff, you can. So there are like a lot of options available where you can just check out, read through that, and then it'll give you references of various other commands and stuff. So similarly, mod info is just to provide the information about the Linux module, you know, what does a module do. So let's say if we see, if we get that cipher, see, so the module that we imported, we were trying to import, which was already there. Mod info command help us to identify what does this module do. So this is saying it's a global public license, GPL, which is like globally available. And this module, if you look at here, so kernel version is 8.6.8.0. And if you look at the hardware, so this hardware is ARM64. If you remember in our second chapter when we spoke about installation of Linux, so this Mac machine is basically ARM based machine. It is not Intel based processor, right? So that is not AMD. It's a ARM based. So this kernel also supports that ARM now. That's why we when we downloaded the Ubuntu, we downloaded the ARM version of Ubuntu, and that had the ARM supported kernel as well. And that's how we are able to communicate and perform actions on our Linux machine. So this module is basically being used for some cryptography purpose, you know. The author of this module, who wrote this module. So see, these are the people who are basically who are basically developing it in the community. So the open source community, if you participate that, there's a GitHub, you can just go through that, you can just participate in the community. And if you are eager, or if you seek for some code, you can just write a better code, and you can just write a module. So you can make modifications in the existing modules in order to make it more improvised, or make it more useful in terms of unblocking some other use cases which the current module is not supporting. So you can be part of that, one of the community. And then you can also see, okay, you are able to modify some sort of a code where you are able to make a change in the community where it can help people who are using the Linux. So yeah, you can also be author. It's always open, so you can make a change and then you can make it yourself author of any modules as well. Now it is telling about the signature of it and which signature encryption it is using and how does it basically automate it. So any module that you want to read through the information, you can use mode info command. And if you want to list the modules, you can use ls mod command. You can mod probe command to add or remove the modules here. Now if you want to insert manually to load a specific module, let's say for example you have built a module, okay, and you want to load that module, so you have to use command ins mode, insert mode. So you can insert the modules basically. So sudo ins mode, then you can provide the path of your modules. So let's say any path, I'm just giving a reference of, okay, this is the path of module, and some module, some module you want to insert. If you want to insert it, you can use ins mode command. So there might be some other options as well with the ins mode in order to see what other options are present and what it does. It will give you information like this, like for example dmessages command, where you can just read through the error messages if it comes, in order to import a module or stuff like that, right? Now you can also prevent a particular module to be loaded in your system. The use case may be some conflict of modules can happen depending on the usage of the applications, and you want to restrict one module to not load on my system, so you can mark it as a blacklisted. Once you do that, after that nobody will be able to insert that module until you whitelist it again. So to do that change, there is a file called etc mode probe.d, because all configurations are present in etc directory, then blacklist.conf. So this, if you see here, there are a lot of modules which are already blacklisted, okay. So it says this is a debug tool that should be loaded explicitly, means should not be part of these drivers. These drivers are very simple, and HID drivers are usually preferred. That's why we don't use these drivers, okay. So there are various entries you see for blacklisted, where they are saying these modules are not being used, or there might be some other replacements of these modules. So for example, like this is already replaced by this. So this is nothing but might be a ticket number of Ubuntu community, where they have been discussing about this via any GitHub issues or stuff, and then they decided, okay, let's not use this module, rather we should go for Asus laptop, maybe for Asus laptop only it is being built it or something. So similarly, AMD is blocked here because this is not a AMD based processor, this is a ARM based processor. So it says that EDAC driver for this AMD is clashing with the AGP drivers, preventing the aperture from being initiated. So that's why it was blacklisted. So similarly, you can also add an entry here, blacklist, and whatever the module name that you have it, you can just pass the module name. Once you do that, you can just load the kernel, and that's it. It will just take up the configurations, and then it will not let you load the modules. Let me see if if we can, what if we can just manually try to load it? Insert module. Okay, it says that could not load module because it does not have the reference of the modules. That's why, and because we have backlisted, so might have been removed the reference files which belongs to this module. That's why it does not allow you to import the modules. All right. So then all the modules that are loaded on the startup, those entries are present inside /etc/modules. So you can just say okay, currently it does not have any entry. It says that etc module is obsolete and has been replaced by this. Okay, so the configuration path has changed. Load.t modules.configuration. So currently this is the file where we are documenting about the modules that are there. So this is one of the configuration files. Then there is one more present inside /proc. So if you remember when we spoke about file system hierarchies, and we spoke about each and every files, /proc /bin. So /proc is basically holds the kernel modules, so information, the configurations of the kernel. So you see that and it also holds, I think these are the process IDs. Yeah, I guess so. Let me open the directory, maps, and so it's basically tells for that process what it is happening, C group and stuff. Information, maps, root. Okay. Yeah, so like all the set of configurations which are related to kernel you will find in /proc. So let's see this file. Let's try to open it up. For proc module, so you see all the modules which are being currently loaded is being present over here. So this is actually listing, okay, this module is currently live to use, and what are these numbers in order to explain the usage of this module. So similarly, you can, when you insert any new module, it will make a change in this file and make a new entry for that module to support by the kernel. So these are the configurations that you can see, and then you can just modify and you can insert it. So just trying to give the overview about how a kernel being loaded and see stuff. Then dmessage command basically helps to check the logs. So okay, unable to locate this package. There might be some other package which dmessage support. Okay, I think ms. Let's see this. Yeah, spelling was there. So once you use that utility dmessage, it loads the kernel logs for you. So so somebody who is basically more interested in how does a kernel functioning, and if you load any module, what is happening under the hood. So if you remember the logs that we spoke in generalctl or syslog logs, so similar to that, for kernel logs you can either use -k option in generalctl to provide the kernel logs for you. Also dmessage is another command where it can give you more elaborated details about the kernel processing whatever it is doing on your machine. So this is another way of fetching the details for you. So it is basically listing me, okay, it has found iPhone camera devices. So whatever the operations that I am doing on my machine, it is being stored here, and because those are the ones which are related to kernels, because as I spoke, it has a various set of drivers. So any USB which is detected, it will identify that, any devices or any drivers or anything. So you see it has identified parallel virtual mouse is also being used on this machine, because I'm using keyboard mouse, so that's why it has been listed over here. So all the hardwares and stuff, kernel being read by the kernel, and then it can just list down the devices, whatever it has found and the functionality. And if there are any issues with those devices, it will basically create the logs for that. Okay, these are the problems detecting those devices. But again, so these devices are being supported or found by the kernel because it has the module loaded to support that. See, it is just saying about starting systemd journal services. So this is what you can just calculate, get the kernel logs as well by using journalctl. So that is what the daemon, journald daemon, which basically stores that information about loggings and stuff. So dmessage is a good command where you can try to get the kernel related logs. So these logs are more of about you see the protobufs and protocols and stuff. So this is basically capturing all sort of information, whatever it is doing. So this is I think UFW. We remember we talked about UFW and IP tables firewall blocking. So some rule blocking rule that has been implemented until it is being provided or passed on to the kernel, things will not work, right? So kernel also understands each and everything whatever you're doing on the Linux machine. So UFW block rules that we have been testing throughout in our series, it has been listed down all of them. Okay, this is what the changes happened. Then some auditing logs also you can see for this particular process. Some process it would have been trying to do, and then something it was not able to perform, some denied problems occurred or something. So any sort of entries that you can see, these are nothing but kernel which is providing us all this information. So first process ID which is of kernel itself, that's why you get that. Yeah, so it gives us very good visibility in terms of identifying any devices or any issues with those devices in terms of loggings. Then there is a utility called sysctl. Sysctl basically helps us to change the configurations for the Linux on the fly, real time. You can just make a change whenever you are updating any set of configuration. So you can use sysctl-p and stuff. So there should be, or there might be some other utility which is linked to the sysctl daemon, and then can tell us the information. Okay, it's not there. Sysctl. Okay, some other utility which is responsible for this package to work. That's why it's unable to find that. Anyways, but yeah, sysctl is a utility which you can use once you download that package, and you should be able to use it. So that can help us to load the modules, make any changes in the modules, that whatever the changes that you have done related to kernel, you can update those settings on the fly. So it can help to tweak those parameters at the runtime in a way. Yeah. Then create a list of module dependencies. I hope this command is there. So dep mode command is there. Basically, let's read about this command. So it will create all the dependencies, whatever the dependencies, in order to load a module. It will list down the dependencies. So as you remember, we spoke in our previous chapters that dependencies, when we spoke about packaging and stuff, so dependencies are nothing but a single package cannot be always there for any sort of application, right? There are multiple dependencies tied to it. So those dependencies are fulfilled, then only the main package will be supported. Similarly, for kernel modules, also the same case, where there are multiple dependencies in that situation. So this command helps us to identify dependencies related to those modules, and then can help us to identify problem and help us to further modify or load the kernel module. So these are the good amount of utilities and stuff that we have seen for the kernel, and you should have a good understanding about at least how do you manage the kernel, what are the kernel drivers, how do you see the logs, how do you insert a module, and how do you blacklist a module if the module is no longer being supported or some other alternatives has been invented for any sort of modules, right? So those are the things you should be having some awareness. But furthermore, there are a lot of information that you can dig in terms of kernel, kernel modules you can write. If you are good with writing as well codes and make changes, you can be part of the community, can give your own contribution, make a change. So things like that can be done. So I hope this chapter can give you some idea about the modules. Kernel works based on the modules, and how do you see those modules, how do you get the information of those modules, and how do you load it and blacklist and stuff like that. Yeah, so that's about the modules in the kernels. All right, so now let's talk about the performance tuning basics in the Linux systems. So when I say performance tuning, what are we talking about? We are talking about the performance of our hardware, the performance, how the application softwares are running, how do you manage those performance, how do you make sure you evaluate the best performance and best suitable conditions for the application softwares to run. So admin should have knowledge about how do they tune the performances in the Linux system. So there are variety of tools which are available. You might see that we have come across when we were talking about disk management, CPU management, and memory management. So that is nothing but a way of tune your system, the performance tuning you do. So we'll be discussing about that today in this chapter. And then we'll be seeing how do you do the network tuning, how do you swap the memories tuning, and how do you see what kind of memories are being coming up and going out. So a few tools you will see, they are like overlapping what we have already being discussed, but yeah, it's part of the performance and tuning session, so that we'll be seeing now. So just to start that, we will see. So let's talk about some tools in terms of CPU performance and optimizations. So for example, you can use command top that we have seen before as well. So top is a command which can tell you the real-time situations of your system. When I say real-time situation, what does it mean? Currently, whatever the process which is running on the machine, you can see the list of those processes, and also you can see the number of percentage of CPU it is basically using, or percentage of memory it is using. So you will see all that. And apart from that, you will see what is the priority of a process, and you can tweak the priority accordingly depending on your use cases. And what is a process, and for example, like you can see it here, we are seeing it, the machine is currently up for last 3 days. Okay, one user is currently logged into this machine. What is the load average, which is 1 minute, 5 minute, and 15 minute load average on your machine. So, and then number of tasks which are currently running, sleeping, and zombie, and stopped states. Then you will also see the priority, the percentage usage of your process for the user state or system state, and ID wise as well. And then similarly about the memory use cases for swap memories or physical memories on any process. So this will tell you kind of a real-time logs. You can think like real-time awareness of your process or tasks which are being currently running on your systems. And then, for example, let's say there is another command htop, which is kind of a more visibility in terms of colors, and more further granularity in terms of checking the process listings and stuff. You can check via htop command. Here you can basically sort or search. Let's say there are function keys. You can search, let's say if I search init, so it will highlight the process to me. So you can do more analysis with the help of further tools, let's say searching or sorting, or you can change the priorities. So you can see in the below there are function keys F1, F2, F3. So those are the keys which basically help to identify what do you want to see here. You see the setup, search, filtering, then you sort and change the priorities, or if you want to kill a process, so you can say F9, so it will basically open up the signals that you would want to pursue. So currently you can see there are total 64 signals available on the Linux machine at this moment. So if you remember that we spoke about kill command in our previous lectures when we were talking about process management. So we used option kill -9. So that is basically a forceful kill. So under the hood, that kill -9 uses sig kill. That's a signal that is being passed, or you can say interpret, to the kernel, and then kernel immediately kill a process without asking for any approval stuff. So those things you can see, and the visibility or articulation in the form of good graphical and more readable format, like how many tasks are running and threads, CPU threads which are currently running, you can see it up here. And load average also. So 1 minute load average and 3 minute and 15 minutes. So for example, let's say I'll explain in this way. Let's say there is 4 core machine, okay, which means there are 4 cores of CPU available. And if I say current load average is, let's say for 1 minute it is 90% or 90% utilized, that is fine, still fine. Or 5 minutes it's, let's say, 110, and 15 minutes it's, let's say, 97. So there is no need to worry, because with the time, if you see 5 minute and 15 minutes load average are comparatively less. If it is, let's say, you have a 4 core machine and you have a load average of 400, which means that all 4 cores will be used. But if it goes beyond 400 in a 4 core machine, it's something that you have to think of. But if 15 minutes says load average is 400, which means it's okay, because it will work, it will process things. Might be a little slow, but it will work. But for what if the load average is 800? In that case, it's like double of what your capability of CPU to pursue or take the threads. Then it means something has to be worried, because in coming 15 minutes there will be more process will be there in the queue, and the way it is going, definitely in the future of 15 minutes it will make a problem for the system. So that you have to think of. Similarly for 5 minutes area or 1 minute area. So if it for 1 minute, if it is, let's say, 100, it's fine. If it is beyond 100, which means like, or 400, it's for a 4 core machine, yeah, it's something, it's fine. But if it is double or more than that, it's something problematic. But for a long duration, 5 minutes and 15 minutes, if it is really double of your capability of your core, then you have to think something, because in future also in 15 minutes there are chances that more queue will pile up, and then the process will not be able to sustainable in terms of the current usage of or of our CPU or infrastructure, whatever we have availability. So these are the terms which are being useful to manage a system, and using commands like top and htop can help you take care of your system and tune it when and where required. You can kill a process if you realize that something which is not relevant, or you can you can take it forward. So those are the things it gives you facility to see. After that, like as we spoke in the previous chapters also, you can use command ps that can list down the process. ps aux will list down all the processes which are running, but not the real time, and you can further grab the process and check the priorities. So those are the things that you can do in terms of process CPU performances. If we talk about memory stuff, so there are tools like free. Okay, so free tool you can use to see the memory which is currently available, and to make it more human readable, you can use -h. So it gives you in gigabytes instead of bytes. So currently this much memory we have physical RAM allotted for this machine, and currently out of 2 gigs, 1.4 gigs are already being used, and 107 MB is free. And similarly the swap usage, which is nothing but kind of hard disk, the hard drive usage, that's what the swap memory is all about. So the pages basically change from swap memory to the physical RAM. This much is currently used and free. So looking at this, this is like very small machine of having RAM which is 1.9 gigs. Usually servers has 64 gigs or more than that, 128 gigs or 256 gigs, out of which if it is 90% utilized, definitely you have to think of that, okay, it is 90% utilized, there is a warning that admin will get, and then furthermore they have to make sure that remaining 10% buffer should always be there. If the process memory goes beyond 90%, then immediate action has to be triggered. So that's how the alerting part comes into play, where when we talk about performance tuning. So that's what the DevOps and SRE's role. Just to make sure the infrastructure, whatever is running, with the help of these commands, can analyze the current state of your memories and CPU. And then they can get the errors, they can get the notification on their whatever the monitoring tool they are using, and after that they can make modifications or whatever the necessary steps are required in order to make the memory or CPU free. Okay. After that, VM-stat also we discussed before, where it tells about the process memory, user CPU usage, system ideal usage. So here, like for example, CPU is usually 95% ideal, which means it's fine. It's running ideal conditions. If it is overloaded or overburst, then in that case you will get the warnings, or you can set up a warnings, and something that actionable is required after that. So, and then what are the bytes which are coming in, coming out, writing into the disk. So those are the things you can monitor via VM-stat command. And to know more about what VM-stat does, you can anyways anytime refer the manual of it using man command, and then it will list down the active inactive memories or forks or slabs and stuff like that, partitions and disks. So that is how you can read about each and every columns or the representations of the output that you are getting. For example, like this procs, this R, what does it mean? Runnable process, So you don't have to remember that actually. Okay, what does it mean all the time? With the time, the use cases, whatever it comes through, you can anytime refer the manuals, and then you can get the output to read about what does this thing mean, and you can understand and take it forward after that. So that is how you can use VM-stat, and then free command just to analyze the CPU, analyze the memory usage on your machine, and you can tweak after that. Similarly, if you want to check the performance of your disk input output, so you can use command iostat. Okay, let's say for 5. So this will list all the devices that you have, and kind of percentage of input output operations which are happening on the disk. It will tell you in more detail actually. So this is like user wise, average, nice, priorities, system wise, IO weight or ideal conditions. So currently look at this percentage which says 95% it's ideal, which means it's fine. Average CPU ideal, if it is 95%, that means 5% only it is using, so nothing to worry about. But what if this reduces to 2%? That means 90% of your CPU usage are being happening. If it is a 4-core machine, 400 load average 400 is almost being used or stuff. You can just take actions after that, and every 5 seconds you will see this will be updated. So this option -x does the same job. If you want to read more about the manual of iostat, it will tell you basically what it does. It basically checks the stats of your CPU input output for the device and partitions. And let's look for -x. So it will give you the report, extend stats, whatever the stats that you would want to see. And then you can check for what display you want to see the stats and at what interval. Let's say in this case, this will give me the stats for SDA every 2 seconds and SDB every 6 seconds, something like that. So let's try to execute this command. I hope we have SDA and SDB both. So for SDA, it has given me, if you look at here, every 2 seconds you will be getting that for SDA. So it will keep on updating, and 6 times it has given me. 1, 2, 3, 4, 5, 6. So that's how you can monitor. Let's monitor for our disk SDB also. So it will give the device area QSZ. whatever the marking is available on the system, it has given me all these details. So that's how you can check, okay, this disk is also ideal, where it's fine. I mean, it's not doing too much of writing on your disk. So for example, like these kind of utilities are helpful in terms of databases, where or let's say any analytics tools, for example, Kafka, so which basically writes quick, very milliseconds of partitions. In the partitions they write topics and stuff, right? So it does very too much, let's say a batch of 10,000 in seconds, so it is just process and write too much of disk. So in that case, there are chances that the compute power that you are using for your CPU, it can be overwhelmed, where it is not ideal 95%. It's like always overburst, where these are writings are too much. So in that case, admin has to either increase the disk. If you're using AWS, then you can extend it, or you can get the on-demand stuff. So those are the actions. There are various action in terms of cloud computing also, or if you're using any on-premises, then you have to additional add the storage and disk to make sure that input-output operations performs, and the performance should not get affected because of that. So yeah, so these are the utilities that can help you in that situations, where you should be having awareness about these utilities. Okay, when and where required, you can use these utilities and get the stats about your IO for the CPU. So that is how you can capture. For network, there are some utilities like if top is there. Yeah, so this will give more detail about your network relationships in order to transfer the connections and stuff. So you can press H. So this will display what it does. Actually, it's very good utility. It can tell you how do you toggle the DNS resolution if you want to toggle it, whatever it is. Let's say if I press N, so this will be off. If I press N again, it will be on. So it will take the stats, print out in front of me, and then tell about DNS operations, or any network sort of things, on the socket, TCP, IP, whatever, right? UDP. So this will actually calculate that in that term. So if we say source, so there are multiple fields and columns actually. So there are like source, destination, then how much bytes it is sending, which is a TX byte, and how much bytes it is receiving, the RX byte, and how much is the total byte in terms of network it is being transferred or receiving, and transferring it. So if you calculate, just add up these two values, you will get 1.14 kbs. So you get all these details here. Then how much is the total bandwidth available on this machine in terms of networking things. Then cumulative total also, it gives you that information. So in the if you look at like in the leftmost column, so you get like average bandwidth usage over last 2 seconds. So this will tell you that bandwidth stuff, whatever the bandwidth you're getting currently. And if I, let's say, access something, or let's say Google, so it will capture all these information actually. See, it is capturing me that I am doing some, this is my source IP address, and from my source IP address I have tried to access some Google contents and stuff. So it will capture all this. If you don't want host name to come up, so you can press H and toggle that DNS resolution. So in that case, what will happen is, if you refresh this page again, so you will get IP addresses, or DNS resolutions will be toggled. Let me switch it off, and instead of that, toggle show destination and host, or D, hide destination host, so it will not display that destination host to you. So you can just play around with it, and there are options that you can use it. For example, like port also, if you don't want to see the port, you can just say capital D. So the destination port is disabled, and you see the changes here in terms of byte, because you are doing some sort of searching in terms of network stuff. So it will basically go up. And let's do one more time. Let's do this. Yeah. So this will actually, it can help you to identify the traffic or the packets which are going on the internet in terms of networking sockets, what it is actually doing. So all these things you can see it up, and then accordingly you can, tweak it actually. And you can just pause the display, port display on. So which means that, you know, this will tell me the port number, whatever it is using at the source side. Capital D, port display source. Capital D, port display on. Okay, then source column, hide source host. So once I press S, it has hidden that source host, because that's not required in front of me, because I already know this is the machine and what is the IP address of this machine. So I don't need that information. Rather, I need the information on what protocol this is using, HTTPS, okay, the traffic which is going up over there. And let's access something else, github.com or something. So this will tell me github.com, you have reached here. What is the CDN content delivery network it is using? How much bytes are being transferred and received, and in total bytes and stuff. So you see all these rates and utility kind of help you to analyze the network related performance. You can just use it. Yeah, when I press N here, it has stopped the doing resolution for me. It is just directly giving me the IP address rather than host names. So earlier it was just, doing the resolution, but now it has stopped. So it's not, it's just giving me just the IP address instead of the host names. So that's how you can analyze as an admin. Also, you can just verify. You should be aware about there is a utility called iftop, which can help you to analyze the network things, and then you can read through that. Let's say manual. So it tells the bandwidth usage of at any interface by host, and this is the use case, like the common use case how you use this command actually, iftop -h. Then there you can filter based on interface. Let's say enp0s5. So this will only print that interface. Listening on enp0s5, it came here. What if I say ETH0? Then it will not come up anything, because there is no device interface at this moment. If I say IPA, I will only see these are the two interfaces of networking available on my machine, on which any sort of networking operations or transfers are happening. So yeah, so you can just review all these options which can print things for you, and then you can just use it. Yeah, it is explaining actually what it displays in terms of data and what it caters to, these arrows, what does it mean? This is like transferable, like it is going from source to a destination. This is coming from destination to source. Like when you download anything, when you try to fetch things, you get details about, let's say if I refresh it and then if top. Let's refresh this and then go up here. Yeah, so you see these arrows. This is the traffic which is going 0 bytes. Okay, coming up, how much total bytes, then again going, then again coming. So this is kind of a good utility in order to track the transfers which are happening between two parties, client and server, or two machines, you can say. So those things you can capture. So what if there is any internal interface which is available on any server, which is used for some internal tunneling and to a particular machine, but you're trying to send some signals to another machine and the machine is not able to retrieve anything or not being sending the acknowledgement back. So this utility can help you to identify or troubleshoot or why the traffics are not going. Really, you can, if you're not able to see any traffics coming up here, which means that something is wrong with the machine settings or configurations, that you can change and then make it corrected according to the use case. Yeah. There is one more option, skip the, so with -n itself you can just skip the domain name resolution before. It will just give you IP addresses. So you can open like this also before, or you can change it here also. Yeah, with pressing N keyboard key. Okay, or you can just provide a N-N here. So yeah, so this tells, okay, when you execute and end this, it says on this interface, which is having this IPv4, IPv6, and this is my MAC address. That's how you are able to see the information. Okay. Now let's talk about CPU tuning. So CPU tuning is about like how do you manage the CPUs in terms of setting the right priority for the processes. So there are a few commands which are basically used. One is nice and renice. These are the commands which are basically used for setting the right priority for the processes. So you can just say, priority, let's say -5 I want to set for whatever the process ID, So let's execute sleep 1000 times backend. Okay. So this is my process running. The process ID is this. Okay. Now let's change the priority of it. Minus is like more aggressive. You want this to be completed and give your CPU first preference in order to pursue this. So old priority was set to 0, but now it's set to -5. So you can see this now. If it is showing up here, it's not showing, then we can see netstop. Let's filter based on searching and say sleep. Yeah. So in sleep, you see -5 is set here at the priority NI value. So that's how you can actually see the change, and it will come up and it will take it up. So it's tuning in the sense like you're making your CPU to tune a way that it picks up certain processes with the high priority and takes up another processes which are not relevant at this moment with the high priority. You can reduce down the priority for them. So that's how you can tune your CPUs usage and stuff. And if we say the memory tuning, so there are a couple of things. One is swap memories that we say, right? So swap memory, swappiness adjustments, how do you do that? So there is a file actually which is available, swappiness. So currently the swappiness is set to 10. So basically it refers the tuning the behavior of Linux kernel's memory management, specifically the balance between RAM and the swap space. So which means that how much swap will be used, how much physical RAM would be used, and how much hard disk would be used, and then it's kind of a kernel parameter. According to the number that you are providing in this file, it will change the kernel parameter, and then it will ask kernel to make sure that you do this much of swapping in terms of memory swapping adjustment. So you can just do like that. And so basically the swap space is a reserved portion of your disk storage, as I spoke already, that from your disk, from a hard disk, you can reserve some portion of hard disk just to make that hard disk available as a swap memory. It's like a memory, but not as active or as more performatic than the physical RAM, And then the value of the swappiness is between 0 to 100. You can just make a note of it. The lower value basically makes the kernel avoid swapping as much as possible, which means that keeping the data into the RAM. But if you go increase the value, let's say 100 or more than 60 to 100, that means that you do more swapping. So when in case of more swapping, those processes which are not really required the active physical RAM to perform, for that swapping is fine. But the process which really required active RAM to be progress and then make it work, or it require utilization, in that case it's good to have the value lower as possible. So the value can vary and you can change the value by using either by editing this file or sysctl. We can use sysctl ifvm.swappiness and say if I set 50, so this will change the value of swappiness value. So if you again do cat, it will change the value, which means that it is still keep the data in the RAM, but again the behavior of that swappiness will be taken place slowly, but if you increase it furthermore, let's say 60 or above, then it will do more swapping than keeping the data into the physical RAM. Okay, and if you want to save this sysctl changes, so there is a command called sudo on the fly sysctl -p. So this will update the changes. So this is how sysctl is the utility. I think we discussed that in the last chapter. We were talking about changes on the fly that you can make in terms of modules and stuff for the kernels. So I'll just show it up here. Yeah. So this can configure the kernel parameter at a runtime. So it's kind of, there are a variety of parameters which are available. So any file that you want. So basically what we did is, like, we basically changed the configuration of swappiness. Okay, that configuration presents in a file. So once you edit the file, either by going into the file and edit it or by using the command, you have to apply that parameter as well to make kernel aware that you are making some changes in the swappiness conditions, so that according to that condition mark, whatever you have chosen, kernel will behave the same way. Okay, that means it will take it in the progress, and then according, let's say if you say 60 to 100, if you change the swappiness, kernel knows that now it has to do more swapping in order to make the progress of your any processes and stuff. But if you set it to less value, 0 to 50, like for example, then kernel knows, okay, it has to keep more, as much as data can be in the physical RAM. But yeah, again it can do swapping, but it will be very less. But if you set it to more, then it will do more frequent swappiness of stuff. So sysctl-p can be apply that parameter, modify it on the fly. So, and then the configurations of sysctl, it is telling the examples, kernel host names and domain names. It's a very basic, kind of very good utility actually to list down what it is doing. Okay. So whatever the information you're seeing it here, the same information it is telling the host name. Yeah. So sysctl is a kind of a good utility wherever you make any changes. Just now we did for the swappiness, which is the management of your swap memory, tuning of your swap memory. So you have activated those changes in the kernel level, right? Similarly, like for disk IO, also you can just make a change. Just to note for one thing, let's say if you are having a desktop or a gaming machine with 16 GB of your RAM, so good to have this swappiness 10, because in that case it has to be like more at the RAM side, because the game, there might be chances that for that 16 GB of your memory, the game can be paused or can be slow, which nobody wants to face that same experience. So it has to go through, the threads has to take care, the memory has to be in the RAM itself. So it's kind of an example I just wanted to show up, like depending on the use cases, the swappiness values can differ and can change. Now if we see about the disk IO tuning, so mostly for disk things we see the file etcfs tab. When you remember we were talking about disk management, so we discuss this file where it holds the entry of your all mount points on your file system. And here also you can change these values. For example, like you can add these values to swap it for the memories, and then do you want to dump the data or run the backups and stuff. So like for example, like there are furthermore, instead of default also you can add more. So for example, like this whatever it is mounted, this is nothing but swap. It's kind of a swap memory kind of will be using. So you can add more level of options available here. Instead of default you can have RW, read write, read only, RO you can do, or you can say there is one more called no a time. So these are the options that you can list down, which will change the behavior of it. Yeah. And then mounting only, we saw that execution or non-execution in terms of that options as well. Let me see if it holds these options actually, so that you don't have to remember. So yeah, you don't have to remember what all options are supported. So you can just go through this manual. It will tell you what defaults mean, what no auto means, not automatically mounts, or allow a user, or no fail. So it will tell you the examples, the usage of all these fields which are present in etcfs tab entries. Yeah. Similarly, like mount command also can list down what actually you're trying to mount. Is the device being labeled or not, and what is the ID of it. And so these are the utilities which can help you for the CPU tuning and disk tuning or memory tuning that we have seen so far, and file system that it would want to check for those file systems. Like there are various of file system: ext4, xfs, brtfs, btrfs, vfat, and ntfs. So these are like vfat, ntfs. These are all Windows supported system. FAT64, FAT32 based mounting of the file system that you are doing. And then you can just add up a journal level of things on top of it. Then there are something called quota management, user quota, and group quotas, basically to enable the quota, which will limit the usage for the user. Let's see if quota is there or not. Okay, it's not this utility. Let's see. Okay, let's download it, the quota. This will show you the disk usage and its limit. How much is the limit it has it. Let's see, any examples are there. Quota-u. So there is currently no quota has been set to. You can set quotas and you can change things if there is any quota which are being. So quota is nothing but kind of restrictions, or you can set upper limit, lower limit on what all options, like how much files you can create, how much disk usage you can perform, and beyond that there is a limit that you can set on number of files, number of inodes, and stuff like that related to file systems. So that is a quota can help you. So group quota also you can set, user quota also you can set. Currently there is no quota set, that's why we are not getting any responses, but you can go through these options. You can set up based on whatever the quota you would want to set, and then accordingly it will help you to set that quota. So that is another way of tune your disk in terms of usage and in terms of file file systems as well. Yeah. And after this, like network tuning is also there, like TCP window size. So if you know about transmission control protocol, which works on a synchronized basis, like three-way handshake, and it has a window size where in that particular window segments the traffic or the packet will go, right? So that window size also you can change. That kind of a tuning you can do further. So for example, there is a command to do that, sysctl-w net.core memory max. So then you can, let's say, 30. So some memories you can assign with the help of sysctl command in order to have a better throughput, which can give you more bandwidth to pass on the data. So if you have more throughput, which means that you have more leverages of bandwidth available on your machine, which can help you to traverse more traffic in terms of network. So that's how you can increase that window sizing. So here I'm just telling you a way to tune your systems. There are utilities that you can use. Ultimate aim is to make sure that system should be fine. It should be serving whatever it should supposed to serve. The application that it is hosting, web hosting or some other server hosting, it should not get affected. So these commands and utilities can help you to tune your system. So similar to this, you can set, there is a another settings, R core, R memory, maximum, and then you can set something like that. You can set the memories also. So these are the options. For if you say write, force all arguments to write arguments to print. So we are forcing these arguments, or these are the parameters, actually kernel level parameters, which you are tweaking based on the requirement. Okay, this memory maximum has to be this much and it should not go beyond that. So you can just tweak like that. So if we talk about the summary of total, so we have seen like CPU usage, we have seen memory usage, we have seen disk usage, we have analyzed how do you update the kernel modules entries, how do you change the settings using sysctl command, how do you monitor the processes using htop command, how do you see the network related logs, if top command is there, then fs tab entries, how do you set up which option to do what. So these are the variety of tools that you can use in order to make your system more performant, and you can tune your systems based on the requirements of it. Yeah. So that's about tuning and management in Linux system. All right. So now let's talk about networking troubleshooting. So this networking troubleshooting chapter will give you some idea about how do you troubleshoot if there are any network issues which are being faced on the Linux machines. For example, like let's say you are accessing www.google.com or facebook.com, or you are accessing your servers that should come up. So how do you troubleshoot that? What are the utilities that you should look for, and how do you start the troubleshooting purpose? So there are a variety of stuff, like you can troubleshoot DNS, you can troubleshoot HTTP, your handshakes process or data transfer process, or some issues with the database. Then you should review the server check. So at the preliminary stage, how do you troubleshoot that? And then later admin can help you to basically get the details about server logs and stuff. But before going to that level, you should have a basic idea about how do we usually troubleshoot the network related issues. So we'll be seeing some common scenarios and how do you find the solutions of those. Let's see the system, and then we will try to find out how do we basically try to check. So for example, currently this is my Ubuntu machine, and to check if it has a network connectivity or not. So before jumping onto the admin or before going to your vendors, you should have a preliminary checks, and everybody should be aware about basic networking stuff. So if I'm able to access www.google.com, then you should be able to get the response for ping command. What if so this is a utility, it uses ICMP packets, and with the help of that utility you can get the response if you are able to get any response for for any request that you're sending to your server. So basically it does not transfer any data, but it just can identify if the server, front end server or whatever server, right, it is active or not. It's getting the response back or not. So let's check the manual of ping command. So it is basically printing the ICMP echo request to the network host, whatever the host that you have assigned. Then you can use -4 for IPv4, then IPv6 audit ping. So there are a variety of options that you can use ping command. If you want to do a flood ping, you can use -f. It will flood the ping. Then what interface you want to ping on, that also you can make a change and settings. Similarly, like what node options. So there are a variety of options which ping is supporting. What is the pattern that you would want to specify, and so you can just check all these things. You can read through that, and then it will give you more idea about ping command. Let me just try ping -f. Just there. I'll just flood the packets on Google. Right, cannot flood. Minimal interval for the user must be greater than 2 milliseconds. So it is giving me some warning saying that it cannot flood the traffic on this. Anyways, so what if ping utility is not present? Then how do you verify google.com is working or not? Okay. You will usually check your browser and you will try to refresh the page google.com. If the page loads, that means Google is working for you. Or there is a utility called curl. Okay, curl utility can also help you to identify if the Google is working or not. Okay, if you are getting the response like this something, then curl is, which means that it is basically getting the response back for the Google page. Let me see a better way. Okay, something it has changed this time. Yeah, so see, this part is very important actually. Since we are doing curl on HTTPS, HTTPS is a secure protocol of HTTP version. So the default port is 443. Google is also using the default port 443. This is IPv6 and IPv4, which I am trying to connect to Google. Okay, this is a Google IP. All right. Now it says that in the handshake process, if it basically sends client hello, then it sends the server hello with the public key. Then they create a single key which they transfer it, and then a synchronized key from asynchronous to they create a common key, and then after that they make any data transfers and changes. So at least using some information that you're connected to Google. Okay, that's fine. Then client hello happened, then server hello. They were ready to communicate on the algorithms or the ciphers that client supports, and server also has to agree, Google server. Okay, these are certificates that they exchange all these things. They verify, oh, you are a legitimate website. How does it verify? Because it checks the certificate imported on the client side. So let me see if I can show it up here. Certificate, view certificates. Yeah. So as you can see here, right? So these are the trusted CAs which are currently available, imported in my browser. So this is the utility. Similarly for curl also, there are always, so when you update the curl utility, automatically curl utility also has a CA certificates, which verifies if a website is legitimate or not. So similarly, like these are the CAs which are currently imported by default on my Firefox when I downloaded it. DigiCert is a very big name. You can just think like Amazon also has a CA. DigiCert is digital signing. Then there are some local trust and certificates. Global Sign is another one. These are the big names, who does the CA certifications, certify the certificate for any servers, web servers. So you can see all of them are imported. And that's how the certificates are being verified for Google. So if you click on that lock icon on the browser, right? So you can see connection is secure, more information about this connection. So, and then you see view certificates. So it says common name of the google.com is star.google.com. Country is US, organization, common name is this. Then what are the DNS alternate names it is giving it, and it is telling the certificate expiry, that this certificate was created on 9th of December 2024 and it will expire on 3rd March 2025. Okay, these are the alternate DNS names of google.com. Actually, they have added DNS entries. Then public key information, then fingerprints, then certificate authority, no. Then it should be having something called issuer, key IDs, we'll see for the certificate, location, methods. So this is using OCSP protocol in order to reach to that location. CA issuer is the method. Usually says the issuer as well in the chain of certificate. So the organization is Google Trust Services LLC. So this is the issuer. So this certificate is basically available on my Firefox. That's why it is able to verify, okay, this is a certificate chain you can download and you can see the digital signatures of it. It's a certificate trusted by this organization. So that's how you can see this. And similarly for GitHub also, let's say if we review the connection security and go to more information, view certificates, and you can see like what is the common name of that certificates. Which trust is the one who basically issues that certificate. So this is the issuer who has issued this certificate, is a legitimate or not. So the organization called User Trust Network, there is a common name of this, which has issued the certificate for github.com. So without that, you will be able to see not that lock sign, but rather be something insecure or some warnings showing up here. Similarly, curl also has this under the hood checks or a capability to identify the certificate if it is valid or not. And then it says, okay, which connection you are creating on. So it says, okay, they both were agreed on this connection, TLS version 1.3, which is the latest in market, and algorithms. Okay, server also accepted that, and then it sends the certificate information. You can see all it here. And they are using HTTP version 2, which is the latest version, for Google. And user agent is nothing but the utility that you are using in order to make the connection. If I would have been using Firefox, then I would have seen Firefox, Mozilla Firefox. But this is curl, that's why it is showing you are using curl 8.5. Okay, now this is all request actually. Now if we talk about responses, so I'm getting 200. Okay, so there are various of status codes you can go through on Google. I'll just say in a brief that all 200 is basically getting a proper responses. 3xx is mainly for like you are being redirected to some other locations, and 4xx are majorly the client side problems, and 5xx are server side issues. 429 is like, for example, like rate limiting, or 404 not found. You are trying to reach to a server but wrong location, that's why it is not giving you any responses. 505, server issues. 504, so those are the things you get it. But yeah, 200 okay means you are getting a response back from the server, and this is a page of Google written in whatever the language it is, right? So you're getting that page. So curl utility also is a good one that you can use. Apart from that, I will show it up here. You can have more tools, or let's say web developer tools. So this is also a good utility actually in order to see is what is happening in the network. So you should go to the network tab, and let's say if you okay, I should start here. Right click, if you do inspect element also, you can just check. Yeah, network. Okay, I think I'm not able to zoom it, it's okay, but I'll just show it up here. So when you refresh this page, you will see the HTTP methods and requests which are going through actually, and then you can just pause it up here, and there are a variety of things that you can do actually. In the network tab, you can see the requests which are coming. You can analyze each and every request. Or you try to do a get method and you got a response 200 OK from google.com. So this is another good utility tool, inspect elements, which can help us. Let's say if any website which is not loading, you can check the console logs if there are any errors present on the console logs or not. So those things also you can just see it, right? So apart from curl and web developer tools, you want to see the DNS configuration. So there are various of commands. IPA is one command which can detail you on what interfaces which IP is being assigned. So that is like, I am using this interface only, ENP0S5. I have one physical NIC card on which this IP is being assigned on my machine. After that, IP route to analyze what is the route of my traffic to go from this machine to internet or some other machine. So this is a route, it's using this default route as a route to go. Then DNS settings also, system D -resolve -status. This command is not found. Okay. Okay, maybe this command is not there, but in some other system also maybe it works, the resolve, just to check the status of your DNS resolutions or not. Then there is a command called trace route. This can help you to trace down how the traffic and where the traffic is going actually. github.com. So this will maximum take 30 hops actually. So these stars can be firewalls also, or a server which my machine is unable to identify. But yeah, so as a website, for example, which is hosted at any location, so with using traceroute, it can tell you on what hops. Hops means a place like a router. You can think like, it's hopping the traffic. It's basically jumping from one location to another location in order to identify or find that location of github.com, which is really located on the internet, where it is located actually. So, or any other website, let's say we could easily get it. GoDaddy.com. Currently the firewalls are being in place actually, it's unable to identify. But if you try to do the trace route, or in Windows there is a command called tracert command, so they do the same job, where it basically tries to identify the hops which are coming in between from your client to the server machines. So traceroute is a command to analyze. Then after that, DNS resolution, you can check NSLookup command is there to see the resolution of Google IP. These are the two IPs, IPv4 and IPv6. The large version of NSLookup is dig command. It can tell you more details about the DNS hosting, what is the A address assigned of the servers, and host command will be like just to list down the host, like very short form of NSLookup. You can just think like, all right. Then there are files which are important for DNS. One is etcresolve.conf, okay, which is currently not there, but usually it's present. And there is a local file etc hosts, which has entries when we discussed the DNS in the DNS chapter, right? So we discussed what is the usage of this command actually. Basically this file presents the local host entries. So if the request goes from your machine to any internet provider, to let's say google.com. So it just checks this local file first if it has the IP address of that machine what you're looking for. If not, then it goes to the nearby name server which are defined in this machine, in this file, or in the resolve.conf, and then after that it basically gets the more information or the name servers that you have defined. So name servers are basically, let's see if we are using netplan to or network manager. We are using both, it seems like. So netplan configuration C. So these are the name servers, now nothing but the DNS. So if you don't find the IP address of any machines looking into etc host, you can look for these name servers entries which are part of netplan way to set up the DNS that we discussed already in the netplan when we were talking the networking managers sessions. So that's how you can find it out. So let's try to do trace route on these because these are locally hosted on my machine. So I should be able to get the hop. Okay. Trace route. Sorry. www. Okay. See, this mywebsite.com is currently hosted on my local host. That's why it's able to find, okay, this is just one hop is there, which means my only present machine on which this website is hosted, and I just got the response back. I just wanted to show you how does the output look like if you are able to find the location of it. Usually like traceroute gives a good way of location also, and there is a command called what is my IP address. So you can just check that as well. What is my IP address? So it can provide you the IP address and the ISP I'm using, hathaway.com and whatever, right? So this is another thing to check, basically which internet provider I'm using and what is the IP address it's being assigned or being used as a public internet facing. So that information you can also check with what is my IP address things. All right. What if you want to see if the port you want to talk to or communicate to is available or not? So www.google.com. So telnet is a command. Basically, it can checks if the particular port is open or not. If you're getting the response back, that means the telnet say that port number 80 is open for listening. You can just communicate or connect to that port of google.com and then you can get the response back. Similarly, for 443 also, you can just see 443 is also available. So that's how you can verify if any port which is available or not for any remote servers with the help of telnet command. Let me check. Definitely my local port would be anyways be available where my website is hosted. Telnet. Yeah, I'm able to connect to my local machine where it has basically given me the IP address by doing the resolution of name servers resolution. Okay, this is hosted on local machine, and yes, I am able to connect to that machine. All right. Then there is one more command called netcat command. You can analyze the network files which are opened and stuff. So you can do various operations using netcat actually. Blah, blah, blah. So this is how you can also check the connectivity using netcat. The what telnet is there. If telnet is not there, then netcat also can help you to check. Okay, this is currently connection is succeeded, which means I am able to connect. I can initiate the connection. Similarly for google.com also, you can just say, oh, I am able to connect to the google.com using netcat command. Then active connections, you can see netstat command is a good command, and TCP UDP listening all ports, it is telling you by using TULNP options. Okay, to print it. So it is telling these are the ports and protocols which are currently listening state, which means it is there. So these are the only connections which are currently active, which means it's very minimal, right? So usually this netstat command output is required when there is a situation where the firewall is actually, or proxy is capturing the traffic from the source machine, and then it is sending the logs, right? So at that time there are a lot of connections which are happening, let's say SQL server or syslogs, which are basically capturing lot of traffic at that time. So there are chances that all the connections are being utilized, or stale connections. Stale connections means the connections which are no longer required, but still taking the resources or consuming the resources of our infrastructure. So those connections which are not being closed after serving whatever the request user sent it, they became stale. So you have to manually kill that or clear that cache in order to make sure the new connections can establish. Because see, there are chances, let's say 60,000 connection maximum it can create. What if your syslog server is having 60,000 batch of logs is publishing, which means 60,000 connections are already there, but then after that also it is creating more connection. However, the previous connections are still not closing, let's say 10,000, 20,000, then slowly it is piling up the more connections. And then after that it is basically taking the resources unnecessary. So in that case you have to clear those connections or stop that service so that the connection gets closed, or some other way you can clear the cache of the connections. So netstat command can help us at the time to identify the connections are being opened or not. So stale connections also, and the connections really keeps that run in the run directory, which is nothing but a volatile directory, right, where the process IDs are being stored. So they store like a file. It keeps on creating one file for one process IDs, and similarly one file for one connection establishment, which are stale connections. So that also consumes your disk space. So these are the situations I'm telling the based on the experience where we come across those scenarios, and then netstat can help us to identify if the connections are still not getting closed, and then you can close it after that. Then ss command also you can use to see, okay, these are the connections currently on my local machine only. It is basically listening and connecting to the world actually. So it's telling the port number and how much received and sending requests and stuff. So that is kind of a good utilities. You can read through the manual and understand the further use cases of it. Then for traffic monitoring, unload command is not there, but there is a command called unload. Not sure if okay, it's not there. Okay. So this is kind of monitoring the traffic. If top command is another one that we have accessed in the last chapter. Similarly, unload command is another one where it can tells you on your device ENP0S5 incoming how much is the current byte transfer in terms of network and outgoing. So it can detail you all that information. So unload is another command to basically monitor the networking things. After that, like we saw previous chapters also when we were managing the network manager, that if you want to see the logs for network manager, so you can say generalctl for this network manager user, give me the logs. Currently there are no entries, which means either not being so used or not creating the logs, or the entries have been deleted. And in order to restart the network manager, so we saw systemctl command is to restart and stop, restart it and then stop it. For that you can use systemctl stop, reload it, enable it. And for netplan, sudo netplan apply, then sudo netplan try, just to apply the netplan stuff, the configurations that we set up in the netplan file. So netplan file is mostly being available inside etc netplan. Default files are being created, and this is for network manager. So when there is no network manager being used, that's why there is no other file present. Let's see if the network manager is there or not. Status. Yeah, it's active, but it is not doing anything. That's why it is not creating anything. If I restart it, maybe it will create a file and then it starts using it. But currently NetPlan is active and it is basically assigning the IP address based on the configuration that you have provided inside NetPlan. So these all things we already saw in our networking management of our interfaces. So you can go through that chapter in detail. It'll give you idea about how to set up an IP address, but I'm just kind of refreshing this here in order to troubleshoot. How do you troubleshoot the networking related stuff? So the NetPlan also comes up here. Then general CTL also can give you the idea about loggings on various services which are running or not. So common, let's say if you are unable to ping to the external sites, so there are problems. There could be a problem say related to the default gateways, that the traffic is not going through the gateways, and then it is not basically storing that information. So that's why you can get that. Or if wrong IP addresses are being assigned, then you should check for the DHCP servers. If it is working as fine, check the configuration for it, because there are chances that sometimes DHCP session servers basically does not assign the appropriate IPs that we are looking for, or some misconfigurations or conflict can occur in the services. Or if you're getting like timeout to any of the servers and stuff, so you can use SS command that we saw, right, just to analyze the traffic. Why are you getting timed out? Maybe the port is not open, or it is still stale connections or some stuff. It can happen, right? So netstat command and SS command also you can use in that way to identify the problems that has been happening in the network. So yeah, so that's about the networking troubleshooting. If we recap that, so we have seen so far, how do you identify if any site which is not working or loading. So you can check the web developer tools, you can execute ping command, curl command just to analyze. Then Wireshark is another tool, or TCP dump is also another tool to capture the networking traces. Then you can see DNS configurations, if it is present or not in the local machine and stuff like that. Then later you can see the socket which are currently opened or established connections on the machine using netstat command. Or if the ports which are not being listed or not being able to connect, you can use telnet command or netcat nc command. Similarly, netstat alternative is ss command you can use. Then for memory, for the networking bandwidths and stuff, you can use nload command or iftop command that can help you to identify network bandwidth issues or things like that. And then you can anyways time checking the IP address assignments either via DHCP if you're using NetPlan configurations, or you're using DHCP in the NetPlan or the network manager side, which side of you're using, or both. Some conflicts can occur. At that time also you can just check your networking stuff, and then you're not able to connect to the server. So these are the things that you should look for in order to troubleshoot the networking areas in the day-to-day basis. Okay, so that's a wrap up for this chapter as well as our Linux learning series. Comment below if you have any doubt, or if you would like to have an advanced course on Linux. To get globally recognized certificate and upskill in Linux, you can check out our DevOps course. The link is given below in the description box. Till then, keep learning and growing. Signing off, Himanshu.